Good morning to you all. It's good to see you all here to discuss today's topic, where is shipping heading in the next decade? Decisions regarding major issues governing the operation of ships not only have to be made, they have to be implemented as the industry sails through one of the most challenging phases ever. Only with access to top quality information can shipping people keep up to date with the ongoing developments in a constantly changing industry. Further, the information has to be practical. We at Newsfront Naftyliaki believe this summit will not only provide information on tackling the ever-evolving developments, it will lead to discussions about the challenges faced and their impact from a practical and even legal point of view. This is the 15th summit Newsfront Naftyliaki has organized under the auspices of Martekma. We all know Martekma is an association which gathers under its umbrella some of shipping's most innovative and practical minds from both a technical and managerial point of view, and as usual, Martekma has been a guiding light in putting together today's program. As I said, this is our 15th Greener Shipping Summit, so we have been focusing on greener shipping for some time. So have others, and they are the ones that make up our strong group of sponsors and supporters. Indeed, they are the backbone of these events, and without them, the event would not be possible. They are listed behind me and in front of me: ABB, ABS, Acceleron, Bound for Blue, Bureau Veritas, DNV, Irma First, Hempel, Jotun, Lloyd's Register, MAN Energy Solutions, Marichem Mari Gases, Metis, Naftosol, Ocean King, Rina, and Shell Marine. Now, as you can see from the program, we have a strong lineup of speakers. Some of them you already know, and some you will soon know. Unfortunately, Panos Laskaridis, who would be our keynote speaker, is not with us today, as he has COVID. I would like to welcome John Platsidakis, Honorary Chairman of Intertanko, who was kind enough to accept our invitation in such a short notice. Thank you, John. We have a tight schedule, and before I hand over to Summit Chairman Stavros Hatzigrigouris, another leading voice in how ships should be operated in today's environment, I want to say these events would be nothing without you, the delegates. I hope that by the end of the day, you will be in a better position to enter 2024 and embark on the long road beyond. I would also like to inform you that Greener Shipping Summit, New Technologies and Education, which was launched for the first time last March, and it was a very successful event, will be organized again by Newsfront Naftyliaki under the auspices of Martekma in June 2024 during the Posidonia Week inside the venue. Details about the event will be sent to you in due time. Again, Newsfront Naftyliaki and Martekma welcome you. Stavros, let's get started.
Good morning, everybody. As Natasha said, it's the 15th conference, which is a bit impressive. I don't know many other conferences in Greece that have gone so far for so long. We have 19 speakers, plus Yannis as the keynote speaker. We have 4 panelists, and we have 4 different sessions. I want to thank Yannis for accepting to be the keynote speaker. I want to thank the moderators, Mr. Yanzikis, you have 2, Mr. Adam, Mr. Fradelos, and Mr. Kourkoudis of the last panel session. I bought a hammer yesterday, but I forgot it in my car. Panayoti, if you can bring it to give it to the moderators. Let's wish for the success of this conference. It's already successful. Somebody was asking me why my conferences are empty and the Naftiliaki conference is always full. It's not full. People wake up late. But okay. And Harris, if you want, you are the first moderator, if you want to start.
I want to thank also Naftiliaki for entrusting me with the moderation of the first session. We are here to try to understand, try to decide, try to make things more clear so we move forward. It's not an easy task. The technologies, the fuels that are there are not mature fuels. The technologies are also not mature. So this is what we are going to discuss first of all. And Mr. Platsidakis will be the first one who will talk about it and give us his insight about the future.
Thank you.
Mr. Platsidakis, thank you.
I have my glasses, but only for the recording. All right. My name is John Platsidakis. I'm a poor substitute of our good friend Pandos Laskaridis, so please be patient today. Mrs. Vasilaki and the team of Newsfront Naftiliaki, thank you very much for your kind invitation to be the keynote speaker at today's Green Shipping Summit 2023. I hope and wish you will not regret it. Distinguished participants, dear friends, good morning. If you had to wake up early this morning, I apologize for it, although the agenda was not my making. I was asked to talk about where is shipping heading in the next decade. Although an easy answer is, who knows, and off we go, I will dare to make some remarks, and for the next few minutes, we'll try to replace the Oracle of Delphi, which unfortunately closed down quite some time ago. Since 1980, when I was indirectly acquainted with shipping as a shipping banker, and since 1989, when I was engaged professionally with shipping, I appreciated the fact that shipping does not and cannot have a substitute in the future. In fact, it is highly difficult to imagine how other means of transportation could facilitate the transportation of something like 90% of world trade as efficiently in terms of cost and safety as shipping does. So I felt comfortable with my future career as a start. You can imagine how I would have felt had I been in, say, the fax machines industry. Because of the dominant role of Greek shipping in world shipping, and by shipping allow me to refer to ocean-going merchant shipping, I will focus on the historical trends of it. I do not want to go back some 10,000 years ago when, based on scientific evidence, there was maritime trade in the Aegean, as you know, from Milos to the Peloponnese, or the years of the exodus of Greek ship owners, being merchants as well, at the same time, who inhabited the Mediterranean Sea, from Marseille in France to Mariupol in the Black Sea, but will focus on the recent 100+ years, when it transformed itself from sails to steam power to its status today in a highly efficient and successful way. Over the years, Greek shipping followed the evolution of the technology and adopted to the demands of world trade. A very distinct example is the initiative in 2003 to get into the LNG vessels, a segment where the Greek ship owners were entirely absent. And one of the most distinguished reasons for that is my very good friend, Stavros Hadjigrigoriou, who was fundamentally this kickoff for the company. We both worked at that time, and also for Greek shipping. Nevertheless, within a few years after that initiation, some 35% of all LNG vessels under construction were Greek-owned. And today, they represent 23% of the world LNG fleet. Similarly, they control 12% of the world LPG fleet and 16% of the world merchant fleet. In other words, adaptability is the key word. The ability to read future trends in maritime trade and adapt to them. An additional factor has been the so-called hands-on management. In other words, the focus of the owners on the day-to-day status of their ships in terms of performance, maintenance, crewing, employment, etc. In other words, the effort to know the very little details of their own vessels. But where do we stand today? We all observe a fast enhancing technology which is affecting not only the way business is done, but also the day-to-day life of the individual citizens. Inevitably, this technological evolution will come to shipping and will affect the world maritime trade, i.e., the way shipping operates and the vessels themselves. Please count this as concern number one. In parallel, the protection of the environment, in other words, the addressing of the so-called climate change is, I will argue, at the top of the agenda of our society. Every sector of the economy has to take it into account, and certainly shipping has to do so. In terms of the protection of the environment, I would say that shipping is guilty until proven innocent. What I mean by it is that shipping has received heavy criticism as a major polluter, although the transportation of 90% of world trade by ships emits only 2.3% of the world CO2 emissions. I believe this is an unfair criticism, which I attribute to the fact that ocean-going shipping does not have the political clout and support as other sectors of the economy, of the world economy, do. For example, the airliners or the beer producers. So the burden on shipping to improve its CO2 footprint is excessive, and this burden is put directly on the vessels and not on the users of the vessels, i.e. the charterers, who make the decision of where the vessels trade and at what speed, the latter being a direct factor of CO2 emissions. This is the result of the fact that the regulators in general have a very shallow understanding of how shipping operates, together with the lack of political weight, as well as that far too many loud NGOs, non-governmental organizations, are around. The shipping community was very sincere when it said that it will comply with the imposed targets for 2023, 30, 2050, etc. With respect, though, I will say that a communications error was made when we said we will comply. It gave the impression that we admitted guilt, and therefore we will try in the future to minimize our air pollution. It would have made a lot of a difference and would fairly represent reality had we continued by saying, provided that the other players do their part, meaning that the charterers, the shipyards, the engine manufacturers, the bunker suppliers, etc., should do their part of this effort too. Anyway, what is done is done. And we have to imagine what the next environmental scenery will be. It will be a trip to the unknown, as shipping is the end of the chain. Unless the other parties decide what bunkers should we consume, unless our customers decide how they want to operate our ships, unless the charterers decide to pay for the additional cost of meeting the CO2 targets, and methane being one of that as well, and more important of all, the very same consumers, i.e. the other end of the chain, realize that they will have to bear their substantial associated cost, we will be navigating without a compass. Count this as concern number two. Those two factors are the ones I put more emphasis for the future of shipping. First, we need to stay close to the ships and not become passive investors, and second, to adapt to the new environmental status. Nevertheless, I personally feel very comfortable that we can meet those targets and that there is a bright future for shipping. Ladies and gentlemen, I have very great news for you. Here I conclude my presentation, and thank you very much for your kind consideration. Thank you.
Thank you very much, Mr. Platsidakis. That was a really nice speech. We will start the first part of session number 1. Yesterday during dinner, and thank you very much, Natasha, for the nice dinner, I had a discussion with the speakers regarding their idea of where shipping is going. How do they think they are going to assist with their products the shipping industry? There were no real good answers. What we are doing is we are navigating to a future we don't know. But anyway, we are here to hear what they have to tell us, what products are available, what products will be mature in the coming years, and what do we have to do in order to succeed, not only in a financial way, but also in an environmental way. So the first speaker would be Mr. Mikael Jeppesen. He's the promotion manager of MAN Energy Solution, and he's going to talk to us about heading for zero carbon shipping with MAN ES ammonia engines. Michael, the floor is yours. 15 minutes.
Thank you very much.
And I have the hammer here as well, so make sure you do it.
Why do they need promotion? They have a 85% market share.
They want to increase, perhaps.
My name is Michael Jeppesen. I'm promotion manager from MAN Energy Solutions. I work out of Copenhagen and have been doing so for more than 30 years. And I think this is my 10th time at the Greenest Shipping Summit. And on the behalf of the company, I would very much like to thank the organizers, Naftaliaki and Newsfront, for again inviting us to this grand yearly summit, the Greenest Shipping Summit. Is there a possibility that I can get the presentation on my screen here, on the monitor? Or, oh, it's there, okay. Anyway, after a little bit technical difficulty, I would like to welcome you all and start with my presentation, heading for zero carbon shipping with MAN ES ammonia engines. So I will spend approximately 15 minutes for trying to explain briefly about the status of the ammonia engine development in Copenhagen. We are proudly announcing a new era in shipping, and back in July, this past summer, we have announced this breaking news. Combustion of ammonia constitutes a major milestone in the ammonia engine development. So we are looking forward now, but before we can look forward, let's just look a little bit back to the knowledge foundation which was available by the summer of 2023. At that point, the academic research was only limited to some lab conditions, and very few results actually existed on combusting ammonia. The assumed ammonia anticipation for this chemical was that as a fuel, ammonia is actually very poor. It is very reluctant to combust, and it is burning very slowly. But in fact, this is quite suitable for the two-stroke engine, which is a slow-speed engine. Poor ignition and incomplete combustion was the anticipation, and also during Otto cycle operation, it would even have the misfiring risk and also incomplete combustion and a large ammonia slip. It was also anticipated that the ammonia has a very challenging emission profile, slip of unburned ammonia, a challenging level of NOx emissions, and nitrous oxide formation, which actually has a global warming potential of 298 of that of CO2. On the right side of the slide here, a little bit about the safety and handling of ammonia. Ammonia has an unacceptable odor, and it can be smelled only by 5 to 50 ppm. And it is toxic to a lethal risk at 5,000 ppm. Handling, it is produced globally in excess of 200 million tons for the fertilizer industry, and it is known from the ammonia tanker trade. Ammonia handling is significantly more challenging than that of LPG and methanol. And finally, there's no venting to the surroundings permitted. And the classification societies have not yet unified to create unified regulation on this issue. MAN Energy Solution, we are developing the engines based on looking into the future and also based on market demands. And it starts by some ideas and concept, knowledge gathering and so forth. We compare different assumptions to the known technologies and make simulations and tests on prototype rigs and so forth. And the extensive R&D cycles ensure component maturation and overall concept perfection. And this we have been doing over and over again since 2019, when we started the development of the ammonia engine. We have actually done 72,000 R&D man-hours so far, and it is equivalent to approximately 48 man-years. We have applied for 37 patent applications. We have 4 additional applications in the filing process right now, and so far 6 patents have been granted. And we are striving to deliver the first engine to a Japanese shipyard by the end of 2024. And we can already at this stage say that this is the most thought-through technology ever going through for the history of MAN Energy Solutions. So it will be a very well-engineered and unique MAN B&W ammonia engine. The status today is that we have been running our test engine on 1 cylinder with ammonia since July, with promising results. The diesel cycle combustion process is verified. Ignition and combustion works well. Combustion stability is good, and the engine power layout is similar to that of other diesel cycle technologies. Pilot fuel amount seems reasonable. We haven't measured it yet. And the emission profile is also reasonable as it appears so far. Just to show some details of the combustion chamber and the curves, we can see here that it is very stable both at 50 and 100% load. We have on the left the cylinder pressure in this cylinder 4 where we are operating the ammonia, and we have the mean indicated pressure and the max pressure to the right. And when comparing to other low flashpoint fuels. Here, in this case, we are comparing to methanol. You can see that the ammonia picture is very stable and much alike to the methanol burning. On the different consumptions and emissions, we can say that the pilot fuel consumption is similar to other liquid gas injection engines. The NOx emissions are similar or even lower than the reference diesel or operation on MGO, which is taking place on the 3 other cylinders for the test engine. The emission of unburnt fuel is considerable, but we plan to balance this ammonia slip and the NOx emissions by removing both with SCR technology. The nitrous oxygen emissions, they show very, very low levels so far. We have been doing an intense development of the auxiliary system, and when this finally finished in July this year, we succeeded in doing problem-free bunkering. You see the truck here in the picture is backing into our bunkering facility, which is on the second picture also, where the truck is doing the bunkering. We have succeeded to develop everything in a very good manner, and everything is working. We had, though, on one occasion, we had a leakage, ammonia leakage inside a cabinet in the bunkering station, but this turned out to be something that we could contain inside this cabinet, and it has been safely handled, and it was neglected. This is a picture of the property at the test center in Copenhagen. To the left you see the test building, and in one of the frames there you can see on the left this is where the test engine is situated. We have 2 test engines in Copenhagen. Just to the right of it you have the fuel valve train, and on the long part here we have the specific ammonia high pressure supply line. We have the supply and recirculation system and the water seal system in the middle of the picture, and then to the right we have the ammonia bunker facility. On the design development, we can see the specific prototype version of the 50-bore test engine to the left, and to the right we have the model of our test engine at Mitsui in Japan, which is being built right now. You can see considerable differences. There's 3 fuel booster injection valves versus 2 on the 50-bore test engine, and we have upgraded the accumulator amount to 3 pieces from 1. Looking at the ammonia catch system and the water seal, the left side is a sketch of the system as it is built in Copenhagen and on the test facility, and the right side is the further development, a 3-stage water seal where the exhaust gases are entering into, and clean water is entering into one side, and ammonia water to be disposed afterwards on the left side here. We are having significant focus on the various areas, and of course safety is the key to everything on the ammonia engine. So we have participated and completed at least 10 hazards so far, with different involvement from large stakeholders and classification societies. We have some testing being developed for SCR, for the emissions. We have the issue with elastomers. The O-rings for the engine is not complying. It cannot be accommodated for the ammonia engine because it is toxic and it is corroding the elastomers. That has been solved by a new product. Corrosion of materials have been already solved by the industry by adding a little bit water into the ammonia. And then the catch system, an ammonia catch system on the auxiliary system has been developed also with success. Cylinder condition testing is ongoing, and also combustion is ongoing. So far, it is looking very promising. So here we can see on the right side the SCR unit, which has been developed by and delivered from our colleagues in Augsburg, MAN Energy Solutions in Augsburg. And the specific SCR unit is being installed right now. A model in the middle is specified, and materials are ordered for this installation. This will hopefully be completely installed by the end of this year, and the testing will be commencing by then. This is showing the development schedule for the ammonia engine. As can be seen, as I already mentioned, we started in 2019, and we are today very much in progress for the 2023 schedule. And we can say that the development status is on track. And by the end of 2024, we are convinced that we will be able to deliver the first engine. This is the Mitsui test engine that will be a commercial engine which will be delivered to a Japanese shipyard. So for the ammonia engine, the responsible market introduction still remains, but we are already very far in the progress. We have positive results from our test program on the test engine. We have a few pilot project partnerships available now, and a handful of engines will be in service by 2025 and 26. And then after the positive seagoing service experience, we will do the final market introduction. And to put it in another way, or in another slide here, you can see that the development and the delivery of the first engine in Japan will be done by the end of 2024. 64 pilot projects in service by 25 and 26, and upon the positive seagoing experience, we will market the full sales release. So this is the conclusion of my presentation. Thank you very much for your time.
Thank you very much, Michael. Excellent timing. A nice presentation. We are going to move to the next speaker now. Next speaker will be Mr. Christoph Rofka. He is the Division President for Medium and Low Speed Products for Accelleron. And his presentation will be Next Generation Axial Turbocharger Fit for the Carbon Neutral World. Mr. Rofka.
Thank you very much for the kind introduction. And yeah, thank you very much for having me here. It's the first time for me and a great honor. You might have recognized that I have changed the title to Accelleron's Evolving Low-Speed Offering Portfolio, because I'm not talking about a conventional individual turbocharger development as we used to do it over decades. It's more about, let's say, a set of development or development streams, in total 4, where then the combination or the benefits and the value proposition is a combination thereof. Now I will start to give you a little bit of context why we have changed our approach to product development, then an overview of these 4 major work streams, and then we go one by one a bit more in depth, and at the end we will see then how they are linked together and create hopefully value in our joint journey towards decarbonization of shipping. When we started the development thought process 2 years ago, I mean, the decarbonization journey of shipping was still very early on. And the only certainty was there are tons of uncertainty, and it is still so. So we have to deal with a lot of uncertainties going forward. And if we look back how we used to develop turbocharger, I mean, was basically the requirements were quite specific, quite detailed, and derived from, let's say, evolving engine performance enhancement in terms of power density, fuel consumption, or emission. But you feel this does not fit together. I mean, developing 5 years and then ramping up 5 years in the market, with all these uncertainties forward-looking, this is a mismatch. So we had to change our way of working. And one very relevant, instead of a very detailed set of requirements, we are working on assumption, on an hypothesis. And moving forward, then we learn, and we have to build in flexibility to adapt depending on the learning and the changing requirements. And two very simple ones we had from the very beginning was that it's ammonia, methanol, and LNG. These will be the future fuels. And I think by now there's quite a strong industry consensus. And we don't care what the mixture at the end is, but we focus very much on these three fuels in our portfolio offering development. And another one is, and that sounds a bit aggressive, that by 2030 all new builds will be dual fuel capable. And it's not about if it's 100% or 90%, it's more the vast majority. But the point here, it's dual fuel. So the technology capability will ramp up much faster than actually the availability of these future fuels. And as a consequence, these fuels are dual fuel because you need, let's say, a fossil-based backup fuel. And that's very relevant then to come to the conclusions for our development. But in the next step, I mean, when you look at fuels, what are you doing as a turbocharger maker? You look first at the fuel properties because we have to deliver the air to burn the fuel. And don't worry, we don't go all through these numbers. It's also the most complex slide I have. In the first column, you see just the amount of air necessary per energy content, and there is no big deviation. So we cannot derive anything meaningful out of this. But anyway, I mean, engine designers, they used to burn fuel with an excess of air, and normally the air to fuel ratio is in a range of 2 to 2.5. So the next column shows you the range these fuels can accept. And some are extremely broad, so you have all the freedom you need. But here you see the first difference in ammonia, where the upper limit is lower than the air-to-fuel ratios applied today. And I would say the most telling are then the next two columns, which is the ignition energy and the flame speed. And Michael was referring to it already, and there you see a significant difference then when it comes to ammonia. It's difficult to ignite, and once ignited, it burns relatively slow. And for completeness, I have added hydrogen. Not that this is a major fuel for shipping, but it is the fuel of the future for the energy market that is also served by internal combustion engines, and that's extremely the opposite. It ignites extremely easy, and then it burns super fast. But that's more a challenge than for those engine builders who are serving both markets and want to cope this in similar concepts. This is valid for monofuel. But imagine, or remember the former slide, we said it's all dual fuel. So we believe engine builder, and Michael has shown this as well, try to develop these future fuel combustion concepts very close to current fossil fuels. So heat releases are in a similar magnitude. And that would mean, as a consequence, there are no big changes expected. Current hypothesis for turbocharging performance requirements. And this is for dual fuel, it's not for monofuel. But again, monofuel for merchant shipping, ammonia monofuel, I think that's decades down the road, simply because the infrastructure has to be built up and also the production of the fuels have to see a significant uptake. Of course, I could now end my presentation and say, I mean, we go with the products we have in place, but of course we also want to contribute. I mean, we want to drive turbocharging technology, and turbocharging technology is more than pressure ratio and efficiency. So we have set ourselves targets, first of all, to simplify and add flexibility. And that is needed that we can react if needed. So we go along, we learn how the engine builders are developing their combustion processes and what are the requirements towards turbocharger. They might change, it might be just a minor adaptation, optimization, but for this we need to simplify our portfolio to react fast. And we also want to build in flexibilities for the owners. Normally, turbocharger is a very fixed piece of iron with hardly any flexibility. Then we have innovative service concept in mind already during the development process. Normally, this is more a consequence, a result out of a design. And now we take it very early in supporting innovative service concepts. And last but not least, we are looking at lowering Scope 3 emissions. And that's for sure, from our perspective, it's the fuel consumption of the vessels. For most of you, that's Scope 1. But also our own processes and life cycle assessment of the product. So that's a bit the context. Let's have a look now on these 4 development streams. And the core is for sure the next generation low-speed turbocharger that we call X300. And you see, I mean, it's a very strong evolutionary step. We are not doing anything super fancy. We are not printing out of plastic with high risk. It's a solid evolutionary turbo machinery development. But the X300 already indicates that we are aiming for more, that we are building in flexibility. You know, our current products are A100, 200, A200. So just evolutionary would be A300, but the X300 is then indicating that in combination with the other work streams, it's more. We are developing here up to engine outputs of 14 megawatt per turbocharger. So this is the lower half of the available, more or less, propulsion power needed nowadays. So the next element is connectivity. And there we have launched already a product called Turbo Insight, where we strive for having connectivity from the new building phase, and then customers get access to our customer portal, and they can see then how the turbocharger performs over time versus the reference line from the new build condition. And we will see later how these play all together. Then the third pillar is that we are looking at alternative on-engine arrangements. And as said, the X300 is covering up to 40 megawatt. With these alternative concepts, we are trying to extend this up to the highest engine outputs available. And we will also see later how this plays in. And the last pillar is then TC cutout, flexible TC cutout. I mean, that's a known mean to reduce fuel consumption at lower load, and it's applied on many vessels today. Most of them are permanent cutout. Flexible cutout means that you just run the engine up and down, and the turbocharger cuts in, cuts out automatically. So there's no interference necessary from the crew, and you also don't lose the higher output as it is with permanent cutout. Let's look a little bit deeper on the X300. I mean, it's a strong architecture and a much broader coverage per frame size. So here we really make a strong or step change in simplification. And for the lower output range, we reduce the number of types from 5 to 2. You can say, okay, I mean, that's of course a value from operations. It's always good for us. We can drive productivity. But we will see later that also plays then in when it comes to innovative service concept. Then we are adding from the concept the so-called cartridge. So we are enabling from the design that you can remove the whole rotor and bearing assembly from the cold side. And in combination then with lowest weights and highest compactness, we are decoupling now service events from dry docking. So today, all low-speed turbocharger servicing has to take place during dry dock because you need just a lot of time. You're assembling from the hot side, from the cold side. A cartridge exchange is possible with this approach outside dry docking. So that gives flexibility, obviously. And if we just calculate 25 years, we can then reduce the number of service events from 4 to 3. Let's see now how connectivity kicks in. I mean, connectivity, it's all about getting data, operational data, from running hour zero. And if we combine, I mean, obviously, if we have operating data, we can have a lot better and more precise database service offerings. But combining this with cartridge, we can also serve population out of a global or central cartridge pool. Because we know the exposure in the workshop, we have the visual inspection, so we can maintain a pool and ensure the healthiness of this pool. And then we can just offer, in exchange of a used cartridge, a cartridge out of the pool. So this gives flexibility for really, I would say, unique service concept and service offerings as we go along. So this is valid up to 40 megawatt. Now we go higher. And here we see a concept study where we apply, this is an 8-cylinder, 90-plus bore engine, so large bore two-stroke engine. And the lower picture, you see conventional application with two sets of our 180. It's the biggest frame size we have. And the upper shows you then a so-called twin arrangement, where we apply 2 X370 turbocharger per cooler. So we are going from 2 large turbocharger to 2 twin arrangements, or then at the end 4 turbocharger, but without changing the engine architecture significantly. We still have then one arrangement going into one cooler. So the number of coolers, the major architecture remains unchanged. And with this, we can extend the benefits of cartridge, pooling, etc., up to the highest output. And then last but not least, it's the flexible cutout. And that's almost a no-brainer. If you have more turbocharger with the twin, you will have more capabilities and options to apply cutout. And the most obvious one is when you exchange one big turbocharger with one twin, then in one case you have no cutout, and in the other one you have cutout. And TC cutout brings you fuel savings normally in a magnitude between 3 to 6 grams. So this is quite substantial. And on the right side you see here a picture of our very first retrofit. That was still on a conventional end, or on an engine with 3 turbocharger, where we have now FITS 2 running since September this year. And it's also a product offered by MAN, for example, already in the new building stage. But this is only today when you have 3 turbochargers, you can apply this flexible cutout and take one out. And with the twin, you will have a lot more flexibility. So let's come back to these 4 elements and see what the values are. I mean, X300 series basically from 4 to 3 service events, because we have the capability to decouple the service from dry docking intervals, and with this we can fully utilize the component lifetimes. With Turbo Insights, the connectivity part, we can have service offerings data-based, including then potentially a global pooling. With the twin concept, we extend then the benefits to the upper output, to the largest engines, and with the flexible cutout, we will see then additional tangible fuel savings that go well beyond. I mean, with cutout, the fuel savings are much higher than just increasing turbocharger base efficiency. And that gives you not only better fuel efficiency, but also lower CII rating, and the asset value will be enhanced. And as mentioned at the beginning, I mean, from our perspective, it's also improved Scope 3. We will see improved material usage. Our Scope 3 is mainly transportation of components today, mainly by air freight. With the global cartridge pooling, we will have much better, and data, we have much better planning capabilities. It's not only less transportation, but potentially then also changing the mode of transportation from air to sea, which is good for Scope 3, and it's also good for our industry, obviously. And last but not least, then, of course, we are always aiming to provide fuel savings for you as operator and owner, and also for the engine designs. So with this, I come to an end, and I hope there will be many questions, and we would be honored also to support you in your journey towards a greener shipping. Thank you very much.
Thank you very much, Mr. Rovka. I have to mention that Acceleron is the new name for the old well-known ABB. So the next speaker will be Mr. George Mandicios. He is the product owner, data analysis department for MITIS Cyberspace Technology, and he will be talking to us about converting raw data to actionable intelligence. 15 minutes, Mr. Mandicios.
Good morning, everyone. I'm truly honored to be here among you and share my insights from my daily work in MITIS. My name is George Mandicios, and I'm a naval architect and marine engineer, and currently I serve as a product owner in MITIS. So, digitalization is all the way over and can provide and handle enormous amount of data from different stakeholders efficiently. However, it is not the data itself that is valuable. Data is like oil, and unrefined, it is of limited use. The power of data lies in its ability to transform raw information into actionable insights, fostering innovation, improving efficiency, and guiding strategic decision-making processes. Proper data handling, exploration, and big data analytics are essential steps in harnessing this power effectively. And data can be found in various sources, such as the crew, the weather providers, the charterers, the ports, the vessels. MITIS IoT technology has been matured, and real-time data transformation is a reality now and is facilitated by appropriate frameworks. You will say to me that raw data often contain errors, missing values, or inconsistencies. Yes, you are correct indeed. This is the reality, but data quality is always a challenge and will be a challenge, and multiple strategies are available to identify and rectify such issues. Another great challenge is cybersecurity, and MITIS ensures it through specific data security frameworks provided by entities like classification societies and with additional securing mechanisms and best practices. However, what is missing is the lack of digital standards, and this poses challenges in the interconnection of the data collected devices with all the sources. What comes next is the data integration between different stakeholders, such as the data from the weather providers or the vessel, the known reports. MITI software infrastructure is designed to ingest all this data. Data exploration helps businesses in understanding the overall data distribution, and by using appropriate tools and correlation tools, it is possible to understand the relationships between different variables and how changes affect one another. Big data analytics is an advanced stage where data-driven insights are used to recommend action and achieve a better performance. This stage involves the use of machine learning models and algorithms and artificial intelligence techniques to predict outcomes or identify patterns that might be challenging for humans to discern due to the complexity of the data. So, by analyzing the sensitivity of KPIs such as the CII, you can make informed decisions and optimize your vessel's operation. Factors that might be included in such an analysis are vessel speed, the engine efficiency, the hull and propeller condition, and other operational parameters such as the type of the cargo, the weather patterns, the actual weight, and port's efficiency. This screen displays a VLCC tanker operating consistently in the same area for the last 2 years. From 2022 to 2023, an approximate 8% increase is noticed, despite maintaining a constant speed profile. A significant change in the sailing ratio is noticed, showing a decrease of around 25% for 2023. And this results in a hull fouling increase of approximately 11%. And it falls upon the operator of the vessel to find out, to check all these parameters and determine the correct time to take actions. This screen displays the shaft power performance of another VLCC time over time. And once the vessel reaches a specific fouling level, the office orders for a hull cleaning, resulting in an improvement of approximately 7% in the shaft power demand. Nevertheless, another 33% of shaft power relative difference from reference remains. So, monitoring hull and propeller efficiency and performance poses challenges due to various factors that must be considered. Fouling rates can vary widely based on the vessel condition, the water temperature, and other parameters, and it is not occur uniformly across the hull and propeller, but different parts of the vessel are exposed to diverse conditions. So we have ISO standards that provide some framework for performance monitoring and emphasizing in the calculation of ship-specific hull and propeller performance. The standard procedure includes data collection from various sources such as the vessel speed, the vessel torque meter, and the weather conditions. An accurate performance reference is very essential, and if this information is missing, then the vessel should proceed in new trials and have a new reference from now on. However, certain aspects of these methodologies are continuously fine-tuned, and by utilizing a combination of machine learning models and physical object parameters, a reliable estimation of hull condition can be made, can be identified. The speed of the vessel is directly related to the emissions deliberated by the vessel. Proper speed management is vital to decrease CII, but it goes beyond just lowering the speed. The screen presents an overview of the CII performance of a vessel throughout 2023, and multiple variations are noticed. In the first quarter, a 4% rise in the sailing speed resulted in 5% increase in CII compared to the second quarter. Given that the charterers often determine vessel speed, data sharing between stakeholders is essential. This collaboration helps to identify the reasons of underperformance in the terms of CII, grade, fuel oil consumption, and or the voyage delays. Fleet monitoring is of great importance as it allows shipping companies to easily compare vessels and gain a comprehensive overview of their entire fleet. This is crucial, especially now with the new EU regulations, Trading Scheme EU ETS and Fuel EU, which operates at the fleet level. Under this regulation, companies are required to report on a yearly basis their emissions. And to comply with all these requirements, the company must have all the required data and aggregate them. The implementation of CO2 monitoring at the fleet level will allow the shipping companies to analyze the environmental impact of their entire operations and identify areas of improvement. It also enables them to participate in emissions trading within the EU ETS effectively, promoting a more sustainable and effective responsible approach to maritime transport. Weather routing and speed optimization solutions are widely adopted solutions for succeeded voyage efficiency. However, it's essential to first identify and determine the voyage objective, and then select the appropriate scenario based on your requirements. So the table here presents three possible scenarios. The first scenario pertains on a specified speed outlined by the chartering agreement following the usual route from Singapore to China. The second scenario maintains the same speed but optimizes the route by taking into account the weather providers. And the final scenario utilizes a speed optimization algorithm to determine the optimal speed at each point of the route, ensuring timely arrival with a minimum consumption and a reduced CII. METIS provides specific tools to model the relation of various operational indicators with the aim on making proper operational adjustments. So advanced data analytics enables informed decision-making, ensuring alignment with the vessel's true condition. The results presented here are based on machine learning models trained on data collecting from a bulk carrier during a 3-month period. The initial figure, the first figure, presents the outcomes for different fuel consumption rates corresponding to different sailing speeds at specific drafts. When the vessel maintains a constant draft of about 16 meters, reducing speed by 0.5 knots could lead in approximately 6% of fuel savings in shaft and 7% in shaft power demand. The great challenge of this decade is to explore ideas and solutions that will enable you to remain competitive and sustainable for the years to come. Major industry players are investing in alternative fuels, carbon capture technologies, and innovative anti-fouling solutions, as well as new vessel designs with lower speed design speeds. The collaboration of various stakeholders under various projects is also essential to address this challenge. After 2030, the burden shall be huge, and companies that have experimented during this decade shall be ready to implement their top solutions. In the first case of the evaluation of an anti-fouling paint applied on a vehicle carrier, 13 years old, the rise in the shaft power measurements across the 3 reporting periods is relatively moderate, at about 4.2%, and more specifically, the average differences are approximately 4.7 when comparing the first year and the second year, and 3.9% for the second and the third year. In the second, a novel waste heating recovery system is evaluated for a VLCC tanker, which resulted in a fuel saving of approximately 9 tons during the examined period. We're talking about 1 year. And this can multiply it by the amount of the chillers the company applies in the vessel, installs in the vessel. So the industry faces now challenges with issues such as the environmental pollution, maritime security, overcapacity, infrastructure constraints, and supply chain inefficiency. Now it is a time on getting decision and strategic planning that will allow the shipping industry to optimize operation, increase efficiency, enhance safety, and reduce the environmental impact. The goal of achieving zero emissions by 2015, combined with the recent Fuel EU and EU ETS regulations that are here to stay, emphasizes the importance of digitalization with all the challenges that we face, such as the data security and the data quality. Also, the industry is lack of skilled workforce that will work on these new tools. And in this respect, end-to-end solutions like METIS can assist on this. Shipping is an old industry, steeped in traditions and with a highly competitive attitude, making the collaboration between different stakeholders not an easy job. In the past, it has been an argument against the EU MRV and the IMO DCS reporting regulation that sharing fuel oil consumption could endanger the sector's ability to compete. With such mandated transparency, the confidential nature of data as an argument no longer exists. And meanwhile, the most competitive shipping firms are those to make their data public. Data and data sharing in shipping is a great opportunity. Regulatory pressure and the fight against climate change will require whoever leads the maritime sector to provide validated, shared, and benchmarked data. This data will become an essential prerequisite for AI-driven optimization and meet sustainable targets. Just like other industries, the digitalization is inevitable. The question is whether this opportunity will be seized on by you, the sector players that are leading the market now, or external players. Taking targeted actions to enhance the entire chain will result in gaining efficiency, and by taking advantages of all the new technologies, who knows, the zero emissions may be a reality. Data and data sharing through digitalization is the key to lead the maritime market of tomorrow. Thank you.
Thank you very much, Mr. Mandicios. Our next speaker will be Mr. Dimitris Koutsaftis. He's Senior Scientific Consultant for Research and Development for ERMA First. He's going to speak about carbon capture storage. 15 minutes, Mr. Koutsaftis. Thank you.
I would like to thank you for your participation in this very interesting session and for allowing us to present to you our progress regarding our CO2 capture and storage project. My name is Dimitris Koutsaftis, and I am the CCS project leader at ERMA First. ERMA First has initiated an R&D project with regards to CO2 absorption with the implementation of amines, followed by compression and liquefaction of the captured CO2. And in this frame, has conducted a number of feasibility studies in order to examine both the integration of our system on board the studied vessels in terms of fuel, steam, and power consumption, as well as identify available spaces for the actual installation of the plant and propose required modifications on the vessel. Today, I will present to you the results of such a technical feasibility study that we conducted on a bulk carrier vessel with a 91,800 deadweight tonnage. It should be noted that the vessel was already equipped with a shock scrubber and was therefore operating on heavy fuel oil. The operating profile of the vessel, based on the AIS data that have been provided by the owner, is displayed in this graph. As you can observe, the vessel most of the time is either traveling loaded at 12 knots or is at port or unloading. Now we move forward to the CO2 capture system, and I will make a short description of the system operation for those who are not familiar with its operating principle. You can imagine the vessel exhaust piping being on the left side of the process diagram. So a slipstream of the main exhaust gas flow is drawn to the plant by means of a dedicated blower, which is transferred, first of all, to the direct contact cooler on the top, on the left bottom, for pretreatment. This is a direct analog to a SOx scrubber, and its purpose is to remove SOx, particulate matter. In our case, remove NO2 as well, and also saturate the gas stream with water vapor. The gas exits the direct contact cooler at a temperature of approximately 40 to 45 degrees and enters the CO2 absorber. This is again a tower where the pretreated flue gas is brought in intimate contact with a lean in CO2 amine solution flowing from the top side. You can see the orange the orange arrows there. And the reaction of the CO2 with the amine takes place in a structured or random packing, and the amine that is now rich in CO2 accumulates at the bottom of the tower while the treated flue gas flows to the top. The rich in CO2 amine is then taken from the absorber bottom, is preheated to approximately 100 degrees in the lean-rich heat exchanger, and then enters the stripper where it is brought in intimate contact with stripping steam that is produced from the boiling of the amine itself. This boiling is conducted in two stages in our system. First, through a preheating stage at a dedicated exhaust gas economizer, and secondly, through a boiler that uses steam from the vessel itself. This contact between hot steam and rich amine leads to the desorption of a trained CO2, which flows up the stripper. This stream is cooled further on by a dedicated heat exchanger, which is at the top right, and separated water, which is produced by this cooling effect, is returned to the system. The lean CO2 amine is collected at the stripper bottom, and after cooling through the lean-rich exchanger, is returned to, and also a secondary trim cooler, is directed to the absorber for reuse. The treated flue gas exiting the absorber is significantly warmer compared to its entry temperature due to the amine and CO2 reaction being exothermic in nature, and therefore tends to absorb water from the system. For this reason, one or two water wash sections exist downstream of the absorber column, and their purpose is to cool down the CO2-depleted exhaust gas and also prevent any amine emissions escaping the system along with the treated flue gas. Moving forward with the compression and liquefaction plant, the CO2 stream that has been captured in the amine plant is first compressed in a two-stage compression train to approximately 18 to 20 bar, followed by pre-cooling and treatment with activated carbon to remove odorous components. The stream is then treated for almost complete removal of moisture below 10 ppm through a desiccant dryer unit in order to avoid formation of ice in the pipeline and process equipment. The final stage is the refrigeration of the stream that converts the gaseous CO2 to liquid at a temperature of approximately minus 30 degrees, while at the same time, non-condensable substances are removed through a specially designed stripper, which you can see at the top right. So if one wanted to sum up all of the equipment involved in the process and have been described up to now, this would involve the direct contact cooler, the absorber, the water wash, the stripper, as well as the overhead condenser and all the heat exchangers and solvent storage tank involved in the capture plant. The compressor train, the dryer, the activated carbon purifier, as well as the CO2 liquefaction module with a stripper for the removal of the non-condensable substances for the CO2 liquefaction part. Of course, we must not forget to account for the product CO2 cryogenic storage tanks that require a substantial footprint, and their volume depends both on the system capture capacity as well as the vessel's route. Moving on to the feasibility study results, we first see the graph of the vessel's fuel consumption at different operating modes and for various CCS capacities. More specifically, capture capacities with a range of 500 to 2,500 kilos per hour of CO2 were examined, and as anticipated, the implementation of such CCS systems leads to an increased fuel consumption, with the increase being analogous to the capture capacity. The next slide presents the auxiliary engines load on the left and their number, as well as the steam production for the vessel as it stands at the moment with no CCS system installed. In this slide, we see the impact of the installation of a 500 kilos per hour system, both in the number of operating auxiliary engines, which changes compared to the baseline, and their respective load, as well as the required steam to cover the relevant needs for both the vessel and the installed CCS system. The same results are presented for the 2,500 kilos per hour system, with the relevant demands becoming more profound in this case, of course, especially in the number of operating auxiliary engines, as well as required steam production. In the next slide, we can observe the results regarding the impact of the system size in the annual fuel oil consumption, as well as in the CO2 emissions. In the first graph on the left side, we can observe the increase in fuel oil consumption as a function of the CCS system capacity, ranging from 5 to 24% for 500 to 2,500 kilos per hour, while the second graph depicts the CO2 capture rate versus the CO2 capture capacity. So one can observe that the capture rate varies from 11 up to 43% of the total CO2 emissions, depending on the capacity of the installed system. Moving forward with the CII based on the data that have been provided by the owner, its value was calculated with no system on board at 3.47, which gives the vessel a current rating of D. The next slide presents the impact of the CO2 capture capacity on the CII. So, as one expects, there is a substantial decrease in the vessel's CII, ranging from 9% for the 500 kilos per hour system up to 31% for the 2,500 kilos per hour system, resulting in ratings of A for the higher capacity systems and B for the smaller ones. Regarding the actual plant integration, we investigated the installation of a 1,000 kilo per hour system on the vessel, and you can see what this looks like in the next couple of slides and the modifications that are necessary to host such a system. The modification include the installation of a pair of cryogenic tanks with a combined storage capacity of 200 cubic meters, as well as all the relevant amendments required to keep the vessel compliant according to the SOLAS. All the equipment that have been described before are displayed in this nice picture. Regarding the status of our project, we have designed the pilot plant that you can see behind me that will be installed in a commercial vessel within Q1 of 2024 and will run for a period of 5 to 6 months for testing and demonstration purposes. So to sum up, we presented the results of a feasibility study that was conducted on a bulk carrier vessel and examined the impact of the installation of a CCS system with various capacities in terms of fuel oil consumptions, auxiliary engines load, steam consumptions, as well as CO2 emissions and CII. The required mechanical modification of the vessel were also examined for a system having a capacity of 1,000 kilos per hour. From all the above, it is concluded that the installation of a 1,000 kilos per hour system is technically feasible for the studied vessel and can lead to significant reduction of CO2 emissions, making the vessel compliant with relevant IMO regulations. Thank you for your attention.
Thank you very much, Mr. Koutsaftis. Our last speaker for the first part will be Mr. Yigit Kemal Demirel. He's a decarbonization specialist for Hempel, and he's going to talk to us about navigating energy efficiency dilemmas in the CII era.
If shipping were a country, it would be the world's 6th biggest greenhouse gas emitter. as we strive to decarbonize and develop zero-carbon ships in the future, how can we bridge the gap between the present reality and our future aspirations? Obviously, we need to use some short-term measures. And everyone will agree that keeping a hull clean and free from fouling is a key priority to reduce the fuel consumption of a ship, and upgrading to a low-friction coating is a proven method. However, there are many more energy efficiency measures that are currently available, like different energy-saving devices, different biofouling management strategies, and so on and so forth. Therefore, the ship owners and operators are facing a key question today. How can we make an educated decision-making? How can we choose the most optimum solution for my ship? So as you would appreciate, this is a ship-specific question which requires a ship-specific investigation. So with this in mind, at Hempel, we developed a framework to holistically assess and analyze the impact of different energy efficiency measures. My name is Yiğit Demirel. I'm a decarbonization specialist at Hempel, and it is my pleasure and privilege to be here and to be presenting the Hempel framework and also show you a case study to demonstrate how we can use this developed framework for each case. Okay, but before going to the details, I would like to re-emphasize the importance of retrofitting the current fleet. So this graph shows the development of the fleet under a moderate growth scenario. And what we see is wave 0 and wave 1 ships. So basically they are diesel ships. These are the ships that we have. And after a while, we will have wave 2 and wave 3 ships, and hopefully zero carbon ships. But the reality is, from this point forward until 2050, the half of the emissions will be coming from the current fleet. So we have to do something with what we have at hand for our existing fleet. And what is available now? There are many different options, as we all know. I already mentioned there are many different energy-saving devices, as you see here, advanced hull coatings, air lubrication, ducts, and so on and so forth. Along with these technical measures, there are also several operational measures, different hull cleaning regimes, slow steaming, and so on and so forth. But here is the dilemma. Which one I'm going to choose? Shall I go and get a low friction coating with full blasting? Or shall I go and select a self-polishing coating and carry out regular cleanings? Or shall I also include energy-saving device? So this is the current dilemma. So this is illustrating the framework that we developed. So as you see at the center, there are different ship energy efficiency measures. We just put a couple of here, but it is not an exhaustive list. And obviously, as you see, we have 4 different pillars. The first pillar is the, let's say, I call it shortlisting pillar. So among all these energy efficiency measures, we first look at the vessel, we look at the operational conditions, we look at the history of the vessel, all the hull events, and obviously we consider the future operations. And then we do select the, let's say, the suitable ones. When it comes to coatings, for example, obviously you need to consider the fouling risk, or you need to consider the CII increased risk, and so on. Once we have all these shortlisted energy efficiency measures at hand, the second pillar is the regulatory requirements and compliance. So we are modeling all these energy efficiency measures and predict and calculate the fuel consumption, and the resulting other parameters like CII, EU ETS, and obviously we can add many more in the future. The third one is total cost of ownership and payback period. So obviously having some energy efficiency measures require some upfront investment and also some different operational, let's say, actions that may change the total cost. But what is important is also to think about the savings you get and see the total cost of ownership rather than only focusing on one aspect of the cost. And the final pillar is, of course, environmental considerations and sustainability. While achieving all these things, what we are doing overall. So again, an example from coatings. We need to consider the CO2 emissions coming from the production of the coating. We need to take into account the biocide release to the marine environment, and we need to think about the microplastics and so on and so forth. So by using these 4 pillars, we are trying to come up with the big picture and make the selections accordingly. So now let's look at the case study. So we selected a case study to show how we use the framework. So we chose this well-known case study from the report published by the GloFouling project. So GloFouling project is partly funded by IMO, and they published this report. And actually, before joining Hempel, I was involved in the development of this report as the main author. So, we choose this one. In the report, we looked at the greenhouse gas emission reduction potential of different, let's say, different biofouling management approaches in the original GloFouling report. So we only looked at the fuel consumption, but we didn't consider any operations, any dry dock operations, or the implications on CII, EU ETS, and so on. Plus, we only looked at the self-polishing coatings, and actually we wrote in the report that there are certain things to be done in the future. One is to add a silicone-based coating and look at the results again, and also extend the study to give a more realistic, let's say, view. And here, that's what we did. So we took the case study, and then we applied the framework by using these scenarios. So we only selected 3 scenarios from the original report that is relevant to us. So as you see, SPC with no cleaning, SPC with responsive cleaning, regular cleaning, and the final scenario is adaptation of a silicone-based low-friction coating by design. It doesn't require any in-water hull cleaning. The fuel consumption model we use is actually, for this case, isn't that complicated. So as you see, on the left-hand side, you see now some numbers. So the ship enters the dry dock. Obviously, the required power is higher than before because it has fouling, degradation, aging, and so on. And then if you wash and clean, your power requirement will go down. And then if you do spot blasting and SPC coating, down. Instead, if you do full blasting, it will go even more down. And finally, if you adopt a silicone-based coating, it will go down again because the silicone-based coatings are providing an extra property, and they act almost like an EST. So they are reducing the frictional resistance of the ship and hence act as an EST. And yeah, afterwards, when the ship is in operation, in 5 years' time, as I mentioned, due to fouling, mechanical degradation, and aging, we'll see an increase in the required power. And this is the cost model. So we call it total cost of ownership. So all the costs included, the costs during the dry dock and the costs during the voyage. When I say the voyage, I mean the fuel costs, but also other operational costs. If there is hull cleaning, for example, you can think about the diver costs, and if the ship is staying for cleaning, obviously you need to take into account all these costs. So we take such information from reliable reliable contacts, and then we use these values to come up with the total costs. In this presentation, I will be only giving a subset of the case study, but the whole details can be found actually in the literature. This figure shows the power requirements of the ship with different scenarios. So on the left-hand side, you see the original figure from globe fouling reports, and on the right-hand side, you see our modeling. So the first three scenarios, we didn't change anything. We used the same assumptions for the power and for the fuel, but we added the silicone-based coating, as you see with green. And I guess you realize that it starts from minus 8.5 because the SPC scenarios starts from 0 in the original report. So we didn't change that. Therefore, the silicone-based coating starts from minus 8.5. And in 5 years' time, obviously, the power is increasing. Here, maybe one little detail. For the purpose of modeling and being objective, we simply distributed the predicted power increase linearly and evenly over the 5 years. So that's why it looks like a line. But in reality, this curve will change depending on your ship operations and other characteristics. But this coating, this specific coating is a Hempegard X7. So we know that the maximum speed loss value would be 1.4%, and actually we are guaranteeing it. So I use these values for this modeling purpose. Just looking at the power may be misleading, and it is misleading, because what we are interested in, the total fuel consumption in 5 years' time, in one docking cycle. So we need to look at the cumulative numbers for each and every case. So here you see the comparison between these scenarios, and you see that scenario 4 obviously giving the most beneficial result, and the difference between the scenario 4 and the scenario 1 is around 6-7 million. This is only a fuel cost. And if you compare it with other scenarios, obviously the numbers become 4 million and 2 million. Although we are not showing the total cost of ownership here, you can imagine that the fuel consumption is the biggest, let's say, item in the total cost model. So therefore, it gives you an indication on which one is the best when it comes to the total cost. This slide shows the implications of selecting these coatings, also from a regulatory point of view. So what we see here for scenario 1, 2, and 3, the ship starts with a CII rating of C, and it becomes actually non-compliant. So the first two scenarios become non-compliant at the end of the second year. The third scenario, it becomes non-compliant at the end of 2027. When it comes to scenario 4, because of this out-of-dock power gain, because of this silicon effect I mentioned earlier, it already starts from a rating of B, and then obviously it is increasing in time, but it stays compliant over the 5-year period. And the figure below shows the EU ETS carbon cost. Obviously, starting from 2024, this is a very important factor. And as you can see, again, the differences become quite big if you look at the total EU ETS carbon costs that the ships are going to pay and how they differ depending on the selected, let's say, biofouling management measure. And to conclude and summarize, so we came up with a decision support tool which is objective and it can be used to support any decision making. So before any investment, it can be used. Another point is we all need to remember that such analysis should be ship-specific and should be done holistically from different points of view. For this case, adoption of silicon-based coatings seem to be the best investment, but I mention again, it's for this case, so we are encouraging ship-specific analysis. And the final word is a call for action. More input means more accuracy, so let's collaborate and achieve things together. Thank you very much.
Thank you very much, Mr. Demirel. We seem that we have more time than anticipated for Q&A session. So that's a good thing, because we will be able to ask some questions to the speakers. I have a question for all the speakers. My question is, what are your main concerns regarding the development of your product? What are the limitations, and how would you plan to overcome same? If we can start with Mr. Rovka, and then from the right come to the left.
Yeah, maybe it was a bit in my part. I mean, developing a turbocharger, a new turbocharger generation is quite an investment. And then we have it in the market for 15, 20 years. Very blended. We cannot afford to be wrong. And now we have to develop towards and handle quite some uncertainty. And that's a challenge. I mean, we have to change the way we develop our products. And then we have to be very close to the market, to the engine OEMs, that we know what they learn and can adapt it. Then what are the consequences for our product? And we have to build in as much flexibility. We try this with simplification on the one hand, but of course, when you develop a machine, it's not like a software. It takes time. It needs to be qualified. Everything we bring in the market for merchant marine has to last. You know, we cannot take too high risk. And to get an organization also behind it, to think differently, to adapt processes, that's a challenge, but it's also a great opportunity. And I think it's also great motivation.
What about the limitations?
Good question. Yeah. What are the limitations? I think for us, the risk as a technology provider is that there is no acceptance, not sufficient acceptance towards innovation. You know, that everyone asks for standardization. I mean, we have engine OEMs, they would love to have all turbocharger making having the same footprint. You know, and that we start to become commodity. And I think that might be short-term beneficial for some, but it will not drive innovation sufficiently. So that I see as a concern and potential limitation, the acceptance of needed innovation in a rather risk-averse industry.
And how would you overcome that?
Let's say we develop from I mean, what I've shown is we have a rather solid base development, and then we add stretch where, let's say, also stretch our partners. You know, with the twin concept, we don't know how far we get, but we do this at moderate risk. If it doesn't fly, we still have the conventional application of the new developments we have. So that is a bit how we take educated and limited risk and always have a safe fallback and base. But that's a very specific path we have chosen.
Thank you. Michael?
Yes, in the development of the ammonia engine, I think one of the biggest challenges is time. Engine development takes more time than one developer wants to acknowledge, but that is a fact. Another thing is that right now we are in a situation where a lot of ship owners are queuing up for getting our product. And unfortunately, we cannot deliver until the end of 2024, and the release of the different engine sizes is not actually decided yet which ones to go with. The first engine type will be a 60-bore, delivered by Mitsui in Japan. And then good candidates are the 70-bore and then the 80-bore. But we have to look into the encouragement and the demand from ship owners and large stakeholders. Looking at the concerns and limitations, there may be an issue with the development of the infrastructure for green ammonia, as I see it. Ammonia seems to be a very good candidate for the future fuels, green fuels, but the ramp-up of the infrastructure is a concern of mine. I think the technology development takes shorter, I think that has been mentioned already today, takes shorter than developing the infrastructure. So there may be a constraint right here in this respect. But I think we will have a successful engine. The development status appears very promising, and the market seems very willing to take our product.
Thank you. Mr. Mandicius.
Okay. The greatest challenge from ET side, since we're talking about technology providers, is not to stay behind the state-of-the-art technologies. We have to be updated constantly in order to provide to our customers the best solution. Okay, what is missing currently is the data sharing frameworks, and these have to be developed, and this is something that creates some limitations in our work. The biggest challenge for the years to come is the predictive maintenance analysis. We have to get deep into this domain with the use of AI-driven technology and help the shipping companies and the shipping owners in order to do this and enhance the daily operation of their vessels. And what a platform such as METIS can do is to unite all stakeholders into one common truth. It is very important for stakeholders to cooperate, and they have to be able to get the same data, the same information, all of them, in order to enhance the entire supply chain of shipping, including ports, including classification society, including the charterers, the vessels, all this.
Thank you. Mr. Koutsaftis.
Regarding the implementation of onboard CCS, I would say that the greatest challenge would be the part after the storage, meaning that there are limited solutions for discharging the stored CO2. Let's face it, this is the main constraint. And added to that, the requirements, the specifications of the captured CO2 in order to be disposed at certain sites, let's say for enhanced oil recovery, which is, of course, the biggest application of liquid CO2 for permanent storage. The requirements in order to dispose it are even more extreme. Hopefully our system can cope with them, but as a constraint, this has to be solved in order for the market in the marine sector, I mean, to grow as it has the potential now. Yeah.
So you think that the cost is one of the major factors?
Not the cost, not so much the cost, but mainly, as I told you, the availability of solutions after the ship. After the ship. I mean, if you look at Europe, there are only one or two solutions where you can discharge it. And of course, there are projects happening, but you cannot expect a short-term solution.
So what do you think we can do as a shipping industry to take this a bit further?
ERMA first is we are collaborating with various stakeholders in order to come up with various sites, let's say, or solutions in order to help our customers tackle this problem. Apart from this, I think it's a problem of supply and demand. Since there is such an urge for ship owners to install such systems, I think that the part after the ship will also grow inevitably.
Thank you. Mr. Demirel?
Well, I think there are many challenges when it comes to the coatings, but I guess today I would like to emphasize one important aspect that actually I've been thinking recently very much. It's the perception about the coatings, because traditionally we see coatings as naval architects. We see coatings to simply mitigate the eddy resistance during operations. So it is like an operational measures. And nowadays, the advanced technology obviously enable us to develop these silicone-based coatings that I presented. And when I myself actually carried out experiments like towing tank experiments, I saw myself that they are reducing the frictional resistance in the as-applied condition at that moment. So it is acting like an EST. So it is actually both a technical measure right at the beginning, fresh out of the dock, and on the way, it is acting as an operational measures. So I think this needs a kind of paradigm shift, that we need to understand this and actually acknowledge this effect. And obviously, modeling is another aspect when it comes to all the other energy efficiency technologies. You know, you can model with CFD and so on. But when it comes to the coating effect, there are other methods that are not maybe well known by the shipping industry, but well known by the academic world. I think we may need to try and communicate this further, especially through classification societies, ITTC, and IACS. So I think if we can change this, let's say, traditional thinking, it would be good for any coating manufacturer.
Thank you very much. One comment, when we were discussing new buildings during the last 2 months with Japanese yards, Korean yards, and Chinese yards, and we told them that we want to use silicone paint, they all said no. No. What you can do is paint the vessel in the conventional way, cheap anti-fouling, and then take it across to China, and you do a full blasting of the ship, and then you do a recoating with silicone, which shows that not all the stakeholders are thinking in the same way. when we try to do something, there is another stakeholder who is putting us a limit. This is just a comment, but it's food for thought. Since we have some more time, we can take some questions from the floor. Anybody? Yes, please.
Well, thank you for the question. I'm not a chemist myself, so to be perfectly honest, I don't know the details of the graphene, so I will not make any comment on it. I'm a naval architect, and I'm, trying to model what I have at hand, and try to find the implications. But graphene, I just read a couple of things. I see some promising claims, but I haven't seen any, let's say, scientific study, or I didn't see the result of our internal studies, so no comment from my side. Thank you.
Anybody else? Mr. Giannoulis.
Thank you. I have a question for Mr. Demirel. Your presentation was very excellent. Thank you very much for presenting the advantages of silicon-based paints, both on energy saving and ownership costs. But I was a little bit confused on the table you have presented for rating the various coating technologies as far as CII is concerned. You presented that silicon-based paints, they can, with them you can achieve a rating for the time being, but you can keep a B rating until 2027. But my question is, by only applicating silicon painting, you can achieve this CII rating without any other energy-saving device, or what? I was a little bit confused.
Yeah, no. Of course, CII is dependent on many things, including how you operate the ship and so on. So what we try to do here is to eliminate all the other factors. So basically, we didn't take into account different operations and so on. So we assume if in the first year it reaches to, let's say, the reference line, if it is C, how it would vary if you have the silicon, and how it would vary if you have the SPC coating. So by keeping everything else constant, we see these variations. So the SPC ones start with C, whereas silicon start with B, and then they all increase, obviously, depending on the characteristics of the coating. But we kept everything else constant to show the impact of the selected coatings on the numbers. But yes, in reality, obviously, if you have a silicon-coated ship with, let's say, not operated in an efficient manner, obviously your CII will be high. Thank you.
Mr. Maounis.
That's for Michael. How on earth can you make ammonia crew-proof?
How can we make ammonia?
Crew-proof. I mean, given the average standards of our crew today,
Okay.
knowing that ammonia is lethal.
Yes. Well, this is a concern that we have had ourselves in the development phase of the fuel gas supply system and the ammonia catch system and so forth, and the filtration and everything, because it is not acceptable to have just the smallest hors d'oeuvre of ammonia. So, and safety is a very big concern because it's toxic and it is in fact lethal. And we are striving ultimately to avoid accidents and to make sure that safety is in all time in place. And I mean, if we have an accident during the testing of this ammonia engine, immediately the potential for market of ammonia engine will disappear. So this is a great concern of us also.
Training is important.
Training we will do as soon as our concept and the engine development is finished. But it's a little bit difficult to say now that we will have training as soon as this year or even next year.
Thank you.
Welcome.
Yes, please.
Regarding ammonia slip, I think there will be it will be fully covered because we are implementing SCR system on the ammonia engine as standard, and as you know, ammonia is part of the SCR process where we are taking this into account in the after treatment system. And regarding ammonia as a fuel, this is there's no CO in the ammonia. The only introduction of CO2 you can get for the combustion of ammonia is through the pilot fuel. And that can even be done with biofuels, which can be CO2 neutral by carbon capture. So I think on an environmental basis, the ammonia engine is the best candidate at all for the decarbonization era here in the next 10, 20 years. Thank you.
I think we can take one more question, if there is one. Okay. I want to thank the speakers, and I want to thank you, the audience, for listening to us. We will take a break for 30 minutes. We will be back at 12 o'clock. Thank you. Our first speaker would be Mr. David Ferrer. He's Chief Technology Officer and co-founder for Bound for Blue. And he's going to talk to us about power the world with wind. 15 minutes. Thank you.
Okay, thank you very much for the introduction, and thank you to the organization for giving us the chance to be here to pitch about Bound for Blue for the first time. As already introduced, my name is David Ferrer. I'm the technical manager and one of the founders. It's not on?
Just a little closer.
Oh, even closer? Okay. How about now?
Yes.
Okay. How about now? So I'm going to try to make a quick presentation to the company, who we are, because we're not very well known, and where we are today with the technology validation. So first of all, quick introduction. The company was founded back in 2015 in Barcelona. And since then, we have grown quite a bit. We are more than 30 people in the team with 3 offices worldwide. We have already installed the technology in 3 different vessels, and we are working on 4 additional installations. The team, going very quickly, we are focused on engineering. And the strategy that we have selected is focus on what we know that we can do the best, which is designing sails. So most of the team is engineering, mechanical design to design the structure, automation to make the sail fully autonomous, performance, to understand what happens when you put a sail on a vessel, aerodynamics, of course, to make the sail as efficient as possible, and then naval architecture to understand what is the best way of installing those sails on a vessel. But then, for the rest of activities, we basically partner with experts in each field. And I have several examples, but I'm going to explain only one. It's manufacturing. We are not manufacturing our sails because we thought it doesn't make sense to become a company able to manufacture large steel structures when this industry already exists. So what you see on the left is the main structure of one of our sails. So it's basically a tube, two flanges, top and bottom, some elements welded inside. The reason why this sail is like this is because we want it to be very similar to what you see on the other side, which is a tube with two flanges and elements welded inside. This is the tower of an offshore wind turbine. And the strategy of going to these suppliers is because they are worldwide, and they already know how to manufacture these large steel structures with high standards of quality, meeting the offshore requirements for the corrosion and the marine environment, and they perfectly know how to scale up production and automate the production to reduce lead times and costs. So why doing, again, what they already know how to do? So in Spain, we have a partner called Haicea. What you see here is one of their production plants that is in the port of Bilbao, which is also very useful because they have direct access to the sea for transportation of the sails. A little bit of history. The technology we have developed, the commercial name is eSail, and it's a suction sail. So the suction concept started back in the 1930s. NASA investigated applying that to the wings of airplanes. It was not very feasible on wings of airplanes, but this concept was regained again back in the 80s by the Jacques Cousteau Foundation, who hired two scientists, Lucien Malabar and Bertrand Charrier, to develop a wind-assisted propulsion system, and they developed the turbo voile. It's what you see in the picture in the middle. That's the Alcyon. It's a vessel equipping two turbo voile. That basically proved the concept. And the thing is that Bertrand Charrier, one of the two inventors, is now in our team in Bound for Blue, so it helped a lot to set out the basis on how to develop this technology. Let's explain how a suction sail works, but the first thing is understanding how a regular sail works. So what you see on the left, it's images from a wind tunnel test from an airfoil, classical airfoil from an airplane wing, a rudder, or a wing sail. The aerodynamics or the lift coefficient happens when you increase the angle of attack, which is the angle between the sail and the flow of air. So in the first picture, 0 angle of attack, no lift. Second picture, more angle of attack, more lift, but this is limited to what they call the stall. Stall is when you reach a maximum angle of attack, the flow of air detaches from the sail and you lose all your lift. So that's the limitation for a wing sail. And the limitation, it's basically a lift coefficient of 1 or 1.2. What they thought in the 80s is, look, if I'm able to prevent this detachment, I will be able to go to higher angle of attack and produce more lift. And if I produce more lift, I get more savings. So what they invented after 4 years of development, it's basically what you see on the left. That's more or less the shape of a suction sail, that if you don't do nothing, so the suction is off, the flow is fully detached. This is not a sail. This is not generating lift. This is just generating drag like any other structure on the vessel, funnel, a crane. But what they invented is that if you suck a small amount of air just at the point of detachment, you get what you see in the second picture, which is the flow that reattaches. And when the flow reattaches, then you get lift. And now you're controlling the stall. You're avoiding the stall. So you can increase angle of attack and produce more lift. More lift means that we have reached a lift coefficient of 8.2, which is 6 to 7 times more than a conventional sail. And this means that we can have the same savings with a sail that is 6 to 7 times smaller. And that's what is really interesting on a wind propulsion technology. So just to understand a little bit where the eSail positions in comparison with the other technologies, the eSail is kind of in between a wing sail and a Flettner rotor. It's kind of getting the good features from both sides. So if you look at the wing sail, the good features of a wing sail is that they need very low power consumption. They are very easy to operate. You just adjust the angle of attack and no other big moving parts constantly. And they have a very good capacity to sail upwind. They can sail with winds that are very close haul. The problem with the wing sail, as I said before, is that their lift coefficient is small. So if your lift coefficient is small, you need large sails. Large means that you need a lot of material. A lot of material means a lot of weight. So you want to go with lightweight material, then it's a lot of cost, which in the end is a lot of weight and a lot of capex. And also they are so large that it's very hard to put on a vessel because you have aircraft limitation, visibility, stability. So it's very, very challenging. So you want to have something small, and to have something small, you need high lift. And that's what we share with Flettner rotors. High lift means smaller size, and smaller size means it's easier to install on a vessel. The problem with Flettner rotors is to generate high lift, they have to be constantly spinning. And that's a mechanical challenge. It's a mechanical challenge because you need a lot of power to keep them spinning, and it introduces vibrations, fatigue problems, more maintenance on the slew bearing. So in the end, they are also more expensive, both in CapEx and OpEx. So as you see, the D-sail is kind of in between. It is a sail, it's like a wing sail, but generating high lift. How it looks like, starting from the bottom, you have a flange connection, so mechanical connection to the deck or to the foundation of the vessel. Top of that, slew bearing with an electric motor to allow the sail to orientate and adjust the angle of attack with the wind. On top of that, we have the main skin, the tube that you saw in the previous picture. On top of that, we have the suction fan, so it's an axial fan that is basically sucking the air, as you saw in the wind tunnel pictures. And then all the elements of the autonomous control system are located inside the sail. So we don't occupy any other place on the vessel, except, of course, for the control screen at the bridge. We are developing 3 different models, different sizes, to be able to adapt to the different types and sizes of vessels that we think that can take profit of wind propulsion. So the size is basically set by the width of the sail, so 2.85 meters, 4.5 and 5 meters, and 6 meters. And then we have different heights to give some flexibility to air draft limitations or stability limitations. So the strategy that we started is we have to test it at sea. So we have to learn from real operations. So we did two prototypes, what I call the prototyping phase. So we installed 2 units on 2 different vessels in 2021 to learn as much as possible, learn how to control the sail in this turbulent environment of wind, turbulence of the vessel, changing roll, etc., how to measure the performance, how to optimize aerodynamics, etc. And with all those learnings, we went back and we redesigned our technology. We validated the performances. So this is a picture of the wind tunnel test that we did last year. And we published those aerodynamic characteristics early this year. I think we are the only supplier that has published the aerodynamic characteristics, but we think it's important to be transparent. And now we are at the next stage. Next stage, it's installing our technology on one of each of the different types of vessels that we think are relevant to have a reference for the market, so that any owner can go to the ship owner and ask what was the experience and to be able to publish results. So we started with a general cargo vessel from a master shipping, a Dutch ship owner, onto which we installed 2 units, model 1, 17 meters this summer. And now we're doing sea trials together with Lloyd's Register, who will be doing the third-party performance validation. So again, we want to be publishing results. That's what we think is important. Next segment, the RoRo segment. What are the challenges of putting sails on a vessel with large windage area, high position of the top deck, usually not very strong decks? Is it possible? The answer is yes. So we'll be installing 3 units of our Model 2, 22 meters on the Ville de Bordeaux. That's a vessel from LDA, a French ship owner that's operating the fleet of Airbus, and that's going to happen early next year. Next segment, tanker. So we signed an agreement with Odfjell Tankers in Norway. We're now doing the engineering design for the retrofit of the vessel, and we will be installing 4 units, Model 2, 22 meters, on the Bow Orion next year. And finally, bulker segment. So we signed an agreement with Marubeni, a Japanese ship owner, to install 4 units of our Model 2, 26 meters on a Camser Max bulker. That's going to happen in 2025 when the vessel is dry docking. So that was the initial strategy. Let's do 4 installation projects, and then let's go to the market. But the truth is that regulations are pushing very hard, and I know ship owners are not very happy, but I am very happy because it's helping a lot. So some owners are already moving forward. So I can only disclose 1 additional project, but we have 3 more that we're working on. This one is a multi-purpose for the French Polynesia. They did a tender because they wanted wind propulsion on their vessel. We won that tender, so they will be equipping one of our units, and that's going to be our first new building. So just for you to understand what is the process to get wind propulsion. So the first step, and this may sound obvious, is that wind propulsion depends on wind. So savings depend on wind. So in order to know if wind propulsion is for you, and you means for your vessel and your trades, you really have to be doing a dedicated case analysis. This is something we're doing free of charge. Do this preliminary business case to see if it makes sense to explore wind propulsion. After that, if this makes sense, we usually recommend to go to a detailed feasibility analysis, both technical and economical, to answer all the questions. What is the best configuration for my vessel, number of sails for my vessel? What is going to be the cost of installation? So having the full picture, when this is done and you decide to move forward, the next step is doing the design of the transformation. So you have to do some reinforcement, you have to recheck stability, visibility, and all this has to be approved by class. So that's the next step. And when this is ready, then you go to shipyard, usually taking profit of a pre-scheduled stop of the vessel to get your vessel wind ready. So getting it ready to accommodate the sails. And the final step is installing the sails, which can be done at shipyard at the same time, or it can be done at a later stage at port. That's, for example, something we did with Amasus, with the general cargo. We did the installation of the sails at port. It took 4 hours during a regular port call of the vessel. Just 2 examples of what you can expect if this is your precise case. An MR tanker with 4 sails, 22 meters, trading between Europe and the US. Based on the wind, historical wind data for the last 13 years, the average savings that they could expect is 810 tons of fuel per year, which is about 15% savings. Another case analysis, Capesize trading from Qingdao to South America with 5 units, Model 3, 36 meters. Again, with the historical wind data for the last 13 years, so the average expected savings would be almost 2,000 tons, which is almost 18%. But again, if anyone is interested, I recommend to do a dedicated preliminary business case with us, again, free of charge, and it's going to give more information relevant for the decision making. And that's all. I think I was pretty fast. Maybe too much.
Thank you very much, Mr. Ferrer. Obviously, yes, you were pretty fast. Thank you very much for that. I have a pair of glasses here. They are Ray-Bans. I'm looking for the owner.
We are looking for a single owner.
Single owner. Otherwise, we are ready to take a bit. A bit. Come and get them.
I will take later.
Okay. Okay. Thank you very much. Our next speaker would be Mr. Vasilis Tsartsitalidis. He's working energy-saving technology, working for energy-saving technology for ERMA First, and he's going to talk to us about what else? Energy-saving devices. 15 minutes.
Thank you. Okay, so as it was already told, I'm Vasilis Tsartsitalidis. I work for ERMA First. ERMA First is already well known for their products in ballast. You've already heard about them for carbon capture, so I'll go straight forward into our presentation, which is about energy-saving devices. And I'll try to be a bit disruptive here and try to say that things are not always as we are told. So the challenge, obviously, everybody has seen this graph before. The fact is that vessels are going to be worse and worse, and in a couple of years, the majority of vessels will be class D or worse, so we have to do something. We've already pushed the speeds down, and it looks like we've already reached a plateau where we found the economical speed, so we can't go further down. Also, we have the carbon prices going up, we have the ETS coming in, we have new rules, so the cost is going up, and we don't know what's going to happen with fuels. So we need to improve our vessels, and we know we need to be at least 10%. And during this struggle, all the vendors are pushed to make bold claims, like big savings with low prices. So you've already heard wind say 14%, some claim up to 20. If you put ducts, they say it will be something like 3 and 8%. Cap fins will be something like 2 to 5. If you have a twisted rudder, you have more. If you have rudder bulb fins, more. And just those add up to a 42%, right? Well, the reality actually disappoints. So you don't always have wind. So and the average that we have measured so far is on the levels of 3 to 5%. And with ducts, only in good weather and only at the design speed and at perfect conditions, you will get those numbers. Also with cap fins, we see that the average is about 2.5%. Similarly with twisted rudders or with rudder bulbs. And obviously those also have issues with forces on the rudder stock, and you have to make sure that everything will hold. And the numbers don't really accumulate. So the total would be something like 10% marginally if you try almost everything. Of course, you can add more systems, but the problems don't stop with just the numbers blown out of proportion. Even if everything worked as we say, so here is a part of a study of ours for a PBCF type product. I'm going to talk about it later. And if it is well designed and to the point where to the operation profile of the ship, you see that if you go at a different speed, the gains are smaller. So the black line is the one you need to focus on, which is the percentage of gains versus speed. And you can also see, you can also understand that if it was designed for a higher speed, then you would have smaller gains at smaller speeds. So it's not a one design fits all. Also, the operational conditions like weather and things like that also affect. So this is from a study from NTNU about the gains while using a duct. And you see when the wavelength is close to the length of the vessel, which means that the vessel moves more, it's better not to have the duct than to have it, because it's not designed for wavy conditions. And also with any kind of assistance, either reducing drag or pushing the vessel or either with wind, waves, or whatever, I'm going to be slightly deeper here in propulsion. So if we look at the efficiency curve, which is the green one, a typical design is over here. And if you push the vessel, you move rightwards on the graph. So you might go to the optimal. But if your design is already optimal, then you will be pushed to an area where the efficiency goes down really fast. And you will have the engine unloading, and you have other stuff along with losing efficiency from your propeller. So you might be pushed like 10%, but the propeller, if it's not like controllable pitch, which might solve the problem by going with higher pitch, you have a problem there. And also we haven't said anything about heeling of the vessel and leeway, the drift sideways due to the wind, and we have to manage that as well. We don't have keels right now. But that doesn't mean that everything is in vain. So starting with the approach of ERMA first, which is being transparent and clear with our clients and having modular designs and trying to do the best of value for money. And of course, having the in-house expertise and doing one step at a time. We start with FlexCap, which is a PBCF type device. The difference from others is that it is modular, which allows us to have efficient production, but at the same time be able to adjust it and have it tailor-made for any single design that we receive. So it's never one design fits all. And we can go on with any case received, as I already said, I'm sorry. So I'm not going to go into the advantages, actually, because you already know the advantages that systems like that have. I'm going to go into going on with the narrative that I already started about having to be design specific and having to be adjusted on the case you receive. And here is an example of a case of a vessel. On the left, you see the original propeller. On the right, you see the propeller with flex cap. And in that case, you see that on the upper picture, you have the streamlines. On the lower, you have the pressures. You see that the twisted flow over here, it's being straightened out. So you took energy from the swirl. But there is also other cases where the propeller was quite well designed, and the designer took into account all those minute things. So they didn't have a strong hub vortex to begin with. I mean, like a hub vortex in the sense of having this twisted flow. But then again, you could have some gains by making the cap work as a smaller propeller, which will give you some extra thrust. Again, this means that you have to adjust to the design that you are given. Here are some savings from the first case that we already saw. And again, we can see that at different conditions, you have different gains exactly because it is designed to the operational profile of the vessel. And yeah, I think I'll take the question about it later. So even though we can see that we have gains of the order of 2.4%, maybe 2.5%, in the sea trial condition, we can see that in the latent condition, it's slightly smaller, and it's not real. You see that you have a quick drop on the latent condition, but actually the numbers are not that big. It's from 2.29 to 2.2. So it's not like the efficiency drops that much, but you see that the operational domain changes slightly the conditions. And since we are talking about how to make our vessels better, we are also looking into the future. So we are looking for retrofit applications, but also with way future applications where we have wind and fins and possibly some biomimetic stuff, which was part of my PhD actually, and try and see things in a different perspective. So yeah, actually I was also very quick, so that's my presentation.
Thank you very much. This is amazing. Everybody finishes on time. Okay, our next speaker will be Mr. Hakon Juel Hansen. He's promotion manager and business development manager for Holeby Gensets, for MAN Energy Solutions, and he will be talking to us about heading for zero carbon with MAN ES L21-31H methanol gensets. 15 minutes. Thank you.
Thank you, and thanks a lot for the invitation. I really appreciate to be able to talk about the Holeby genset in front of so many people. It's not happening every day, so I really appreciate that. My name is Hakon Juel Hansen. I'm based in Copenhagen together with Michael. We are colleagues. I haven't been there for 30 years, but only for 6 years as a global promotion manager and business development. I really appreciate being able to present our brand new development. We have now launched a methanol genset, methanol operating genset. I would like to introduce these topics. Methanol as a marine fuel, the methanol genset development, digitalization and the auxiliary systems, and then the summary. Methanol as a marine fuel, well, we have proven manned four-stroke small-bore engines being capable in operating on that. We have selected a standard engine from the standard program, so we base it on trusted, proven technology. We have the methanol, which is carbon neutral, green methanol. We have an easy storage of the fuel. We see that at our testing facilities, ambient temperature, ambient pressure. And we have selected also our low pressure fuel supply system. And so we inject with only 13 bars. So low pressure means really low capex as well. So what will the future fuel mix be? Yeah, but we will see fuels like ammonia and methanol. They are really ramping up towards 2050. So we see a demand in the market for methanol-fueled gensets. When we look at our strategy for the gensets, we have selected to have a strong focus on methanol as a genset, methanol-fueled gensets. We are ready with a genset within a short period to the shipyards. We are looking also long-term at hydrogen and ammonia. But as we heard before, ammonia is a great fuel, but it can hardly burn. So we see it as a very interesting for the two-stroke segment, a two-stroke engine moving 100 RPMs per minute compared to a genset that could really give big challenges burning ammonia in a relative high-speed moving genset. Hydrogen, we have the challenges in the supply chain, high pressure, low temperature. So we decided to move forward with the methanol. We already are having many years of experience with biofuel for stationary equipment, so we can also combine the methanol and the biofuel as a pilot oil, as we see the large tanker companies are doing today. Synthetic fuel oils and methane, we are capable with our dual fuel engines also. When we look at the methanol in the pipeline, our project pipeline in the company, so more than 40% in terms of power is actually methanol-fueled engine. So it is quite significant how that has changed, and it's changed very fast now as we see it. So, and we also see it on a broad segment, container, tank, bulk, and general cargo. So there is a demand for the methanol-fueled gensets, but also we see a big synergy effect where we have the MAN two-stroke LGIM methanol fuel propulsion engine, and we have a natural demand for the methanol fuel gensets. And also we have been working on methanol since 2017 on the two-stroke main engine. So of course this technology we can now transfer in terms of material selection, other experience to the four-stroke segment as we are doing today. So the genset development, we selected the 2131 as a basic engine because the characteristics of that engine is very good for burning methanol. So that was the first selection. And actually last week we also decided we would have the 27 bore working on methanol. These engines are very similar in the way they work. So that means we will also start development on the 27 bore. But the 31 bore is moving fast ahead now. We have also decided to use the port fuel injection. This operational principle will be used on all the four-stroke engines in MAN, so also on the large bore from Augsburg will be based on the same technology. We had the approval in principle from DNV, and they were agreed to our concept and our thinking, and they approved that earlier this year. We have the 2131, which is based on more than 2,500 engines in service, so and 55 million of accumulated operating hours. So it is an engine which really is trusted and well known in the market. And on this engine, we are then adding the methanol equipment. So we are not going to scratch and invent a high pressure brand new engine, but we take a trusted, well-known engine from the market, being able to give an output from 1,000 to almost 2,000 kilowatts, different cylinder configurations, and now we are capable in burning the biofuels and also the methanol on that specific engine. So the working principle of our engines for the four-stroke is the port fuel injection. So that means we are adding fuel to the engine in the inlet port. at a low pressure, and again, low pressure means low capex. We don't need a high pressure pump of 600 bars in order to bring in the methanol to the combustion chamber. We do it in the inlet port, and that means also we have no changes inside the combustion chamber either. So the main injector becomes then the pilot oil injector, and that means it's a relatively small changes we are able to do on the basic engine. And then, of course, we are selecting off-the-shelf components from Heinzmann and Bosch for the injection part, and that makes our concept really competitive. So when we see the fuel map, what we have today, the green area is the area where we can operate on methanol. And okay, I must admit, it's not the best, but we have presented this to the market, and the customers, they had really accepted it. And but of course, the first one here is a theoretical one we were obtaining. So we can see the more pressure, the more load we put on the genset, the smaller the amount will be you can operate on methanol. But if you work on 80% load and then you switch in 2 gensets going back to 35 or 40% load, then your operational area on methanol increases. And on top of that, you don't necessarily need diesel. You could also use biofuel as your pilot fuel in the blue area. So that's also some of the benefits we can offer with this engine. When we go to the testing, we have now a full-scale testbed at our propeller plant in Frederikshavn in Denmark, and we work with it's an 8-cylinder 2131, and we have now seen the points we can operate on methanol has actually been expanded. So it looks very promising. The first was the theoretical we made with a lookalike engine, but now with the real testing activities, we see that we can expand the methanol area. We had already the first order. We obtained an order in the car carrier segment for China Merchant, 18 engines. So this also a proof that we have developed an engine which is really is needed in the market. So it's an attractive concept and attractive prices. So this was the first methanol engine genset, and it's very important, as we heard also for the first order, the first reference going out in the market. The pipeline, as it says here, delivered the first engine in March 2025 to the shipyards. We are moving along now with all our testing facilities. We had the pre-sales release, and now we are moving into a full sales release actually this month of November. We are coming up with a retrofit design in 2024. It's a relatively simple changes needs to be done, so that would also be in our program. Digitalization, we know when we launch new products to the market, the crew, they really need support, the staff needs support to run the engines. So some of our concept, Prime Serve Assist, has also been very well received when we launch new engine technology. So this engine, the methanol engine, will be equipped with our Sarcos controller. And the Sarcos controller is in-house developed in MAN, so we have full control of that part as well as the turbochargers and the fuel equipment for the 4-stroke engines. So having this kind of controller, that actually gives the opportunity to work with remote monitoring with Prime Serve Assist. So the crew, they can get easily in contact with our support center, which is located globally as well. So if something is about to happen or something has happened, the crew, they can connect to us, and then we can bring in advice to the staff. This is the data only goes one way, so the other ways goes by SMS or email. So we have a high security in terms of terror or something should take over the engine. It cannot happen. It will always be coordinated with the staff on board. So these setups are ramping up now. We have more than 1,000 engines online. So our customers has very well received this, and I think this is the next step into the engine control technology, engine support technology, with also all these new engine types and fuel types coming to the market. The auxiliary system, I just have a sketch made up here where we have the methanol day tank, we have the 2-stroke main engine, fuel valve train, and the the methanol LFSS in front of that. And then, of course, on top of each genset, you need a valve train to supply the methanol to the genset. But it's a very straightforward. It's not a high-pressure pump. It works with 13 bars. So, yeah, really straightforward setup for the fuel supply. Yes. So, yeah, we will introduce it in the market in Q1 25. We will be using the port fuel injection. We will base it on the 2131 well-known engine in the market already. And we will also have it as a retrofit solution. So, yeah, that was basically my introduction here. Thank you very much.
Thank you very much, Mr. Hansen. It's amazing what a hammer can do. All the speakers were well within time. Okay, our last speaker for the session will be my friend, Mr. Antonis Strakakis. He's the technical manager for Marine of RINA, and he's going to speak to us about an overview of solutions for decarbonization of shipping. Antoni, since we are well within time, not 10 minutes, 12.
That's 20% more. Thank you very much, Mr. Chairman. First of all, warm congratulations to the organizers for this magnificent event. And of course, many thanks to all of you that joined us today. So the need to arrive at a net zero carbon future is pushing shipping towards new fuel solutions. And the purpose of this presentation is to make a quick review of the solutions currently under consideration. In principle, we can reduce CO2 in two ways, either by stop producing with the use of an alternative fuel, in which case availability and cost are the key concerns, or by stop emitting, which allows the continuous use of existing fossil fuels combined with carbon capture technologies. And as such, there are two solutions, the pre-combustion and the post-combustion. Shipping is a very competitive industry, and until now, when running on fuel oil, the main concern was the minimum fuel consumption for the transport of cargo from point A to point B. But for the target of reducing the emissions and operating in a multi-fuel environment, this redefines the frame of competition. What will matter is the minimum fuel cost, not anymore the fuel consumption, that will yield the required reduction of CO2 emissions when transporting a cargo from A to B. This means we can afford to run on to consume more fuel as long as this is less expensive. And this sets the new basis for comparison between the fuel solutions. The ideal fuel for the reduction of greenhouse emissions is hydrogen because its combustion yields only water vapor. And this makes hydrogen a kind of dream fuel, although this dream becomes very distant if on top of the high cost of hydrogen, we consider the problems related to its storage and transportation. And realistically speaking, it is not possible to expect that these problems can be solved in the coming years. The difficulties around hydrogen rightly turned the industry towards hydrogen carriers. But the discussion around alternative fuels did not follow any road of reasoning. There was never a distinction between what we have and what we need. No holistic life cycle study was made, and the proposed solutions have not considered a broader view of other sectors and the sustainability of humanity in overall. Sadly, it has not been appreciated yet that the challenge of decarbonization falls ashore in preparing the infrastructure for the solutions that will be used on board. We should avoid to follow the naive approach that if the engine technology is developed, then everything is ready to run on alternative fuels. This becomes even worse if we realize that despite developments in engine readiness, still very little is known about the lubrication of the new fuels. Ammonia has higher energy density and is a preferred carrier of hydrogen. But cracking ammonia in order to use hydrogen on board requires reactors which need at least 2 orders of magnitude of improvement to be used in a viable and sustainable manner. Today, for the production of 1 ton of ammonia, almost 2 tons of CO2 are produced. Although ammonia is not highly flammable, it still can explode in open air. SCR systems that are needed for NOx control produce more laughing gas, nitrous oxide, which is a very strong greenhouse agent. And ammonia is produced primarily from natural gas. So when the cost of LNG reached $1,000 per ton, the cost of ammonia was in the order of $3,000 per ton. Methanol is discussed as being corrosive, although it is highly toxic as well. Apologies. So methanol is discussed as being corrosive, although it is highly toxic as well. Even more, the combustion of methanol emits formaldehyde, which is very toxic and a strong poison with exposure levels of only half a ppm. We often talk about biofuels. We always need to bear in mind that all Arab land on Earth cannot produce enough biofuels for the transportation sector in overall. After MEPC 80, only streams of waste can be a feedstock for a biofuel, and this needs to be supported and proven by a certificate. The biofuels have low oxidation stability, which results in short shelf life, meaning they cannot be stored for a long time. Also, the biofuel is not the same molecule like an ordinary fuel. As a result, the addition of biofuels in concentrations above the 30%, which is the current norm, will require engine modifications to compensate for aerial ignition and possible effect on NOx, which usually comes at the cost of higher fuel consumption. Today, there are high expectations that green fuels can decarbonize shipping. In fact, today, all green energy produced on Earth is just enough to produce the quantity of a green fuel for shipping. Apparently, the green energy we produce is not going to be used only for shipping, and as a result, the hype around green fuels cannot be justified. It is very clear that although bio and green fuels will play a role in the decarbonization, but they will never be enough. So what happens when a fuel is in shortage? This graph describes that for many years, the price of fuel oil was following closely the variation of Brent, which reflects a mature and developed market. Just before 2020, when the new regulation limiting the sulfur content in fuel was entering into force, the need for VLSFO became imminent, and the situation changed radically. The demand for VLSFO was much more than its availability, and this resulted in the price of VLSFO becoming disconnected from heavy fuel and getting extremely higher. Therefore, a fuel in shortage means a very expensive fuel, and since green and biofuels will be rather in shortage, they will always be very expensive. The cost issue makes relevant the use of carbon capture, which allows to run on existing fossil fuels. The pre-combustion technology is applied on LNG as fuel and splits the molecule of CH4 into hydrogen, while it reserves the carbon atom as CO2. The hydrogen can then be consumed directly as it is produced, meaning there is no need to purchase and store hydrogen on board, while it allows to have as much hydrogen it is needed and at the time it is needed, by purchasing at all times only an existing fossil fuel, this is LNG. Therefore, both availability and cost issues are resolved in the best possible manner. An important advantage of methane reforming is that it is fully matured and commercially available. And since this solution is not anymore a novel technology, but a novel application of an existing technology. The CO2 can be separated from the stream of reformed gases with a physical process that does not require chemicals and involves very little consumption of energy, while it can be easily liquefied by the cryogenic temperature of LNG. The liquefaction makes its storage easy for disposal ashore later on. The carbon capture introduces a new concern, and this is how to handle the CO2 after it's been captured. Everything indicates that today we have reached a point where we need not to just solve a problem, but to decide which problem to solve. And applying this to decarbonization, we are requested to choose between either producing, distributing, storing, and delivering on board a brand new fuel, or simply deliver our CO2 ashore, for joining a stream from other industries, either for storage in depleted reservoirs or for the production of synthetic fuels. These industries are cement, fertilizer, steel, and especially the power sector, which have very intense CO2 emissions, far more than shipping, while they do not have any solutions other than capturing their CO2. Today, there are several such projects, while stronger climate incentives and continuous investments are building more momentum. Actually, as per International Energy Agency reports, there are already plans in place that in 2030 will amount more than 300 million tons. Our studies clearly arrive at the conclusion that by using LNG as fuel, the production of hydrogen on board and delivery of CO2 ashore can wait well after 2035, when CO2 infrastructure will definitely be available. On the other hand, reaching the same point with ordinary fuel oil will require a very generous reduction of speed, which will result in less potential for income, a fact that justifies the extra investment in LNG at the time of new building. The pre-combustion deals with the fuel before entering the engine, while the post-combustion has to deal with the exhaust gas, which immediately yields a huge difference in volume of installation and therefore cost. The term post-combustion carbon capture does not refer to a unique technology, since several processes and chemical solvents can be involved, while there are numerous parameters which affect the efficiency of the process, inevitably resulting in huge variations of CAPEX and OPEX. The post-combustion carbon capture with chemical absorption, which is the most developed solution today, is very sensitive to impurities, such as NOx, SOx, and PM. Due to its very complex structure, heat and mass transfer process, sensitive to hydromechanic and thermodynamic factors, the post-combustion carbon capture can be affected by vibrations. Another important difference is that a reformer can be applied in a progressive and scalable manner, which is not equally easy for a post-combustion system. This slide presents the work done by the University of Cambridge with the aim to assess the energy consumption of a pre- and post-combustion carbon capture system. Other things being equal, the pre-combustion shown with a green line consumes less energy than a post-combustion system shown with a blue line. This validation is very important. All studies conclude that LNG is the ideal fuel when it comes to carbon capture. And this study then concludes that when running on LNG, among the two options, the pre-combustion is more efficient and therefore more preferable. For many years, RINA has been perceived as the class for cruise ships and ferries. We need to stress that a cruise ship involves machinery installations that are much more complex than any merchant ship. In terms of strength, a cruise ship requires a global hull structural model and not a mere hull girder approach. The certification of cruise ships that RINA carries out involves many more drawings and requires a lot more high-level analysis and time. So we'll be very happy to class and certify any commercial ship as well. Thank you for your attention.
Adoni, thank you very much. We are well within time, so we'll have more than 10 minutes for questions and answers. While I ask the same question to the new speakers, the one I asked for part A, please think of other questions that you want them to answer. So for all the speakers, what are your concerns, main concerns regarding the development of your product? What are the limitations and how would you plan to overcome same, starting from right to left?
Yeah, okay. Yeah, but from a technical point of view, of course, when you inject the methanol into the combustion chamber, the way the mix up with air and the way it enters into the cylinder wall, which it shouldn't attach, that is really a critical issue to get the right mixture of methanol and air and have the right position of the injection nozzle and the depth of the ignition injection nozzle as well. Yeah.
Limitations?
Yeah, limitations, I see the fuel map is one of our limitations when we have selected this low pressure injection system. We will meet this knocking line, but we are working on it, and already our tests have seen that we are able to expand the area. So I'm confident we will get it further expanded and have a greater share of methanol in the fuel map. Yep.
Yeah, let's start with the limitation. So as I've already said, the big limitation is that savings cannot be that big. So, and you have to be specific on each design that you receive. So the big limitation is time actually, and drawings obviously. Well, drawings could be tackled by 3D scans or trying to, yeah, of course. Well, there are some ways through pictures, but you have to do too many assumptions. Now the challenge that we will have to solve sooner or later with most of energy saving systems is that we need them to also to be adjustable on different conditions. Because so far what we've seen is trying to solve one case for one speed, and that doesn't really work everywhere.
Yeah, and I think I don't know if you're listening to me, I'm going to extend the answer probably to the whole wind propulsion industry. I would say that the challenges are related to the maybe lack of information, which I see in two different things. There is a lot of numbers, information coming from different places, and I feel that for all the stakeholders, it's a little bit confusing. Okay, but it's clearly wind propulsion, what are the limitations, what are the difference between technologies, and how can I do my own business case? So I feel that the industry needs to give the tools to these stakeholders to be able to do that. And the other thing is transparency. I kind of tried to see it in the owner's place, and there's been several installations, but what were the results? Very little information was published on those results. What were the savings? What were the problems that they faced and they solved? Which may generate a little bit of reluctance, maybe. And that's why we're trying to publish everything, and we hope it's not going to be bad, because I already said that we will be publishing results from the EMS Traveler, and I don't know what the result will be. I hope they will be good, but you never know.
You can publish the good results.
But that's what I don't want to be doing. If they are not good because the vessel traded in an area with no wind, I want to be able to say that, because I think it's important to be transparent. And limitations right now, leaving apart this information, so this reluctancy, I think it's going to be manufacturing and after sales. One big challenge, limitation that we may encounter, and we're looking how to face it, is that in shipping, you're global from day one. So on the startup manual, you always say start regional, then your country, then Europe, and then expand global. But as soon as you put one technology in a vessel, you're global. So you have to give service globally from day one, and that is going to be a big challenge.
What kind of service?
Maintenance repair, at least being able to give that service from day one, it's going to be challenging and an interesting challenge to solve.
Well, from our side, RINA is not really a provider of technical solutions. We are just trying to support the decarbonization, especially under the hat of RINA Consulting. If I may express my concerns, is that we all recall that at the time of a change of fuel to VLSFO, all companies very reasonably made a cost analysis and they decided if it makes sense to go for scrubbers or not. Now we're talking about a new change of fuel, but the fuel cost is not mentioned by anyone. And you know very well the fuel cost is the most important cost parameter in the operation of ships. So I'm very much surprised. The other thing that really is a concern is that although decarbonization is a global problem, shipping has not opened the discussion with other industries. For many years, shipping was using the same solution with other industries, name it gasoline, kerosene, fuel oil, diesel oil. We were all using the same, let's say, solution for energy, for power production. Now that we go to a different world, what are the other industries which are the 97% of the problem going to do? Can we possibly share solutions with them? Why do we only consider ourselves in this world?
Because we are small.
This makes us even more open.
Any questions from the floor? Mr. Kourkoudis.
Yeah. Firstly, I will say that I noticed in the last panel we had the man proposing main engine with ammonia, and now we had the diesel engine with methanol, making clear that we do not have a clear path, actually, whether we go for methanol or ammonia. Everybody will be happy, but we will not have ships with main engine in ammonia and diesel engine methanol. This is clear.
I think it was more informative
Yeah.
to let us know that they can play on both fuels.
Correct. So we are back in that question we had before. And then a question for Mr. Tsarsitsalidis regarding this propeller cap that you propose, and we saw improvement of 2.4%. So this refers to what? It's improvement in consumption, in speed, resistance reduction, and also, finally, with a solution like that, what is the impact on EEXI and how you will prove this one? Will you make the calculations? You will do the revision of the EEXI?
Yeah, thank you for your question. Actually, the savings I showed was on power. So it's 2.4, 2.5 on average percent savings on power, which would translate in EXI to something like 1 or 2 grams, depending on the size of the vessel. I mean, for a small bulk carrier, it could be slightly less. For a big container, it could be much more. So it's not, you understand that 2% savings on power, it's not translated to the same EXI on all kind of vessels and all kind of routes. Also regarding the, sorry, I have to be closer. Regarding the estimation of, or the update of the EXI file, we can, of course, help you with that. We can give you all the documents you need. We do have the CFDs, but we could also agree on a trial protocol if you like it. Well, guarantees is a different thing, but who really gives you guarantee?
Pano prorated pay. Don't be black and white.
Thank you.
Thank you. Any other questions? Please, sir.
Thank you. My name is Alex Karkadzos. I think that the picture is very confusing here. First of all, slow steaming is not so effective, I would say. It might be profitable for high design speeds, but for low design speeds, it's not so effective. And then, if the shippers have tight contracts, then you will need more ships in order to put into the operation. Then the impact for the environment is zero or might be negative. So this is one concern. The other concern is about the prospects of the future fuels. Only hydrogen is a promising solution. All the others are interwoven with various problems. So I would like your reaction to my provocative comments. Thank you.
Who would you like to reply? Yes? Okay. Mr. Hadjigrigoris.
So today, what the technology that we have available is basically 4 fuels. It's LNG, it is methanol. There are no technical problems with methanol. There is a pricing problem for the fuel. It is biofuels up to 30%. IMO are promising that they will increase this percentage to more than 30%. When we say, by the way, 30%, don't expect that if you use biofuel with 30% biofuel, you will get a reduction of 30%. You are getting a reduction of 17, 18% if you apply the well-to-wake profile of the biofuel. And then we have LPG for the LPG vessels, and that's about it for today. Developing technologies are ammonia, and I consider ammonia as a developing technology. We have not seen an engine, a full engine operating. And whatever, hydrogen is a bit distant. Andonis said that we can apply LNG and then reforming and then carbon capture and storing the CO2. But we are complaining, and I'm not a ship owner, by the way, on behalf of the ship owners, that one solution is expensive. We say LNG, dual fuel, is expensive. And Andonis is saying apply 3 technologies at the same time. It will happen, it may happen. but it will depend a lot on how the fuel infrastructure is developing. I don't know if I answered your question.
Well, you answered in a sort of way, but I insist that the solutions, the solutions we see right now are not so promising. Another point I would like to make is the cooperation. Mr. Andonis Drakakis said that the cooperation between the land-based industries and the shipping industry. There is a synergy there which should be acted upon. There are the refineries, for example, the cement industry. You should cooperate with them, exchange ideas, because I'm afraid that very soon we will come in a deadlock. Thank you. And I'll start here.
If I may say two things. Number one, the cement industry is the cement industry, and they are getting huge grants from the EU and from their governments to create a carbon capture and a carbon sequestration network, and they are doing this. Unfortunately, shipping cannot do it for the time being. If we talk about liquid CO2 distribution, there is no such a network for the time being. And if we say, by the way, I'm working on a liquid CO2 project, we have to create 4 or 5 different infrastructures for fuels the way we go. I would not like to see a container ship powered with ammonia on the main engine and whatever methanol on the diesel generators. But for all these things, we need time. And for this time, we have to apply a transient fuel, call it transient. The selection is up to the individual.
Your question was very correct. But I think that we need to include in the discussion the time domain. That is, we don't need to apply ammonia and methanol tomorrow. The question here is, when is, as far as
Frank Sinatra is saying, because tomorrow never comes.
The question is, how can we delay the solution, the decision of a solution as far as practically possible? And our concept suggests that you don't have to do anything on a dual fuel ship before 2035. So at that time, if we have not arrived at a solution that will take us to 2050, the game is simply lost. So you have the possibility to start now with a reasonable extra cost, and then in 2035 decide what will be your ultimate solution.
Yes, Panos.
A comment regarding the additional tonnage and reduced speed. That we hear that if we have more ships on the water with reduced speed, actually, we have more pollution. This is not correct. As you know, a ship at 7 knots may burn 10 tons. At 14 knots, which is the double, makes 4 times more, 40 tons. So even if we have double number of ships, the emission is half of what we have with the fleet that we have today and at full speed running. Just to clarify this, it is not understood by all that more ships and lower speed, it's always beneficial for the environment.
But then, Pano, we have the NGOs talking about pollution, greenhouse gases created during the construction of a ship. This discussion is starting now. Wrongly, in my opinion, but...
Yes, please.
Can I be heard? Yes. Hi, my name is Stelios Bouras. I'm the chief editor at the Newsfront here at Naftiliaki. And I was wanting to ask a question to David. We've heard a lot about the limitations of the new alternative fuel sources, and in particular the infrastructure which isn't there, and the supply concerns, in that there's not that much to go around. In regards to the wind energy, you've done a lot of measurements. You mentioned the tests, the feasibility studies that you've done by installing your units on different ships and measuring performance. In terms of the supply of wind, what kind of limitations do we have there? Someone pointed it out before, that the wind isn't always blowing, and that there's an issue there. Is that something that can be measured, or is it something that you have done in regards to the supply of wind, which is the first thing I'd like to ask? And the other thing is, as an afterthought to that, is wind energy better suited to particular geographies? Do we have any data on that? It's better, it's more efficient in some parts of the world, perhaps. So that were my two questions. Thank you.
Yeah, thank you for the question. So I would say two things. One is about the discussion on future fuels. And one thing that I was missing on his presentation was that the solution to reduce CO2, it's dual fuels, or I don't remember. And what about reducing the fuel needs? I think the first step, you have the first step on reducing CO2 emissions is by reducing the fuel needs. And that's going to reduce the CO2 emissions and the cost of the future fuel, which is going to be higher, but you need less. And concerning the...
unless we talk about zero
of course.
carbon fuels.
Yeah. But if instead of needing 100 ton of fuel, you need 80 ton of or more expensive fuel, it's an advantage. Concerning your question, it's of course the wind, it's dependent on the trade. So the savings that you can get are going to depend on the trade. The numbers that I was showing is an average expected savings on that trade based on the historical wind data. So in some days along that trade there was no wind, and this is accounted for. But of course, it's geographically dependent. So if you trade in an area with a lot of wind, savings are going to be higher. If you trade in an area with lower winds, savings will not be there, and wind propulsion will not be for that vessel and that specific trade. And if you're trading worldwide, let's say on Trump, it's payback. It's usually acceptable. So that's kind of one of the messages. So if you look at the vessel trading on Trump business worldwide, payback is going to be fine. If you're looking at the liner in an area with no wind, payback is going to be terrible. So it is not vessel specific, but it's really geographically specific.
There was recently published in the newspapers that Berge Balk they will modify a VLOC with sales, saying that for the specific route they are going to they have a reasonable payback period. And at the same time, they said that for a sister VLOC in a different route, installing sales will give them nothing. So for the time being, forget about climate change. We have certain areas that sales will be an advantage. If we talk about currents, for example, everybody knows that if you go from the Persian Gulf around the Cape to the States and then through the Suez Canal back to the Persian Gulf, currents are always against you. You know what is going on. I believe it's something similar with the wind, and let's hope it will not. We will not run out of wind supplies. And from David, what is the limitation that your system has in terms of going upwind?
It's between 10 and 15 degrees, minimum operational. Port starboard. So the sails, the maximum operational wind speed is 50 knot, 50, and the maximum survival speed, it's 100 knot. That's specified by DNV and BV and all gas societies.
One clarification from Mr. Charsitalidis. In your last slide, you mentioned that the gain, the efficiency of your system is higher at lower speed and lower power. I was a little bit surprised that usually the maker of equivalent equipment like PBCF, they usually claim that the higher the power, the higher the efficiency. And there are some cases where we install any kind of energy saving device and you have negative effect because the power that the vessel is operating is far below the NSR. So I was a little bit surprised that the gain at lower speed, as far as I remember, it was 10 knots, 11 knots, is higher than 13 knots.
Yeah, thank you for this question. Actually, this is what I was talking about, that the system is specifically designed for the operation profile we received. So the usual thing that most designers will do is that they will design it for the design speed of the vessel. So they optimized for the highest load of the propeller, and they will give you the optimal and the highest gain at this point. And when you go lower, it will drop, and will drop a lot. It never goes to zero, but the maximum could be something like 2 or 3%, and you just got 1. On our case is that we optimize for the speed that you asked for. For that case, it was 12 knots. So in the area of the optimal, you have the maximum gains, but away from that, you see it drop. It doesn't drop a lot. Again, it drops to 1.5%. You still have some gains, but it's not that much. And I think this is pretty much with all the systems of that design. And this is actually adds to the narrative I already said, that all systems have to be designed specifically for each case. And to build up on what we've already discussed from the previous discussion is that we need to know all added things that you have on board, like other energy-saving devices or wind assistance or whatever, and have to adjust on that.
Since it's a new system and your competitor is very, very big, PBCF, do you provide any kind of guarantee or minimum saving cancellation?
What I can say is that I'm not doing the commercial here, so you have to ask somebody else. Maybe what Mr. Hadjirigoras proposed would be nice. So if we give you more gains, would you pay more?
No, pay as we go.
No, this has been applied by Korean yards for ducts, for a number of energy-saving devices.
Yes, please.
I'm Giorgio Barovino from Shell Marine. I have a question for Antonis. In previous conference, I heard your former CEO, Ugo Salerno, talking about nuclear. And I just would like to have your view about nuclear, if you consider this an option in commercial shipping, considering that is readily available for military application.
Well, as I mentioned during my presentation earlier, our concern is which solution will yield the required CO2 reduction at a minimum cost. Because, I mean, working in a shipping company for many years, my key concern was what would be the best use of the money of the owner? Or if I have to do something, how can I do it with a minimum cost? So yes, nuclear energy is definitely a solution, but does it build a meaningful and competitive business case? Because there are two different perspectives, the theoretical and the application. For us, what we care is the application. And although as a theory, as a technology is very correct, is very viable, very meaningful, very so many parameters, but when applied on board the ship, does it secure a competitive vessel? Does it therefore guarantee that the vessel will not become a stranded asset?
The numbers that I have seen, Antonis, about nuclear power is that if you apply a leasing system and you return your reactor back after 20 years back to the maker for enriching the fuel. And if you take into account that when you buy a reactor, you buy together with the reactor the fuel for 20 years, I think the numbers are coming closer. The safety issue is a concern, but what the suppliers of molten salt reactors are claiming is that the enrichment of their fuel is so low that cannot be used for weapons, number one. Number two, at the time, because the molten salt temperature is about 450 C, at the moment you have a leak, the fuel cools down and the reaction will stop. I don't know. I got nuclear power lessons in Athens Technical University, but this was 50 years ago.
Yeah, to add also to that is that an indication, actually the makers, they indicate that they are only interested in supplying very big ships like container ships and VLCCs, and the cost would be something in the region of $200 million.
Yeah, but if
And
you
of course,
take into account the fuel,
also, initially they said, okay, you are going to use your own officers and crew, and then they said, no, you have to hire ours, and they have to run the business. And another legal aspect is that if you want to sell the vessel, I'm sure they would not allow you to sell it to an Iranian owner.
But are you selling to Iranian owners now? Come on.
If we don't, we have one more. We can take one more question.
Hello, Lucas Michalitsis from Navarone. We're handling Hadimax vessels. I'm asking Mr. David, because we are interested, what are the limitations? Because I saw a picture with a Cape-size vessel, if I remember well, during the cargo operations, and if your sails are retractable and can be used also on crane vessels.
Yes, so we have an option that is tilting, so the sails can be, the sails can be tilted 90 degrees. Of course, on gear bulkers, it's, I would say, the second hardest vessel where to put sails after a container vessel, because you have limited space and you have to allow the port operations. I would say that probably on a geared bulker, the best position is forecastle, or, and this is some options that some owners are kind of accepting, is substituting one crane by one sail. But finding the right place where to put the sails, it's really a case by case. You have to look at what are the feasible positions. So I always say the same. When you look at that from an engineering point of view, you find the best position for the sails. And then you end up with the sails on the aft, as we did for the general cargo. Is this the best position? No, but it's the best from the available ones. So you have to be in discussion with the owner to know what are the best ones that meet your requirements. So there is no generic answer to your question, but on gear bulkers, I would say forecastle or playing with substituting a crane, maybe tilting on the sides. This allows still the loading and unloading, and it doesn't generate any issue with people walking on deck. So it really you really have to look at the details.
Thank you. I have a comment also in continuation to the previous discussions that I think that the implementation of the new technologies will be driven by the regulations and the market-based measures. Because I think when the regulations become stricter and also the market-based measures will be, how can I say, the initiated, the motivation to apply new technologies faster.
Yes, but the real question is if you want to order a ship for today or for the next 3-4 years, what do you order?
Sorry. It's very hard, yes, to.
Do you have any suggestions? No.
Interest rates are going up. Keep your money in the bank.
Okay, thank you very much. It's a good thing to see hungry eyes. Sorry.
Just one question, Yannis Makris from Angelakos. One question for David. How much is the minimum height of your tower?
20.
Sorry?
Minimum height.
The minimum height, because I saw in your presentation is about 20 meters. Can it go below 20 meters?
Yeah, the smallest one that we have is 12 meters.
And it's for which kind of vessel?
So-
Or is it a number of how many towers you install?
Again, this requires to know, so would you put a 12-meter sails on a VLCC? You can try, but you will not get anything. So the 12-meter height sails are usually for smaller vessels, as you saw the fishing vessel, for example. The larger you go with the vessel, the larger sail that you have to put if you want to have some relevant savings. So
And for an Aframax or a Kamsarmax?
for a Kamsarmax, I would say Model 2 or 22. So for example, the MR, it's 22 because the owner didn't want to exceed airdraft, current airdraft of the vessel. But we will be installing sails. Hopefully I will be able to publish that on another vessel, which is kind of a gear bulker, and they accepted 26, even though the airdraft of the vessel is increased. So it really depends. On an Aframax, I would go, model, depending if you want to increase airdraft or not. If not, probably Model 3, 24 meters, or Model 2, 22. I don't know the exact details of your vessel. And how many? How much capex do you have? And you really have to see what is the maximum number that you can put, meeting SOLAS, meeting ATEX, looking at the cranes that you have on board, what is the structure. So finding the right configuration or the optimal configuration, it usually requires a few discussions back and forth to find which is the best one.
Thank you.
Welcome.
So Antonis talked about cooperation between the shore industry and the shipping industry. The big problem that I personally have, I mean, as a concept today, is that I see the oil majors, and the oil majors are powerful. We agree on this? They are powerful, good. They go for different solutions. I mean, we had Shell a few years ago go for LNG, now they say hydrogen. We had ExxonMobil saying something else. I mean, the shipping industry is expecting from the oil majors that are selling the fuel to try to unify their approach.
Yeah, the difference is that Shell talks about hydrogen from LNG.
Whatever.
So they bless LNG still.
He's insisting on hydrogen.
Okay, thank you very much. We're going to have lunch until 2:15, I think. Thank you again for your patience and involvement.
The maritime industry is a vital global backbone responsible for transporting over 80% of the world's goods, and it is the lifeblood of our interconnected world, thus having an environmental responsibility. Over the last few years, we have witnessed a significant surge in the technological advancements tailored to make shipping more sustainable. These innovations span a wide range of areas, including propulsion system, energy sources, navigation system, and digitalization. Alternative fuels, we have seen LNG, hydrogen, ammonia, is game changers. These fuels produce fewer greenhouse gas emissions and pave the way for a decarbonized future. The prerequisite for the fuel of the future, of course, is security. And it is something that we have to take into account, the availability and how much it is user-friendly to the environment. On the other hand, fuel efficiency. We have seen technologies for advanced propulsion technologies, such as air lubrications, not in this conference yet, but we have seen winds and advanced coatings that are improve the energy efficiency of vessels. Renewable energy integration, like wind-assisted propulsion, and of course carbon capture technologies promise to reduce CO2, and if a sustainable solution is emerged from the methods, in my opinion, it can be the leader in the near future in order to be able to reduce our CO2 carbon, at least for the first years. These technological innovations hold the potential to bring about significant improvements in the maritime industry's sustainability. The sustainability of shipping is a collective responsibility. Environmental excellence mandates collaboration, collective intelligence, and knowledge sharing instead of sterile competition and isolated actions or even hidden results of tests. In that framework, our panel is consisted of distinguished guests from various functions of the industry that each will share his view regarding this interesting topic. We will start with Mr. Marcel Vrinsen, which is the Global Sales Manager, Digital Service, ABB, who will present overseas product. Mr. Vrinsen, you have 15 minutes.
So, let me first introduce myself again. My name is Marcel Vrijsen from ABB. I'm the Global Sales Manager for Digital Service within ABB. First of all, I would like to thank Newsfront and Nafti Liaki for the opportunity to present our new solution. Oversea Fleet Support Center as a Service is a collaboration between ABB and Wallenius Marine. Throughout the last decade, Wallenius has learned that adding additional equipment and additional support systems did not necessarily provide the benefits that you would expect. Training the crew was one of the solutions for that, and it was an improvement. But as crew can change, the benefits seem hard to maintain. Therefore, Wallenius and ABB decided to join forces and centralize the knowledge with our specialists at the helm. And so without further ado, our specialists at the helm, you will see here a captain and a chief engineer who are at our operating center in Stockholm at the moment, where they are managing fleet and where they are looking at the performance of these vessels. And they are continuously improving vessel operation and operating performance. So to go into detail of what that means, the technical performance and voyage performance that is there are the pillars for the environmental performance as well. So in here is the possibility to add a lot more data inputs and different type of data that you would want to take into account. And Oversea is then the tool that is used by the captain and the chief engineer to support the vessels on their technical performances. So looking at the collaboration in the market, we are trying to establish a collaboration between, in this case, ABB and Wallenius Marine, but also to take in the data points and the data of other suppliers so that we can actually share all the data in one complete package and have one total insight for the client in the end. So at Oversea, we have decided that we want to step away a little bit from the new ways of powering ships, the new ways of ship design, but just look at what is currently out there, what we are currently operating, and making sure that we are smart in the operations that we do, and to improve the performance that we are actually having at the moment. By taking all these data points, we have the possibility to take on additional data and provide engine tuning, conditioning, whole foul management. So we actually do this for our clients. This means that whenever there is a crew on board that has a question, they can communicate to us. So to take you into Oversea, I will just show you what it is that we are looking at when we are presenting our clients with the product. So in this platform, you see that there is on the left-hand side a few vessel names and a few vessels located on the world. And there is already said that, okay, there need to be some actions, some to-dos. So when you go into the fleet overview, you see all the vessels that are connected to it and all the data that comes in. Looking at that and you go into the to-dos, this is actually a ticketing program where actually everybody is seeing the same thing. So our specialists are looking at this data and they get a question from the ship and they will get a high critical answering protocol, which means that they need to take action, look into the data and present it back to the crew with an answer of, you could check this part or you could check this type of statistic on board. It helps to communicate with the crew and take the insights and turn them into measurable actions. This means that there is a log for both the crew, the support center, as well as the client representative to look into what is happening with my fleet, what is happening at this moment, or when there is an advice coming from our specialists at the helm, they can say, okay, what is currently going on? But it's open communication, so full transparency between the owner, the operator, and the fleet support center, which gives this the benefit of driving these actions. There's a lot of systems and a lot of software out there that will provide you insights, but these insights are then given to the operator, and the operator needs to make sure that it's happening. How do you measure that it's happening if you do not have a good closed-loop communication system between the vessel, the support center, and the owner? So if we go down into the analytics of the document, you get these graphs that we've seen a lot today and that we will see a lot in the future as well. But this is a fleet overview where you can see all the different vessels and their performance together in one overview. When you go from that analytics view, per example, you have main engine and hull propeller shown here. But you can also go into a group level where you can decide which class of vessel you want to see in your fleet. And there's a difference. So you can decide if you only look at one class type of vessel or you look at multiple. And with that, you have this compared overview of all your vessels. And then there is the basic vessel level. So you go even one step further down and you look into the vessel data and you can see what's going on with the vessel at this time. It shows here a green line. This is the ideal CII situation if everything is operating to perfection. There is a black line in there, which is basically an attained monthly level. So it reports back, this is what you attained on the CII level. And then there's a blue line running in there that shows you a 12-month rolling average period where this data comes in. So as you can see, you can go very deep into the data and we can go even further down, but it's basically mainly based on how can we add more data so that you have a complete overview so that you are actually taking the right type of decisions made on the database and on the logs with your crew and personnel. Here's an overview of the technical part of the vessel where we go into the overconsumption and the reduction thereof. And as you can see here, this is specifically hull and propeller. So when we talk about coatings, etc., and the resistance, that this is a big part of it. It is because you can see here that the spike created by the resistance and the coating either needed a hull cleaning or a full new paint job. It gives the data, and that data is in a certain trend. So it makes sure that once you look at a data and you plan a dry dock, let's say 5 years, but after four years and 3 months, the operators in the office will actually see that there is an increase, a steep increase of this resistance and overconsumption, then we can actually contact the crew, we can contact the owner-operator to ask about what is the plan for the dry dock? Have you planned the hull cleaning? Is there a potential to do this prior to the dry dock in 9 months? Because if this steep increase continues and you just stick to the maintenance plan of, okay, we have a dry dock, so at the dry dock we will see. But by having a hull cleaning, it already drops or increases the performance so much that your overconsumption drops again to a baseline which is acceptable. But this is basically given to you by the KPIs from the people that oversee. So the people in the office are monitoring your assets while you are operating your vessels to make sure that your shipping routes and everything is continuing in the right way. Then there is the different performance when it comes to hull and propeller. You can go even deeper. And this is a 3-year period visual. And as you can see, this is where the dry dock and the anti-fouling again come together, where you see a massive decrease of overconsumption. And this helps. And these trends and these data are coming in 24/7, and the operators are looking at your vessels all the time, and they give you an advice. This advice is logged, your crew can see it, your owner can see it, and with that you can turn it into actions, but you also see that the actions have been done. Then we can go to the specific fuel overconsumption, where we can actually look at it in which type of heavy fuel or gas oil has been overused, and it comes with the efficiency, a baseline towards the overconsumption. In here, we could also say that some of the suppliers to the industry are actually now already delivering us data directly into Oversea, where we don't have to do anything specifically. So this is already a collaboration between ABB, Wallenius, and third parties, where we actually take the data literally from some other producer. And this is where it comes into play, where it's so important to share this data. Then we can go into main engine condition overview, so you can go towards parts, spare parts. How can we make sure that we plan buying spare parts, let's say 6 months earlier, because we know that we do condition-based maintenance, so we look at the numbers, we see when something is rapidly dropping. So if the trend is wrong, we will contact you. And it could be that the spare part is having a fault. It could be something else. But we log everything, so you can actually see also if spare parts have been bought according to the right specification. Is it lasting long enough? Are we having enough of the data coming in for making sure that you extend a dry dock or an overhaul? So when you are operating in this way, you actually also get an extension, which is approved by the notified bodies, where you can actually extend from 100%, now you need to change everything, to it's condition-based maintenance, so you can actually go up to 160% of the lifespan, which saves a lot of money, which gives you a benefit that you can actually order spare parts, perhaps 6 months ahead of time, 3 months ahead of time. We all know that this week, next week delivery is the most expensive one, so we want to avoid that. And all of this comes into one package, and it's driven by our people in our office. So we take data, we turn them into insights, and then the people in the office will actually take the insights and drive them into actions on board. Thank you very much.
Thank you, Mr. Vriesen. And next is Mr. Markus Scherer. I hope I pronounce it good. Okay. This is the General Manager, Technical and Services from Shell Marine, and will present us today how to navigate the maintenance challenges of two-stroke engines.
Well, maybe I start by introducing myself. It's that I'm Markus Scherer. I work for Shell Marine. In Shell Marine, I lead the technical and service department linked to lubricants. And we help and support our customers to make sure the engines and main engines are well maintained, and they are well lubricated, and they are in a good shape. The next slide, sorry, I work for a very big company who insists that you go through all this in detail, and no. The only text here means don't do any trades based on what I'm telling you today. Then I can skip that slide. So you can make your investments, but not based on what I tell. I would not do it anyway, but it's very hard. I have to tell you, okay? I go back. Do I get another 4 hours? When I joined Shell Marine, this is, oh my God, 24 years back, something revolutionary happened, and totally not linked to me. Shell Marine introduced a second cylinder oil. Can you imagine? After I don't know how many decades of having one cylinder oil and 1 gram per kilowatt hour, that's the golden rule, we introduced a 40 BN cylinder oil to cope with low sulfur fuel you've bunkered usually in the south of America. This was revolutionary. The whole world was driving nuts, and chief engineer said, what can I do? And I have 2 cylinder oils, and I don't know what to do. And it was a lot of work that had to be done to explain to crews how to deal with 2 cylinder oils and 1 fuel. Today we have 5 cylinder oils in the market, and we have countless fuels, and you have heavy and low and whatever, and bio and FAME and LNG. We heard all these fantastic names. Can you imagine how the complexity for these poor people on board has increased? How difficult it is for them to cope? How much help they need to convert the service letters from engine manufacturers into what does that mean for me on my ship with my fuel and my configuration? Well, we see a lot of things. The combustion of very low sulfur fuel oil has changed the focus from corrosion control into deposit control. Total new world. We hardly looked at it. We took samples, Reynolds samples. Is it good? Yeah, it's good, wonderful, no problems. Today you can have a drain oil sample which is fantastic. The report will tell you wonderful, continue, but in reality you have deposits and you are just about to scuff your liner away. The second one is visual inspections are becoming far more important. We heard a lot about data, and I love the data story, but you still need to watch your engine and you need to go and see, because deposits are very hard to convert into data. Visual inspections are incredibly important. It has an increasing need, and I loved the ABB story. There's an increasing need of capture data, of having a good record, of having evidence that you've done your work properly and follow trend lines. And last but not least, there's far higher emphasis that records are kept. You can be more or less sure that OEMs become less and less tolerant if you don't follow their guidelines, and you can be sure that insurances are becoming less and less tolerant if they see that you haven't done your proper reporting and your maintenance and your monitoring of your engines. I think that's the problem statement, but now let's tell you why I'm talking about this and what we see in the market. And I show you real-time pictures, I show you real cases, and the codes of the vessels are not IMO codes, these are internal codes, so don't even try to find out what ship it is, but it's real ships, real cases we have today and tomorrow. So, but first, let's see what the OEMs are saying. Is it possible to get the slides on the screen, by the way? The OEMs are very clear. If you look at the, cool, thanks. If you look what MAN says in the new service letter 737 and 738, they cannot be clearer. Do drain oil analysis, make your cabin port inspections, proper analysis once a month, make onboard data, check your data, and check your scavenge port and the deposits once a month. Very clear statements of the newest service letters came out 2 months back. WinGD, same statements on their lubrication advice. And it has been there for years. It's just that, and I'm so thankful to MAN that they did that. MAN made it super explicit, but in every service letter there was always a small line saying, do your proper monitoring. If you looked at during IMO 2020, we had some claims and cases, and there have been issues. Guess how many ships have been able to provide a proper report on demand based on the claim. We had 52 claims who came to us. Guess how many ships reported proper report? We say, okay, give us your coating, give us your fuel, give us what you have used. Make a wild guess. The answer is 0. It has not happened, and it's still not happening properly in the market. We talked a lot about EEXI, CII, new fuels, the crew, new lubricants. We see 4 components. Well, we see obviously the fuels, and it really doesn't matter which fuel you take. You can take very high sulfur fuel oil, FAME, biofuel, methanol, if you get it, LNG, and you can take 2 future fuels. It really doesn't matter. The system will remain the same now and tomorrow. You can take loops, because the fuel and loops, we always say the fuel is here to kill your engine, the loops is here to protect your engine, so we need to keep this in balance. Then we have the engine itself. What is your trade? How quickly are you running your engine? How fast are you? Do you go on economic steaming? Yes, no. We can see, and not always, but we can see in our data a crew change. We can see in the pictures if your crew has changed or not. That's how sensitive the place is. And then obviously we have the crew himself. And honestly, my biggest worry in the future is the crew. These people are already today overwhelmed, and we add complexity, and we add complexity, and we add complexity. Whatever we can do to help them is obviously a blessing. All these challenges are coming together in a relatively small place in your ship, which is the combustion chamber. There is the lubricant, the fuel, the engine, and the knowledge of your crew is coming together in a very small place. Hence, we are so interested what happens there. And if it goes wrong, you can see cold corrosion, you can see scuffing, you can see deposits and all the problems. If you keep this in balance, you have no issues. And we call this loop monitor, our service, and we call it the feedback loop. And if you think it's a digital tool, no, it is not. It is exactly what we've done the last years, but we have now intelligent zeros and ones and software who is helping us to respond far better. So what we collect is, we collect the cylinder oil you are using, we collect the feed rate, we collect the fuel content as a base information. Then we want to have pictures of your scam import inspection. Pictures are incredibly important. We have onboard test tools, and you can use your own, or you can buy them from us, or you use what you have on board. We really don't care. If you get the data from your ship, you send it to us. If all is good, after 60 seconds, you get a report. Don't worry, all good. If you don't get a report after 60 seconds, you get a phone call from a technician who looked at it and gives you advice. And last but not least, we have lab testing. There's nothing better than a sample. A lot of people say, yeah, sampling is old-fashioned. There is no industry on this planet who invests more money into research and development than the health industry. They care for your body. If you go to your doctor, what is the first thing he takes? He takes a blood sample. Still, after all these years. And he has millions of dollars of machines, but they take your blood test. And the lubricant sample is the blood test of your engine. And there we can see if there's something we can help you and can change. So now let's go into real cases on how, if you make proper condition monitoring, how this can help. First of all, when you get a new build, the most important thing is running in. If you don't run in your engine properly at the beginning, you will have issues for the rest of your lifetime. Still, this is not done properly in the field, in reality. If you look at these pictures, check condition, reduce feed rate, documented. We started with 1.5 gram. We ended up with 1.04. You see the wear going down, which is normal for a running in procedure, and then stabilized. And then you have an engine who is in the right shape with a stabilized wear conditioning. Running in is number one. If you look forward, then we have 2 distinguished problems. Problem number 1 is, and it depends on your sulfur level, if you have high sulfur, you need to care for cold corrosion. If you are on low sulfur, you need to care for deposits. In both cases is to find the optimal feed rate. If you are find the optimal feed rate regarding depending your sulfur content and the sensitivity of your engine. Looking into cold corrosion, well, you need the minimum feed rate to lubricate your engine, but you need more lubricant to accommodate for the sulfuric acids in your lubricant and make sure they don't go to the cylinder wall. Hence, you need to find the right feed rate. Here we have an example, and you need to find the right lubricant. Here we have an example. We have a 100 BN lubricant on the left side with 1.2 gram. And you see at the very top, you see heavy wear and corrosive issues. Now you can say, I need to put more, but more doesn't help. More will lead to deposits. What you need to do is you need to move to 140 BN, and you can even reduce your feed rate. Then you see that the corrosion will go down. And you can only see this if you do proper condition monitoring. And more lubricants is not always good. If we talk about high sulfur fuel oil. It's about the BN, taking the right lubricant and the right feed rate, and then you see good results. That's the consequence of the picture you just saw. Top ring length, the coating is nearly gone. Recommendation is move to 140 PN, and we solve the problem, and reduce feed rate. And you see, it's always the top ring who starts first, by the way. There was a huge drop. If you don't check this and you don't immediately react, then you can wait for the problems to come. The next one is deposit control. And now in the world of very low sulfur and future fuels, that's the most important one. You need to aim for the absolute minimum feed rate. Over-lubricating will result in deposits. The point is that wear is very low. The coating thickness is stabilized, wear is very low, wonderful picture. If you look at the engine itself, we see that the picture is not so wonderful. There are deposits. And these deposits will stuck your piston ring and will cause issues at some point. Here the advice was to move to an Alexia Cat 2 X40, optimize the feed rate, which is even reducing the feed rate, and then you can clean up your engine. How this looks in reality, I would love to show you a picture where the engine is totally scrapped up and Shell came and we helped, but that's what we are not interested in that. We are interested to find these small spots. Because if you see these small spots, nothing has happened on your ship yet. Nothing at all. And we can make measures and we can clean it up. And between 8,200 hours and 9,900 hours, we cleaned up the whole piston rings. How does this all work? Well, there are three key tasks on board. Onboard testing, chemistry board inspections, oil sampling, and then send operational data. We collect all this in our Shell Loop Monitor portal. We look at it from a technical perspective, and then we give you technical advice or tell you everything is wonderful. And it's a huge tool, so if you can go to the next slide, someone. Good. And Marcel said it before, you will see more graphs. You can see your whole fleet. You can see if your fleet is red, green, if the drain oil has been done or not. You can see trend lines by your fleet or by one ship. You can dive into your cylinder. You can dive into your engine. You can see all the details of your engine, and you can even see the pictures. And you can share this with, it's anywhere shared with our experts, but you can share this with MAN. You can share this with your engine manufacturer, WinGD, with your service providers, and we can find solutions. So if you take three takeaways away from now, they really managed to confuse me. It's, first of all, please, and if you, okay, my 15 minutes, if you buy it from Shell or not from Shell, or if you are a Shell customer or not, we give this service to whatever customer. You don't need to buy loops. But if you take one thing away for you, please look at your engine. Funny stuff is happening in your engines, and please monitor it. Disconnected from Shell or whatever. Take a holistic approach. It is required to monitor your cylinder conditions. And make sure you establish trend lines as long as the world is nice and you haven't changed something. If you change adding new fuels, or you change something, or you go on low speed, then the trend line will move, but you need to know how good looks like. Then you see if something is happening. The second one is, if you are worried about service letters, am I in line, am I not in line, a tool like Loop Monitor have all the new service letters and requirements already incorporated in the tool. You are always safe that you follow the guidelines from the OEMs. And last but not least, I only had 50 minutes and I'm overrunning in 30 seconds, sorry for that. And if you want to learn more, then contact our local Greek team. They can show you the tool, they can help you, they can explain you, or call me. I can try to connect you to the local team because they are far more experienced than I am. Thank you very much for your attention.
Thank you, Mr. Serrer. I'm sure you are going to have a lot of questions. that. Now we're going to have Mr. Lefteris Kokoulopoulos from DMD. He was going to present an update on the decarbonization options. 10 minutes, please.
Good afternoon. My name is Lefteris Kokoulopoulos. I have been working in DNV team, in DNV advisory for the last 5 to 6 years. And recently I'm responsible for decarbonization activities in our region. Today we will try to do an update on decarbonization options. We have seen a lot of things today, many technologies, many ESDs, so we'll try to wrap up everything and understand why we are doing this. Okay, the complex problem of decarbonization starts from regulations. We don't only have CII, but now we have regulations that are translated in additional financial costs for our vessels. We mainly refer to EU, who is regulating first. We have ETS, we have Fuel EU around the corner, and IMO, who is planning to copy the system and maybe implement something similar. So what we are doing for our vessels is not only good for less fuel, but only to gain from the additional taxation. Luckily, we have a lot of options. We have a wide palette of measures. What it is important, I think this has been highlighted in today's conference, energy efficiency is at the top. We are talking about energy efficiency in the form of operational improvements. Our companies are doing a lot of things for operational, in the daily operational practices, but stricter monitoring of several parameters can squeeze out any additional benefit or remaining potential for savings. Then we are moving to technical measures. Technical measures can be hydrodynamics, improvements in hull shape, in the propeller, or machinery that they are measures that adding new technologies in the engine room system can reduce the specific energy consumption of the whole engine room. Once we have secured and we are certain that we are doing everything for efficiency, we can proceed to newer fuels, alternative fuels. And not only fuels, but alternative sources of power, like we saw today, a lot of things about wind. Alternative fuels can be renewable, sustainable fuels that are using recycled carbon, so anything that has to do with CO2 taxation, you can gain a lot. Lastly, of course, we have carbon capture technologies, or how we can also call it exhaust gas treatment technologies, where you can capture CO2 after the exhaust gas stream. Starting from the first point, operational measures. There are many. I have selected a few. Speed reduction, a quite controversial measure because, as it was stated today, we have done anything we do for speeds. We cannot further reduce speeds, and also managers and owners cannot decide this alone. And also, speed reduction at a wider spectrum can mean increase of the global fleet, depending on the demand of tonnage, of course. Another thing is better scheduling, port optimization, or how we'll have to call it just-in-time arrival. Currently, vessels are waiting a lot of time at ports when they have not arrived at their slot, and they are burning a lot of fuel in the auxiliary gensets. So minimizing this anchoring waiting time can bring a lot of benefit for all metrics, indexes, and taxation schemes. Lastly, hull cleaning. It is being done by most of the company, but if we strictly monitor the KPIs and the metrics for hull performance, we can certainly have a few more gains. And autopilot, we are seeing a lot recently newer algorithms, AI algorithms that by optimizing the rudder movement can give some energy efficiency benefits. Continuing to technical measures, two large categories, better installations in the propeller, like we saw today, propeller retrofit, PBCF, we have seen some technologies, ducts, any kind of ducts that we are seeing both as retrofits and as new buildings and now continuously, better coatings for anti-fouling and even ultrasound anti-fouling, that it is a newer technology that we have recently seen, and air lubrication that starts to gain a lot of traction. We don't see it only in LNG carriers, but we start to see it even in bulk carriers and tankers. For machinery measures, we have engine tuning. Engine tuning mainly refers to electronic engines where you can optimize the specific fuel consumption of the engine at lower loads, because most of the engines are currently operating at lower loads than designed. We have a self-generator in the form of power takeoff, which again is on the table while it was abandoned for a few years, and we only were seeing this in containers mainly, but now we can see it also in tankers and bulk carriers. And there is a good combination also with air lubrication for the system. Some yards are offering this option where the extra energy, then extra electricity you need for air lubrication, you can harvest it from the main engine with the PTO. Then we have auxiliary economizers. You can install additional economizers for the exhaust gas stream of the gensets and then return some steam to the engine room in order to be used in the several machinery components, as well as variable frequency drives and LED lighting technologies. Once we have secured the efficiency measures, we can proceed to fuels, to the first category of fuels that is currently being tested a lot. It is being bunkered by a lot of vessels, are biofuels. Biofuels is also is a desired solution because currently a conventional vessel that is either delivered now or being built right now, it can secure its lifetime being compliant and minimize the financial impact of the new regulations by introducing biofuel during the last years of her lifetime. And also it is available in two major ports in Rotterdam and Singapore, so it is something that we will see more and more. But probably as we move to 2035, 2040, biofuels may not be enough for newer vessels. We will need at some point as a shipping industry to shift to carbon neutral energy. We are referring to fuels that are produced from sustainable biomass. They can be electrofuels, fuels that are the result of the synthesis of renewably produced hydrogen and captured carbon. But this, we cannot do this alone. That was underlined in a previous presentation. We need collaboration between industries. We need collaboration both to avoid shifting the emissions that we gain from shipping to another industry, but we also need collaboration in order to secure the optimal, the best solution for each industry. For example, to secure biofuel quantities for industries that are hard to abate, like aviation, which is already doing it, and shipping. And alternative fuels is not a myth. It's something that is already happening. It can be captured from the current order book. 50% of the current tonnage that is in the order book, not yet delivered, will be burning some kind of alternative fuel. Mainly, for the time being, we refer to LNG and methanol, but these vessels in the future, they are expecting to burn the green versions of these fuels, either LNG, green LNG, or green methanol. Lastly, there are not only renewable fuels, but also renewable energy. Wind is abundant out there, and it will continue to be. We saw some numbers today. Our estimation SDFV is from 5 to 9% efficiency gains from what we have seen with many projects. And there is also an optimistic figure here, 25%. 20% we saw in a previous presentation. But this can only happen at an optimal route, in a steady route that the vessel is covering. They are here. 28 large cargo vessels have installed some kind of this technology, mainly the two first ones, rotor sails and rigid wing sails. And this number is expected to be doubled based on the order book. There are some challenges, not a lot of challenges. There are challenges. The main challenge are reliability, port constraints, that there were some questions also in the previous presentation, that with retractable solutions, we try to tackle this problem. And crew training, of course, which is, I think, and that was said a lot today, the problem not only for this technology, but for any new technology that we're installing on the vessels. Some key points that we can keep from this presentation. There is not one solution. I think everyone understands this by now. We will have a combination of solutions in order to comply and minimize the financial impact from the coming regulations. First and foremost should be energy consumption, energy efficiency. We can build more efficient vessels by doing simple things, and then consider additional options, further options like alternative fuels. Alternative fuels, they are a part of the long-term strategy of one shipping company, and it is not a switch that you will start burning only this fuel from one year and other, but flexibility is going to exist. You can burn traditional fuels until you can, and you can pay the tax, and then continue to other greener fuels in the future. Lastly, by doing this, we underline this again, we need to avoid shifting emissions from our industry to another one. Also, this is the concept of the regulations, both from IMO and EU. And the transition is here. And it is going to increase. 6.5% of the current gross tonnage operates on some kind of alternative fuel, and this is expected to reach 50% in 2028. 20 vessels are currently using wind-assisted propulsion technology, and we also have 250 vessels having installer planning to install in the next 2 years air lubrication systems. Thank you for your attention.
Thank you, Mr. Kokolopoulos, for being just in time also, and this gives room to our last presenter. Last but not least, of course, Mr. Liapis, the president from the Hellenic Institute of Marine Technology, will discuss about being green and smart and how the ways of artificial intelligence can help decarbonization in shipping. We can give you 15 minutes because it's a huge...
No, it's open. Thank you very much. And for the invitation as well, the organizers. Good afternoon, ladies and gentlemen. So, a little more theoretical talk about how artificial intelligence can really help decarbonization in shipping, and maybe what will be the main aspects of implications with that. So, okay, we know we're talking a lot about decarbonization, even if shipping is a small pollutant, as a matter of fact, less than 3% of the total greenhouse gas, man-made, let's say, man-produced greenhouse gases. It's a big pollutant, and so it must reduce its greenhouse gases emissions. So decarbonization is really a big challenge, and after all the new ambitious targets that we have now, even from IMO, the revised strategy on 2023, we know that we have to do a lot of things. Unfortunately, as all the speakers said before, we don't know exactly what to do or if there is no just one solution. So we'll need a number of solutions and also a number of strategies in order to help these solutions to achieve their targets. So the role of artificial intelligence is the talk of the year, the talk of the time, what we do with and how do we use really artificial intelligence, if we have benefits or if we have even dangerous risks by using it. So yes, we strongly believe that artificial intelligence and all the supportive technologies will help really the decarbonization of shipping, using tools like machine learning, data analytics, and of course predictive modeling that can serve all the to exploit all the vast amount of data that we collect now, big data that collect from all the operations of the vessel. So the main thing is really to optimize the operations, to reduce fuel consumption, and enhance the energy efficiency in order to succeed these targets. So, of course, optimizing ship operations is the #1 target of that, because we know that the best way to succeed decarbonization in the short term is to reduce fuel consumption. So anything that optimizes the operations that we have and, let's say, shorten the routes or allows us to travel with a lower speed, this will really make an impact right away, and we don't have to wait for solutions in the distant future. So we must avoid adverse weather, taking advantage of favorable currents, and taking all the information the ship captains can really help themselves in optimize the routes and reduce their fuel consumption in every trip. For example, Yara. You know, Yara is, as a matter of fact, a fertilizer producer, but as the company uses a lot of vessels in the Norwegian fjords and etc., they use a lot of technology in that. They have made the first semi-autonomous or maybe autonomous vessel, and also they use the artificial intelligence and machine learning in 2 vessels, in order to see what's going on with that and if it really helps them. And as they really remarked and noticed that the vessels were really much better in fuel efficiency, and so they will keep on the trials with the specific technology. And this is the real thing, is that how can artificial intelligence really can help us reduce fuel consumption, of course. And what we can do with artificial intelligence, we can do better. One thing that we should do all the time, I mean, collect all the data from emissions, from engine, from fuel consumption, from weather, etc., and then exploit them in a better way. And the good thing with artificial intelligence technologies is that with the machine learning techniques and tools, it really can improve every movement that we have, and then also suggest best practices that with all this data collected, the human mind cannot really achieve to do that. So artificial intelligence can detect and prevent also any engine deficiencies, and also suggest and propose, let's say, maintenance plan that will be much more efficient than the plan that we already have. We'll see how we'll do it. So we have all these sensors, all these AI-driven systems that we can have now that can monitor and control all of the various ship systems, like lighting, heating, cooling. And so in this way, if we can really monitor and make all the adjustments in early time, we can really spare a lot of waste energy, which is until now we didn't think about that, wasting energy. I mean, so these systems really can make real-time adjustments, and AI can manage the power and distribution, especially when we have in the near future hybrid or electric vessels in small ferries. In this way, the energy management system is really much better when you use artificial intelligence techniques. Also, we can have much better predictive maintenance with artificial intelligence tools, as a matter of fact, because we can gather with Internet of Things all the data from the sensors from the engine, from the funnel, from the exhaust, and temperature, etc. And so in this way, we can have proposals for a better maintenance plan, and having this predictive maintenance, we have less damages and, of course, less fuel consumption. And as a matter of fact, Rolls-Royce, which is a well-known marine engine manufacturer, but also is doing a lot with airplanes, with airplanes engines, they have developed an AI system for exactly for predictive maintenance, and they're very happy with that, seeing that they have much less damages and also less fuel consumption in their engines. Critical for this subject is, of course, the emission monitoring, and measuring and monitoring all the emissions is vital for the compliance of environmental regulations at first, and also can predict in an accurate way in real time, taking all the data from the ships and calculating, let's say, the environmental impact of the vessel. And of course, this allows better control and management of emissions. And we know that when we have problems with emissions, it means that we spend fuel and we waste energy. Another aspect that AI sure helps a lot is the routing optimization, and the choice of the routes is significant. We know that slow steaming is as we said before, is the first measure that we can take, and the most, let's say, bringing the best results and accurate results in reducing fuel consumption. So when we have AI techniques in route optimization, then we take into account a wide range of variables like the weather conditions, the traffic, the port congestion, and so we must have a more eco-friendly and efficient route, and in this way, of course, we reduce fuel consumption as well. Maersk, as a matter of fact, one of the world's largest shipping companies, and its work has to do a lot with logistics, of course. They use, in a big part of their routing, let's say, software, they use artificial intelligence, and as a result, they have reported a significant reduction in fuel consumption and emissions. As a matter of fact, CTO of Maersk said that they are heading towards a zero-touch logistics. Now they use artificial intelligence in the software that we use for routing in a percentage of 15 to 20%, let's say, of the total logistic tasks, but they expect that in 7 years' time they will use it in 80% of their logistic software. So this is really significant. And we have also in weather forecasting, which we know in weather we have a lot of data, we have big data, which is quite difficult to use and make some useful information about the weather forecast on that. And this is exactly what really artificial intelligence thrives. We have already big companies that have developed tools for that, like Huawei, for example, NVIDIA and Google, that really change the way that meteorologists see the way to predict the weather. So it helps a lot, of course, with shipping as well. And in general, it helps with logistics, and not if we see the intermodality, as a matter of fact, and we know that what we want to see with vessels now, especially with the CII in force, is that we don't need congestions in ports, we don't need bottlenecks and things like that. And this is really a field that artificial intelligence could really help, especially to better track containers in container shipping logistics, to better match drivers to containers and better manage capacity issues in order really to optimize all the supply chain. And in the supply chain, of course, the vessel arrival, for example, in a port, calling the port, and the way to decide the speed that the ship captain will use in order to save fuel, and this will help a lot all the supply chain to go greener, let's say. But of course, we don't have only opportunities with artificial intelligence, we sure have some concerns, risks that we can have. So we're really concerned about data security. We must collect a lot of data in this route, and we know that at the moment we have problems with hackers, we have problems with piracy, and in this way we must really be sure that these data are secure, the data collected by the shipping companies mainly, or the supply chain operators. We have also to see subjects about reliability, because the systems, of course, in the systems would have errors. We could feed the system with wrong data, for example, and when you feed something with wrong data, you will have wrong results, as a matter of fact. So we must be very careful about that and need the careful management on that. Also, implementing artificial intelligence systems at the moment is not a cheap procedure, and its cost, and the small or medium-sized shipping companies are not able to afford the technologies like that at the moment. And one of the biggest problems right now in implementing systems with artificial intelligence, Internet of Things, or machine learning technologies is the personnel. There are not enough trained and experts on this field to use them, not only shipping, of course, but in land uses as well. And they need a lot of training. The crew will need a lot of training, a lot of skills, different skills that they have at the moment, acquired at the moment. And so there must be, they should use a lot of the shipping companies, a lot of training in order to be sure that they have crew that are skilled in this way. And of course, we must see also regulatory compliance, because we must ensure that this, the use of the data in this way, it's legal, and we don't have legal problems or financial penalties. So in order to really implement all these technologies in a safe way in shipping, we must have some key developments to see in the future, in the near future. So we must have a greater integration of such technologies in the day-to-day operation of shipping. We must see increased autonomy in a lot of operations like this. Of course, improve collaboration between all the stakeholders in order to everybody can gain from the enhancing this technology. To see also advanced sustainability metrics, because sustainability and decarbonization is our main target, and also to see global efforts to this direction. So concluding, we see now that artificial intelligence has emerged as a powerful ally in the global emission target to decarbonize shipping, of course, but this can happen through mainly the ship operations optimization. And in this target, we have to reduce, to see the reduction of fuel consumption, the energy efficiency, predictive maintenance, emission monitoring, and more. So it's a revolutionary, let's say, technology, but it needs some way in order to see that we have it as a day-to-day, everyday business. So we have challenges, we have risks that exist, but we have a big potential, and so we must really work on this, in this field and in this target. And as technology advances and as regulations evolve, we can look forward to a maritime sector that is not only more sustainable, but more efficient and, of course, more innovative than it was until now and ever before. Thank you very much.
Thank you, Mr. Liapis. Thank you for staying in time also. That concludes the presentations for the panel. We are moving to the Q&A session. So if there are any questions from the floor, please, it is time to raise your hand and shoot the question. Anyone? So, oh, yes, please. You can take the microphone, maybe it's working over there.
Yes, you said that the 6.5% use alternative fuels. When you refer to alternative fuels, what type of fuels do you refer to? Do you count in the LNG or not?
Yes, we're only referring currently to LNG. This is the fuel that is currently being burned for dual fuel engines. We are talking about mainly dual fuel bulk carriers, the dual fuel tankers, and they are burning LNG when this is needed, not always. They can still continue burning traditional fuels for certain voyages, but they are also burn LNG during part of the voyage in order to reduce their CO2.
I don't see LNG as an alternative fuel.
It is not an alternative fuel, you are correct. It has carbon, it is not an alternative, but we mainly, when we are saying burning alternative fuel, that they will burn the green version of this fuel in the future. So they have the engine on board, they have the fuel tanks, they have the piping, the deck structure, so they are ready to continue in the alternative path in the coming future. Currently, LNG can be considered alternative fuel from one side because it can give 20% CO2 reduction from traditional fuel. So for the time being, and the regulations are not currently so strict, ETS, for example, fuel is not here, is not yet in the picture, but even for CII and other regulations, it is a short-term measure that will switch to another. They will switch to another fuel in the future. Thank you for the question also.
If you allow me, just for that, because we talk a lot about LNG. It is an alternative, but not a renewable fuel. But it was always considered. Yes, it is. It is. But the idea, especially with the European Union promoting that, it is a bridge fuel, and after 10 years or so, we will have biogas, a lot of biogas that will be 100% renewable, theoretically, and so we'll have the same vessels, the same infrastructure, the same supply chain, etc. So that's why we promote, I mean the society or... Yeah, okay.
This story with the LNG is misleading the people. Okay, some of us you understand, but most of people don't understand. So by presenting such figures, you are creating an idea to the public opinion that something is taking place. But very few things are taking place now, correct? We are very far from the point of decarbonization. By presenting such figures and including LNG, that is a clear carbon fuel, you are misleading people, especially young people, institutions, public opinion, journalists. They believe that something is going on. 6.5 is good, but it's not good. Maybe we have to be cynical and say the truth to the people, that we have a long way to walk until that point. Okay.
You are correct. We have a long way in order to reach the targets. 6.5%, this is something that we see now. and it is going to pick up. It is a change. It is something alternative. We didn't have, we were only seeing LNG for LNG carriers. And at that point in the past, that was a great step because LNG carriers were burning diesel oil. So they moved to LNG. Now we are adopting this solution and we're installing it on other vessels, tanker, bulk carriers, or even containers. So it is a first step. It's not a baby step. It's a first and very important step. And this is going to pick up. It is truth also that 50% of the order book, they are vessels that are going to burn LNG. So, and also this is a conservative approach because when we were discussing previous panels, we were seeing that the most conservative way to go now is a conventional vessel. Installing, either preparing a vessel, making LNG ready, that a lot of owners, this is what they are doing now. They are preparing all the infrastructure in order to switch to LNG when they need it, not now. Other owners are building LNG-fueled ships. So it is something that is happening. We are not at the end of the way. You are correct. We have a lot of steps to do, but this is the beginning. We need to start from something, and we start something that is proven from LNG carriers and other industries.
Any other question, please? Yes, please.
I was the head of decarb innovation at Maersk until a month ago, and I really like the conversation about applications of AI and latest technologies to look at decarbonization because different ships have different needs. They operate at different routes. All these technologies are great, but one needs to zoom out and kind of preventatively look at things, analyze the vessel, analyze the specifications, where it operates, and then look at what can be done with things as they are to reduce the fuel consumption, improve efficiency, and then going from there to the next step, looking into available technologies, how they fit together to improve it, and then going from there further into, okay, advanced technologies, because choosing ad hoc things, maybe one fuel, another fuel, like it will lead us to wasting money because we will start and then a regulation will come in 2 years later and we will have to reinvest in certain things because now that slip is not acceptable anymore. So I really love the conversation about technologies, and I think that's one thing to embrace. Like AI and machine learning actually takes us to the opportunity to look into the future without taking risks today to make a good decision for the future. So thank you.
Thank you. Thank you for your comments. Anyone else has any other question? Mr. Chairman, maybe.
Yeah. Number one, and I don't want to insult anybody, I don't think that Maersk is the best example to follow. They have ordered massively methanol ships, and they did not wait to see what is going to happen. They have started just now, maybe 15 days ago, to question what they have done with methanol. Number two, if we talk about 100% zero carbon fuels, then we have to exclude ammonia. Ammonia needs pilot fuel up to 15% at low loads. MIN may say it's 10% and not 15%, but I'm not going to argue on this. Even more. Let's be kind to MIN. So this is about Maersk, and remember that Maersk are both owners and charterers. Trump Shipping, they have charter parties. They have to follow the charter parties. The charter parties are saying you have to do 15 knots per hour. Sorry, per hour, yes, for the whole day, and they will not look. Most of the charterers will not look at what the weather is or the way the ship will be traded. Sorry. Yeah.
I just wanted to clarify that I don't say that Maersk was right with all of their
No,
decisions.
I said it.
No, because they are my former employee. But I just wanted to say that from that position that I had to kind of look into future 2030, 2040, and look into, I was playing in that field of future, right? And looking at technologies that can drive us there. So that is just a clarification, not saying that one is right, the other one is wrong.
Okay.
But enablers
If
of
you
technology.
allow me to say one sentence about Maersk, if you remember 5 years ago, they were saying scrubbers over our dead body. Now they are asking their owners for chartered vessels to install scrubbers. So Maersk is a big organization. I don't think Greek shipping should follow Maersk. We may have better examples, I don't know. Now, this is about route optimization and Maersk. Coming to the cylinder oil issues, I hate the MAN service letter. What they try to do with their service letter on lubrication is to move responsibility away from them. And the poor chief engineer has to do whatever, to select between 2, 3, 4, 5. He has to do the sweep test. And I do the sweep test today in Singapore, where humidity is whatever, 80%, and then I go to a dry place and my cylinder fails, so you have scuffing. How often can we do this sweep test? So the MAN objective, right from the beginning, as far as lubrication is concerned, was to move responsibility away from them. We have no objection letters now for the lubricants. We don't have approval letters. For me, it's clear where this is going. How many cylinder oil tanks should we have on a vessel? One, as we had in the past, 2, 3, 4, how many? 5, as many as Giannaki? Shut up.
First, I think there are enough MAN colleagues in the room who can answer the MAN question. I'm not going to do that on their behalf.
No, I'm just, that's a kind of statement.
You don't need a lot of oil tanks if you are clear on what fuel you take and what the operations. Well, you know if you take a very high sulfur fuel, you know if you have a scrubber or you don't have a scrubber. I think that one you should know.
This is basic, yes.
That one, if you know if you have a scrubber or not, yes, then you know you don't take high sulfur oil.
Correct. But
if you don't take high sulfur oil, you don't need 100, 140 BN at the first place. We are down to 3.
Yeah.
The one is a 70 BN, and to be very fair to MAN, they came up with a very clear CAT 2 strategy, which is if you are on high sulfur fuel oil, you need 100 or 140. You need to make a choice, because I showed on the pictures how easy, you can find out if you need 100 or 140, depending on your engine. If you don't need the 100 and 140, if you have an MA engine, then it's a CAT 2. It's our Alexia 40XC, so you only need one tank.
And what happens if you take fuel in South America, where the sulfur content is 0.8, 0.9, 1, never above 1 sulfur? What happens? I mean, we have seen, maybe there are people in this room that had cylinder liner failures, yes, on the way from South America to Cape, yes, Town. They stopped at Cape Town to renew all the liners.
If they've done that, then it's always the balance between the lubricants. And again, I think MAN, I'm not saying I love the service letter because I need to read them 3 times, and then you need to take a breath, and then you need to understand, and then you need to convert this into something which can be actioned on a ship.
And do a sweep test?
Yeah, well, the sweep test you only need to do if you're on high sulfur. But the majority of the fuels are on very low sulfur or on ultra low sulfur. And then it's very simple. You need a CAT 240 BN oil, and you need to adjust your feed rate. The level you have to play on your ship is your feed rate. And obviously, if you never do any inspection and you wait until your engine scraps and you wait until your liner are scuffed, well, then you miss something between getting the fuel and adjusting your feed rate. And that's the whole project. If you look into your engine, if you do onboard monitoring, and you might take, if you know I got a new fuel and I'm in a critical stage and I have an engine where I know it's a sensitive engine, then maybe you make your onboard test.
What is a sensitive engine?
A sensitive engine is an engine who might scuff, might have more sensitive to corrosions. You have a feed rate factor, and you know your feed rate factor or the old ACC factor, whatever you think is what you're going to take.
Yes.
But then if you do your onboard monitoring and you send data and you have a trend line, you can adjust your feed rate before your liner or your, well, it's usually not the liner, it's the piston ring, and it's deposited on the piston ring. But nowadays, we see not much wear. With low sulfur fuel oils, we see not much wear, and ultra low sulfur. And MAN is very clear. As long as you make sure that your piston rings are freely running, you even don't need to change your liners between dockings. It can go up to 5 years. And I can show you on a slide, just to finish, I can show you on a slide that we have cases where we can go up to 20,000 hours and the liner is still intact. But if you don't do your maintenance and your liner is scrapped, well, is it MAN or is it you who haven't done your maintenance? That's probably the question you need to ask yourself.
But you know, in year 2000, 2002, when MAN introduced the S90 engine, and then it became the S90 ME, we could go from overhaul to 36,000 hours, and we had a cylinder oil consumption of 0.4. And these were numbers accepted by MAN.
And again, there are sure MAN people in the room who can easily...
The solution for me, we have MAN people here, if they want to speak. So the solution for me, the only solution is online iron content analysis, online.
You can't make, sorry, but it's very hard to make an online iron content analysis on drain oil because you have no constant oil stream. Drain oil is a two-stroke engine. It gets scrapped and it disappears. You can put a sensor in it, but the sensor cannot measure. The sensor can only measure if you have a stream, and it can only measure an oil stream, and there is no oil stream in your two-stroke engine.
Then how do you do the analysis of the stuffing box drains that you do? We do analysis of the stuffing box drains.
There you have a constant oil stream.
You have to wait for a while and then do the analysis. But this will take 1 hour, 2 hours, 3 hours to collect the sample from all cylinders, and then you can do the analysis. I mean, it's...
that's what you are, then you have not been very attentive to my presentation, I have. Because I showed...
No. I'm talking about online. There is a difference between online and do it manually.
Online is possible for the system oil. Online is not possible for drain oil analysis. It's physically not possible.
Although MAN a few years ago, they were talking exactly about online cylinder stuffing box drains analysis. They were discussing it, and then they forgot it.
Because they realized there is no oil stream in a two-stroke engine.
One.
It depends how diligent you are with loop monitoring and monitoring your cylinder conditions. If I would say 1, max 2.
Okay.
Please.
I have one more question for you. When you mentioned that you have 5 different types of cylinder oil, it came to my mind the possibility, and I do not know if this is possible at all, to have one base oil and a mixing mechanism for additivation package with additives, what I mean, and change the alkalinity level to the desired level. I do not know if we have come to that.
Yeah, well, Maersk had an onboard blending system and the onboard blending device. I'm not sure how successful they implemented and if they are still using it. The challenge nowadays is that it's not only about alkaline and BN. Meanwhile, the new Cat 2 cylinder oils are highly complex oils. It's not a commodity because what MAN told us, they want to have, the benchmark is 100 BN oil, and they want to have a 40 BN oil who has the cleanliness ability of 100 BN, but only 40 BN. So if you only think about BN, that's not going to help you. You need far more additives. And for us, it's research. For us, it was 2.5-year research to come with the right additive package to produce our product. So for the one Cat 2. Then there's the normal Alexia or cylinder oil 40, which is not Cat 2. You can still use it if you have a Vinci D engine. There's the 70 BN who eventually will phase out because it's a bit in between the high sulfur and the low sulfur at the moment. I think this one will phase out anyway. There is no guidance anymore to use it, but never underestimate the stubbornness of a chief engineer. If they love the product, they keep the product. But there is no guidance from both OEMs to use the 70 anymore, and then you have the hundreds. But if you want to compensate that, either you have 5 additive tanks, and I just learned you don't like many tanks on your ship, if I got the mood correctly, or you need to do your own blending, or you buy an additive from a finished additive package, but then you have the whole blending risk on your ship. It's not as simple as that. It would be a nice solution. Look, my dream would be, as an oil supplier, mine would be one grade who fits all problems. Because having 5 grades or 4 grades, for you it's a problem of 3 tanks. For us it's a problem of a global supply chain of having 5 grades, which is a financial nightmare. If you would have 1 grade only, it would be fantastic. That's our dream, but technically not as easy as... Did this answer your question? Or? Mezzo.
By the way, there are systems in the market that allows you to mix used system oil with cylinder oil. We had 2 ships in Zodiac doing this. There was no financial gain from this exercise.
I just wanted to know if it is possible to match the requirements to the exact, not separately or after the...
Ah, yeah.
But to go exactly who you need.
It is, yeah.
Specific requirements from time to time based on the conditions and the bunkers that you have on board.
That's okay. Okay, I misunderstood the question. That's physically possible. That's from an installation perspective, you need to have a blending unit on your ship. And if you talk about competence, capability of crew, for me the biggest concern is how do the crew follow all these changes. I think they already are overwhelmed. Now you won't expect them to start blending lubricants. This will not work automatically. You still need to do the drain oil, you need to check, you need to find out, you need to adjust, you need to have the sulfur level. I mean, if you want to build a small lubricant blending plant on your ship and you trust your crew, they can manage this on top of all the other challenges, and you have the investment to have a blending plant on your ship, then I think it's theoretically possible. I wonder we match all the criteria to make this successful, to be honest. But theoretically, yes.
Thank you. One last one, because we need to change the panel.
I heard with great interest Dr. Llapis's presentation, and I'm not trying to shift the responsibility from our side, the ship owners and ship managers, to any other sector. But I would like to know how the port logistics and are coping with AI. I see that there is a very large room for improvement using AI for streamlining the port operations. We find ourselves arriving at ports at maximum speed or less than maximum speed and waiting there for 2 or 3 weeks to discharge our cargo. We could have arrived at a much lesser speed and consumed much less bunkers rather than wait for the port to let us come in and discharge or load. AI would, in my opinion, would dramatically improve this part of the chain.
You're right. It is a big challenge. As a matter of fact, automation in ports happens mainly to container ports or container terminals in ports, as a matter of fact. We don't have many of them. I think it's about 20 ports now that are automated and about 35 to 40 that are semi-automated. But all the plans from greenfields, for greenfield ports, which are not many, of course, they are planned 50% of them to become automated. So I think they're trying to integrate very much this because of the congestions and the bottlenecks, which is a big problem, really. But I'm not sure from the, 600 major ports that are in the world that they will proceed really fast in integrating artificial intelligence. Mainly because of people. I mean, it's a big lack in the market in specialized people that can integrate such things. And when we talk about bulk products, this is even more difficult because automation mainly takes place with containers and the container stacking and container moving in inside and warehousing and etc.
Thank you.
That at ports there is no pressure to adopt these technologies.
They're in between land and sea, and nobody. And there is a big change in the in who owns in the ownership potential. Now they privatized many of them, etc. So, as a matter of fact, they're in between two situations. I think that take 10 years time in order for ports to really change.
Thank you for the questions, and this is the end of this panel, Mr. Chairman. Mr. Brandelos. Thank you.
So I would like to thank Mr. Hadjigrigoris and the organizers, and I would also like to thank you for spending this evening with us, especially this very nice day with the nice weather outside. We're going to be as brief as possible because we are about 30 minutes or so behind the schedule. So we'll try to be fast. Hope our chairman will not shut down this session at 4:30 and will give us some more time, at least to complete the presentation and possibly to have a couple of questions at the end. So I'm very happy and very honored that I'm hosting very distinguished panelists this evening, and together we are going to explore how can a ship operator navigate the complex regulations sea. So we have our panelists, which are very experienced with knowledge on operation, and I think we're going to get their insights, their practical and pragmatic approach and view on what is the impact of this ever-changing regulatory regime. We're going to start with the perspective of classification societies. We are going to have the presentations, maximum 10 minutes, and then we are going to have the discussion at the end. Unfortunately, Mrs. Labardaki will not be able to join us because of a personal health issue. So I would like to invite Mr. Kourbelis from Lloyd's Register, Strategic Business Partner, to start the presentation.
An interesting fact is that, again, it was November, many years from now. I had my first panel participation with Mr. Hadjigrigoris as chairman. The night before, I did not sleep. I said he will tear me apart. Surprisingly, he didn't ask anything, so I said my presentation was a total failure.
I think it's your size.
So many years after, he can still tear me apart, but I'm now enjoying it. I learned to enjoy it. So thank you, and thank you, Stamatis, for hosting this panel. I will try to be brief and say a few things, mindful also that we are late in time, in schedule, about how we are navigating through changes within the IMO. And IMO is one thing, but the truth is we have fragmented regional regulations everywhere. We do have the European Union regulations, EU ETS, and Fuel EU Maritime. The Chinese are thinking of doing their own thing. We don't know exactly what it is yet. The texts are in Chinese, they are not being disclosed, but it's something similar to ETS. The United States Clean Shipping Act is adjourned, it's postponed, but we do think that something will happen in that end of the Atlantic soon enough. And recently, this July, IMO, with its revised greenhouse gas 2023 strategy, started seeing things and starting to regulate things with a different perspective other than the initial strategy of 2018. So the aim and the goal of the strategy is to phase out emissions from shipping as soon as possible, close or by 2050, promoting a just and equitable transition, while IMO specifically says avoid offsetting emissions from other sectors, from outside the ecosystem of the marine energy industry. What exactly it was agreed this July is that we moved away from the 50% reduction of emissions as set out in 2018 strategy, and we're moving towards a net zero environment close or by 2050. This net zero means that the accounting and the perspective is on a life cycle basis, well-to-wake basis, well-to-wake approach, meaning that the production and the distribution pathways of the fuel will be well accounted for. This practically means that each fuel will be assessed on the basis of if it was produced by natural gas or renewable energy, but I'm sure that you have heard that song many times today, so I'm not going to lecture you on the fuel production pathways. I'm going to stick to the important things of the strategy and the key things that are to consider, meaning that now the strategy says we aim at net zero by 2050, but it has introduced some indicative checkpoints, meaning 20% reduction compared to the baseline of 2008 in 2030, and 70% in 2040. Someone could say, okay, it's an indicative checkpoint, it's nothing mandated, there is no actual target or resolution driving this, but we are going to see this very soon. In the strategy, it was also introduced that a small percentage, 5 striving for 10% of the energy used on board by 2030 should be from zero or near zero emissions technologies or fuels, meaning that wind assistance could be eligible for such a reduction, or other zero-emission fuels, meaning hydrogen-based fuels. How IMO is planning to achieve this in the mid-term? On the short term, we have CII. CII will be reviewed by 2026, and the short-term measures may take another form, or I don't know, there's someone else talking about short-term measures. Mid-term measures. Mid-term measures are the ones that will help drive the IMO's decarbonization goal, meaning that we expect for them to be adopted by 2025 with aim of entering into force in the beginning, the first quarter of 2027, if we do the IMO accounting on how much time do we need between MEPCs and stuff like that. These measures are on top of CII and on top of other compliance measures, meaning it's something new, it's something different. And these midterm measures will basically consist of two things: a technical element, and by technical element, we mean a greenhouse gas global fuel standard, and an economic element in the form of a greenhouse gas emission pricing mechanism. The global fuel standard, very briefly and easily explained, will resemble a lot the way that FuelEU does the emission accounting, meaning on well-to-wake perspective, emissions, grams of CO2 per amount of energy, per megajoule, with a baseline and starting point around 94 grams of CO2 per megajoule, which is equivalent to VLSFO, or close to VLSFO, and we would expect a reduction curve similar to the target set by the IMO greenhouse gas strategy as we move towards 2050. In order to give you a brief idea, the fossil fuels, VLSFO, HFO, are around 90 to 93 grams of CO2 per megajoule. Sustainable biofuels are in the order of 35 to 50 grams of CO2 per megajoule. Also, the blue things, the blue ammonia, the blue methanol, are in the same order of magnitude, around 50 grams, give or take, depending on the blend or the origin, grams of CO2 per megajoule. And the green fuels that we are discussing about are at 7 or 8 grams of CO2 per megajoule. So you can understand that it's a big curve to take, a lot of things to be considered, especially where there are no green fuels available right now at mass distribution scale. On the important thing, the economic element, we don't exactly know what it will be. In the strategy, it is referred as a greenhouse gas emission pricing mechanism. So there was a lot of debate during last MEPC. Many delegations disagreed with each other, so there was no consensus reached on what it should be used. One opinion was a global greenhouse gas levy, meaning a flat rate per ton of CO2, multiplied by the CO2 emissions. The other option was more of a sort of, and don't take my word as it is, just to explain the mechanism like a fee-based mechanism, a mechanism rewarding the good performers while penalizing the underperformers. So there was no consensus, and the major aspect of disagreement was that this economic measure should promote a just and equitable transition across all states, meaning that every member state does not have the same needs, the same economy, or the same dependence from imports and exports. So what IMO will do, it will do a comprehensive impact assessment on states about the potential and candidate midterm measures. This impact assessment will be presented at MEPCs, and following consultation with states, the final measure will be presented. And I think Stamat is looking at me.
1 minute.
Yeah. You switch it off. Stamati, will you switch it off? Okay, so thank you. Thank you very much, and thank you for keeping me in time.
Thank you, Theo, and apologies, but we need to keep the schedule. So we'll continue with Mr. Dalmiras, CEO of Adriatic Shipping, who is going to provide us what is the operator perspective in terms of the IMO short-term measures. Thank you.
Okay, where is my time? I don't see it in the way. Thank you all. Thank you, Mr. Hadjigrigoris. Thank you, Natasha. Thank you all for inviting us in this panel. So, challenges, engineering and fixes. A short presentation of what we have done in order to comply with short-term measures.
Let's see that.
Okay, so challenges, we wouldn't say so. Now that we have the entire context and everyone knows what to do, so we consider that what needs to be done is good collaboration between qualified partners, either within the company or externals, and aim to the maximum possible effect, which is quite sustainable, it's achievable. We had to comply with EEXI technical measures and CII operational measures. In the specific case, we refer to a series of Suezmaxes and a series of LR1s. Suezmax required a large engine power limitation, while LR1s were marginally compliant. And as for the CII, it was a matter of performance optimization, accurate reporting, and projection from a technical operator point of view, of course. With regard to the Suezmax tankers, we did the market research of the available energy-saving devices, actually off-the-shelf available energy-saving devices, nothing fancy, I would say, that could be potentially applied in order to improve efficiency. We assigned a classification in order to do a feasibility study and project the expected 5-year saving based on previous operating profile. We procured the equipment. We performed the pre-dry dock trials to understand where we stand before the dry dock, and having actually a calibration of the performance monitoring system that we tried and installed beforehand, as well as torque meters. We did all the job during dry dock, including full hull blasting and painting with premium anti-fouling paints. In dry dock, we did all the retrofits. We did a 3D scanning of the entire hull, focusing on the aft part where the appendages were installed. We had the post-dry dock trials, not official, of course, with class, but on our own, in order to capture a good set of reference curves, both in ballast as well as in laden condition. We applied for the certification of EEXI with manual SAPOLI solution. And at the same time, we initiated the CFD modeling and calculations of ESDs in an effort to reduce further the impact of EPL, work which is currently in progress. Unfortunately, on this case, we could not show the benefit and take advantage of the benefit of the paints, but only the hydrodynamic appendages. On the LR1s, we did practically the same, except that the vessels were marginally compliant with their as-built EEDI. So we initiated the recalculation of the EEDI in order to see if there is room for reduction, and therefore that would make the vessels compliant. This proved possible, and it was accepted by vessels class. And the same thing we have done on our Kamsarmax vessels as well. So no engine power limitation on this. And finally, energy-saving devices were installed during dry dock in order to improve overall vessels efficiency. With regard to the CIIs, and after having applied all the before-mentioned energy-saving devices, we established performance curves, having installed first torque meters, power meters, and performance monitoring system with the ability of machine learning, as it was mentioned before. We interfaced the performance monitoring system with the ERP in order to get the timestamps of each voyage, since most of the performance monitoring system are calculating based on calendar and not based on timestamps. We enhanced the sensors and the accuracy of flow meters. We interfaced the ERP noon reporting system with the class, the verifier cloud platform, in order to have a direct interface with the RO that we use for MRV and CIIs. So this was actually a two-way authentication and validation process for the data reported, which is a great struggle. I mean, there is a lot of inaccuracy in the data reported, we have still not gained the confidence that we would like to have on direct without human interface reporting. So this is a work that is currently in progress. Then we have the ability to revise our TC speed consumption curves, which were communicated to our commercial operators, making the vessel more commercially attractive. We enhanced our slow steaming pattern with ultra-low speeds, having, of course, taken all necessary preventive maintenance measures. Daily reports acquired from the performance monitoring system without human interface were fed back to the vessels in order to cross-check all the data reported manually by them for cross-reference. We produce weekly voyage and whatever performance results may be produced, while the new feature is that the Verifier Cloud platform will have the ability, based on the API that we mentioned before, to issue voyage reports that will be used for consumption, CIIs, EU ETS, etc. So what we did, performance did improve. We are recording a plus 10% improvement for both Suezmax and LR1s compared to the average of 5-yearly performance pre-dry dock. The new performance curves practically step on the as-built sea trials and model test after, of course, having the necessary normalizations. CII remains a problem since it falls beyond our control. We cannot control the commercial operation of the vessel. The terminals and the charterers' tuning seems difficult, at least, and we still experience delays in ports and higher speeds than what is necessary to reach the port. So in our case, the deadweight played a significant role since we have 165K Suezmaxes instead of the standard 159, which is beneficial. And we finally expect to see an honest effort from regulators in order to correct the CII, 2026 onwards, I suggest, in order to reflect a better performance of the vessel, not penalizing the short ballast trading. And of course, we are not done. We have to start thinking what we will do at the 15 years dry dock period, looking then which will be the available solutions. That's a small example of the Suezmax, where we see with the green line what is the performance now compared to the sea trials. Actually, we see that at lower speeds, the performance is worse compared to the higher speeds. This is indicative, just to give you an example. Yes. So some considerations in brief. We actually feel that we did the due diligence to comply with regulations. And overall, we managed to improve vessels efficiency, which is on the right side, considering the essence of the regulation. We feel that there will be mid-term or long-term consolidation of the fleet, since significant funds were required to do all this upgrade, and we still have to invest in the future in order to cope up with drastically reducing targets. Of course, there is a concern that there should be transparent mechanisms to lead the green funds that will be generated by the shipping industry back to the shipping industry, and avoid any effect, negative effect on the commodities prices. And finally, we see today the result, some indications at least, of the greenhouse gas effect, which should alarm everyone and not just the shipping industry. More broadly, what will be the next liquid cargo or fuels that would take us to the next tanker era? I don't have the answer. In order to achieve a net zero, we should engage in behavioral changes, decarbonizing our mentality in living, traveling, and shopping. And the fact that seaborne trade remains inelastic, so we should keep our focus on how to keep it sustainable, not only for the shipping owners and operators, but for everyone. Positive closing, we remain optimistic, we work hard, we remain optimistic, even if things get really challenging. We maintain positive thinking, and remember that everything happens for a good reason. Thank you.
Thank you, Foti. I would like to invite Mr. Psilakis. I would like to invite Mr. Psilakis, General Manager Technical, Columbia Sea Management Greece, to present the commercial and financial impact to operators from EU ETS and Fuel EU Maritime Regulation.
Hello. Hello, everybody. Thank you very much for hosting us today. Basically, I just realized that I have prepared a huge presentation, so I will try to rush things a bit. I won't spend too much time talking about EU ETS. My guess is that you are all familiar what EU ETS is and what we have to do. Basically, we will all pay for it, so this is the only thing that you shall worry about. How we will pay? We will pay the 50% for all voyages from to Europe and the 100% for all emissions for voyages between EU ports. This is how we are going to pay. When we will pay? Well, we will pay the 40% of applicable emissions during 2015 for all emissions that we have emitted through 2024. This will take place using the MRV data. The 70% during 2026, and this is applicable for the emission emitted during 2025, and the 100% from 2026 onwards. So this is how we will pay for the emissions according to current requirements. The price is, the average is close to 90 euro now, if I recall correctly. Another regulation that will for sure affect our business is the Fuel EU Maritime, and this because basically this regulation restricts the use of food crop feedstocks, which will affect the biofuels. That's why I'm mentioning it. The impacts we have discussed thoroughly today, what will be the impacts of the EU ETS. Basically, for the ship owners, the major impact will be the operating expenses, the capital expenses that they will have to bear either for investing on their ships or for paying the taxes having to do with the emissions. So this is basically the impact for the ship owners. Now, there is also the impact for the society, greener environment, and all these things, but my guess is that we are mainly interested for what we have to do as a shipping community. As the panelists before me said, there are a lot of countermeasures that can be applied in order to overcome, to save, let's say, and to improve the efficiency of your vessels and to save fuel and subsequently save taxes. There are alternative fuels, there are upgrades that you can perform, there are scrubbers, decarbonization units, energy-saving devices, performance monitoring, leg analysis, route optimization. There is the cold ironing, shaft generators, power take-in, power take-out, waste heat recovery systems, slow steaming. A lot of people are talking about slow steaming. When it comes to slow steaming, yes, it will assist, but that depends on the type of the vessel, the mobilization of the fleet, the trading pattern for the vessel. So slow steaming, basically, it's something that it is a measure that will assist, but it's not the only thing that we can do in order to improve the efficiency of our vessels. We need to do more than that, basically. And to my opinion, there are quick solutions, low investments, and midterm solutions, relatively low investments. For everything there is payback. We have done everything. We have installed VFDs, MEVIS ducts, full blasting, silicon paints, whatever, flattened rotors, whatever you want, name it. There is payback for everything. You will save money for everything. Don't expect a quick turnaround. Don't expect that the charterers will pay, they will revise the charter party terms in order to, in a way, reimburse you for the expenses that you have made during the dry docks, but still you will have payback from the fuel that you will save from the charter party rates with further negotiations with the charters and things like that. So for sure there are things that you can do in order to improve the efficiency of the existing fleet, and there are a lot of solutions currently for the new building vessels. We are talking for EDI phase 3 currently, so EDI phase 3 basically is 30% reduction. So with an EDI phase 3 vessel and improvements like the ones we mentioned, I think it's easy to overcome all these requirements for the next 10 years at least. I don't see any issue basically for the next 10 years. There are, I have discussed thoroughly with various charters having to do with how they see things. There are basically 4 types of vessels: container vessels, LPGs, LNGs, bulk carriers, and tanker vessels. For the container vessels, they have already announced the EU taxation will be, per boxes. Maersk, they have already, if you go to their site, they have already announced how much it will cost depending on the trading pattern per box, the taxation. For the LPG, LNG vessels, we are talking for time charter vessels. We don't see any issues there. Same also for the bulk carriers. The majority of the bulk carriers, they are time chartered, so it's easy for them to reimburse owners against the MRV data. The issue we see is with the tanker vessels, and there we have 2 schools. We have people, we have charterers that they want basically to pay against the freight rates, the taxation having to do with the EU. This means that at the end of the voyage, they will pay in cash the taxation, and there are, for the time charter vessels, they are considering transferring EUAs to the maritime operator or holding company. Both are on the table. You have to be careful what you are doing. You have to take care of your contracts. There are conflicts and issues having to do with the EU ETS. It's not clear. They are not telling us how to implement and how to draft, how to apply all these changes when it comes to the contractual stage. They are not, the EU ETS is basically a regulation having to do with the EU, while all contracts are made, well, when it comes to the shipping industry, are governed by the English law, so there will be an issue because with the Brexit, we will have a problem. And basically, for the EU, the responsibility liaise with the ship owner, which is, again, an issue for us. This is the Exxon suggested clause they've sent us yesterday for the time charter vessels. The only reason why I'm presenting this to you is because you need to pay attention to F and G. This is how they think they will pay the taxes having to do with the emissions. Be very cautious because they demand the data to be submitted to them, to be evaluated, to be verified, and to be included into the next month's higher statement. This means we are talking for about 60 to 70 days of delays when we have fluctuations at the price of the EUA. We are talking for stock market here. So you can lose a lot of money if you wait for 2 months to... Or you can make some money, correct. But that depends. That depends. So be careful what you are negotiating. Be careful, take care of your contracts, because you can make money, but you can lose also money. And honestly, when it comes to the shipping industry, we are the 3% of the emissions worldwide. It's not such a big number. We are talking only for 3%, but still we need to do something about it. The way I see it, go for the easy money, collaboration, talk to your clients, talk to your customers. It's not easy because we are talking for just-in-time arrival and things like that. But our industry is very complex. We have shippers, receivers, charterers, ship owners. We have a bunch of people trying, to load the vessel, to deliver cargo, and it's not easy for us to communicate with everyone in order to, it's a bit of a utopia. We are trying to do so. We are trying hard to do so, and Stamatis is telling me that it's only 1 minute and he will kill me. But again, as I said, go for the easy money. Be careful with your contracts. It's very important for you because now the charters are pressing us to implement the UETS clauses. So be very careful what you are going to do. Try to leave room for the future. Try to leave room in order to negotiate your contracts. You can do that down the road. And go for the easy money. And above all, something that I want to tell you, and we have seen great benefits and results out of it, monitor your vessels. Monitor your vessels. You need to monitor your vessels. You need to know what your vessels are doing. And you need to train your people to operate your vessels to the maximum of their capability. This is very important. So training, monitoring, and proper operation, it's things that will assist in saving money day one. Stamati? Thank you.
Thank you, Stelio. I would like to invite Mr. Skevis, General Manager of Kleos, to provide the changing regulatory landscape as a catalyst for technological advancements in shipping. 10 minutes.
Okay, hello. Thank you, Stamatis. Thank you, Natasha. Thanks, everybody. Okay, it works. Perfect. Okay, so let me first give you a very brief introduction of who we are and what we do. And so we are a joint, I like to refer to ourselves as startup. We're a very new company. It's a joint collaboration between Drylog, Gaslog, and Olympic Shipping. And what we do, again, I like to refer to ourselves as an R&D and innovation center. So what we try to do is not simple, is it here? Yes. Evaluation of technologies. I don't like the word decarbonization as such. Okay, first of all, it's energy efficiency and how to make things better. And then decarbonization will follow. But of course, we also need to follow the regulations. That will be the next slide. So this evaluation, and one is evaluation. So where we are now, what are the technologies, how we're going to integrate these technologies. And to integrate these technologies, we focus on two main tools. Okay, the first one is modeling and simulation. physics-based models, integrating data, and as the previous speaker mentioned, it's very important that we measure everything and we integrate everything. Okay, so vessel performance, operating parameters, whatever. And also combine this with physics-based model for the engine, the vessel modeling, okay? Together with lower, as we say, lower order models for machinery, like fuel cells, like carbon capture, like waste heat recovery, that can give us the full picture upon which technology can be evaluated. And the final thing we do, which I think is even most important, is pilot and demonstration projects. We collaborate closely with leading research institutions, mainly in Greece, but also abroad, to actually put new technologies, appropriate technologies, on board. Now, you've seen this a lot today, or at least you heard about it, and I have to commend for the excellent presentation here. But I will not spend too much time. I would like to mention, first of all, to point out three things. As has been said today, we're at point zero. We have not started decarbonizing, which is good and bad. Of course, it's obviously bad, but the good thing is that we are in the position of being able to draw a strategy based on solid principles. And that's also one of the things that Klaus is trying to do. The second thing is, of course, you hear a lot about technologies being ready, etc. Nothing is ready. Okay, all the technologies are under development, some at very early stage, some at medium stage, etc. So again, it's a big arena. And the third thing is that we need evaluation tools. We need ways of disentangling all this information that's floating around, and sometimes we have problems of seeing exactly what it means. Okay, now let's go to the facts. The fact is that it's a bit complicated, just the shape is important, all right? So we need a gradual decarbonization strategy up to 2030, and then a very steep way forward. But the key words here are what I refer as absolute GHG emissions and well-to-wake basis. So the key with the new regulation is that we're looking to reduce the absolute greenhouse gas emissions. And this means that operational measures, efficiency measures are okay, but cannot take you to this big slope. And what can take you there is alternative fuels and, for what I believe, onboard carbon capture and storage. Okay? Now, the other thing is that given A, the nature of the regulations, and B, the onboard whatever energy system and operating profiles, these changes have to be flexible and gradual. We have to be able to adjust, use technologies that can be, that their effect on decarbonization can be adjusted possibly at will. Okay, let me go into some more details and talk a little bit about fuel, first of all. Now, again, you've seen this, probably you've seen this, or Theodoris mentioned, without showing the graph, mentioned some of the values. These are results of a life cycle analysis on the carbon intensity, well-to-wake greenhouse gas emissions. And as some people mentioned here now, that's the important thing because the production comes into place. Now, again, some misconceptions. As you can see here on the right, this is the carbon intensity of LNG. It's exactly the same, even higher than MGO. LNG is a dirty fuel. It's not an alternative fuel. Okay, it's clean and nice because it's not black and thick, okay? But it emits more CO2 it may emit more CO2. Now, this is just a simplification. There are even more detailed, this is an in-house analysis. There are more detailed analyses. ABS has a more detailed analysis, DOE has more detailed analysis. But the key is that if we want to follow the trajectory, then we have to do what? Move away, of course, from fossil fuels. Ammonia stands out there, you can see that, and this is the gray ammonia, okay? I'm not implying anything here, just showing the facts. And to really go to renewable fuels, we have to go to things like 10, 15, that's ground 32 per megajoule, and this can only be achieved by biofuels or waste to oil or things like that, or even, as this negative line shows, more exotic things like renewable hydrogen plus direct air captured CO2. Now, the magic word here is around 30, and this has to be accomplished fairly soon. And we have done a small example to show what will happen. We take one of our vessels. This is the Olympic fighter. Okay, this is a Suez Max, and what we have calculated is what is the CII based on a well to wake basis. That's 3.3 currently. 2.8 is the well tank to wake basis. Okay, and if we put a 30% renewable, okay, diesel that's coming from waste, that's what's sometimes called as HVO, it's very similar to SAF of the aviation, then we can go to 25% reduction. That's very similar to what Stavros said about 17-18% reduction with the non-renewable biodiesel. So, and these are fueled. Now, of course, here comes the question, where do I find these? What are the prices? Okay, of course, these are legitimate questions, and we can discuss for many, many hours until Stamatis kills everybody in the room. And, but the key is that the science tells us that we can go a long way with renewable drop-in biofuels that do not require any change in the engine or the fuel delivery system. Okay, how about the rest? And of course, this can go further down if we go to lower carbon intensity fuels. What's next? Well, carbon capture. Again, you've seen some presentations about carbon capture. The question for carbon capture is a very interesting and promising technology. There are two problems with it. First of all, it's been developed for land-based applications where you have essentially no size limitation, okay? And also no storage limitation. So solutions like this one which you have seen before, and also, as I mentioned in the beginning, nothing is working perfectly at the moment, or nothing is working at all at the moment. Okay, so the conventional, sometimes refer people as amines, it's not amines, it's chemical absorption, desorption technology, is mature for, say, a cement plant or for a thermal power plant, but to introduce it into onboard has two big problems. First of all, it's bulky. Okay, you have 3 scrubbers instead of 1. And the second one, I'm not taking energy issues into account. And the second one, by the way it is developed, it operates, it can be optimized only for a narrow range of carbon capture rate. Remember what I said in the beginning, we need gradual, modular things. We need to be able to adjust and adapt. So I think this is the way that it is now developed, or if it's taken directly from land, then it's not an optimum solution. You have other solutions that are relatively mature, like calcium looping, that work almost exclusively for land, although there is an example I will show in the next slide for onboard application. And then we're moving to technologies that are more promising, that are modular, that are have much less energy requirements and higher efficiency, and are membrane-based. I'm not going to go into detail now because I think I have 2 or 3 minutes left. So I'll just go to the next slide. That was just a slide to show you an overview of what we can have in terms of technologies that all have advantages and disadvantages, but we need to closely evaluate them. So part of the evaluation is just, I have here some technologies that, some rather demonstration projects floating around. 1 minute. Okay, so I will skip that. We can discuss about this later. But what you can see is that we have started, for example, here is the Everlong project, for example, that they have now, as we speak, there's an LNG carrier crossing the Atlantic with absorption desorption system, and there have been also studies of calcium looping with big problems. Last slide. I won't speak, no time to speak about storage, but so I will just give you what I believe is the way forward. First of all, phase 1, vessel efficiency, operational optimization, performance monitoring, data, digitalization. There are many ways to refer to the same thing. They can give you some advantage. First of all, they can make you understand what is the system that you're dealing with, but they are of limited value, particularly when we're talking about greenhouse gas emissions. Phase 2, alternative fuels, and these phases are not strictly on chronological order, okay? So alternative fuels focusing on drop-in biofuels. And when I say bio, I also include non-bio, say waste-based, whatever. Okay, of course, here the $1 is probably an exaggeration, it should be more. But again, we take this as a second stage. And the other one is carbon capture, where we have a modular system that we can actually increase whatever the needs are, couple it with alternative fuels. And this can go through vessel optimization and vessel energy system optimization. It can go a very long way. Okay, thank you very much. Thank you.
Thank you, George. And now I would like to invite Mr. Hadjigeorgiou, Managing Director of Almi Marine, to present the design for the future.
Good afternoon, everybody. Natasha, Stavro, and Stamati, thank you very much for the invitation. I want, at this stage, you have the benefit of two things. Either you have heard everybody and learned a lot of very useful and very important stuff today, or you're happily asleep. I will opt for the first one. Having said that, I want to share with you the bottom line of what we heard today, or one of the bottom lines, and that there is one thing that we know for sure, and this thing that we know for sure is that we do not know what the fuel that will be prevailing in 2050 will be. Having said that, I think that I'm trying to contemplate what we should do about it, and I wanted to think out of the box. And thinking out of the box meant going back to my start of my career and having colleagues here that were discussing about in conversion of T2 tankers in Scaramanga yard. At that time, tankers were, let's say, sort of obsolete. There was a need for bulkers. So what this shipyard did was to take a tanker, cut it up, remove the old aft end, build a new parallel middle body or parallel body or a new bulk carrier, weld it up to the engine room section, and then combine it with the forend of the tanker and create a new ship. This is a fantastic transformation of a tanker into a bulk carrier. And I think this transformation could be or should be the key for the future of our industry. How is that? Today we're being faced with a situation that, as you can see here, we have urgency to act. There is a real development and social pressure that shipping decarbonizes quickly. And also we have to be seen to be decarbonizing quickly. We're being faced with a lack of focus. Everybody, having heard all the learned speakers today, will easily realize that. There is a lack of established alternative fuels, as I said in my introduction. And whatever we decide, or whatever will be decided at the end, it will take, first of all, massive investment, but it will take time so that we have an infrastructure that will be capable of supporting the whatever technology is eventually chosen. Having said that, where do we stand today? And what is, let's say, the off-the-shelf or out-of-the-box solution? My proposal is that, first of all, we design and build chips that consume less power. This has been covered by many people before in today. The other part is to have chips that are designed to be transformable. What I mean transformable is the key to that. And I have been prompted by this conversion of the T2 tankers to go for the future. The proposal is that ships are to be designed and built as electrical ships, with electrical propulsion, with an azipod propeller that will make the shaft line obsolete, the rudder obsolete. All the aft end of the ship will be designed around, let's say, the azipod propeller, and will not have to accept the constraints of a shaft line. That's one. The second part, which is equally or even more important, is that the ships will be built with a modular, self-contained, replaceable power generation and fuel storage module. This is the key to the whole concept. This module will contain all the fuel and the machinery that will transform whatever fuel is chosen at any different time into electricity. Therefore, you will only have to change that module and have a brand new ship to comply with any regulation in hand at that time. To do that, to make this transition even easier, you will have the accommodation block either be raised above the main deck or have like something like a cofferdam between the main deck and this module so that the change can be done even in a much easier way. These ships will be able, of course, to be connected to shore power very easily because it will be an electric ship and shore power will be able to be supplied at any point in time. I also think and propose that the range of the new ships is greatly reduced. Ships were being built with a 20,000 nautical mile range for no reason. They just had too many double bottom tanks and they didn't know what to do with them. That could be adjusted. Someone could ask what is, let's say, the difference between this proposal and current dual fuel designs. My answer is everything, and the reason being that the dual fuel designs of today do not take into account the possibility to change into a third, another fuel, another concept, another idea. Constructing a ship carries a huge emissions footprint. So if, as the previous speakers were discussing earlier on, we can enhance the life of the ship, and instead of making it, let's say, 10 years, we take it to 20 or 30 years, this by itself is a huge saving for the planet. Banks, I'm quite sure, and financiers would love this concept because out of, let's say, X amount, $100 million ship, maybe with a fraction of this of this cost, you could give a life extension or life renewal for a ship in the future. This is my concept, and the aim has been basically to provoke discussion. It is not an all-covered everything solution, but it's something that I would like to put forward to our learned guests here and listen to their opinion. This is a current design of a ship. This is the concept that I have been talking about. And this is from the T2 conversion at Hellenic shipyards. Thank you very much.
Thank you very much, Christo. Very time-efficient presentation and very interesting. So although we are a little behind the schedule, I think we will be able to take two questions, a couple of questions. So I don't know if there is anything that you would like to ask our panelists. I will start with a question, and maybe you can submit your questions as well. So also in the previous panel, we discussed a lot of all these new technologies and alternative fuels. I would like to have the view from the operator's side, but also from class perspective about what will be considered these low-hanging fruits that we should look first, that we expect to have a fast return of the investment. Stelios mentioned earlier about easy money. So I would like to get your views on this, what we can do now fast to improve our, let's say, rating and reduce our emissions. And also, I would like to have their view also for the future about how they see all these different fuels as an operator and looking into their fuel strategy for the future, which fuels they believe they would possibly be implemented, and also their views on the carbon capture storage as technology, whether they see that this could actually implement it. So any of the panelists that would like to start?
With regard to the low-hanging fruits, I mean, everybody knows that solutions such as ducts, PBCF, paints, VFDs, and the all commercially available solutions have a return on investment. We look to approximately 3 years in the investments that we have done, and a net benefit in the end of the 5th year of approximately 3 to 4%, because the benefit you get from the paints will gradually deplete. So you can consider that 3 years return of investment, it is sensible and it is achievable.
About your future perspective?
I would ask Theo to say.
Theo is the youngest one here, so he should reply.
Okay. Starting with the low-hanging fruit, I would say that the best and zero capex solution is do your emissions reporting correctly. And honestly, I'm saying that because as a verifier, we have seen that more than 50% of the reported DCS and MRV data have mistakes, which can lead to either a big deficit in CII or now with MRV converted to EUAs, it would be a pain. Anyway, for more mid-term and long-term solutions in terms of alternative fuels, for the sake of good order, we are fuel agnostic, of course, but I would like to say a few things about LNG as fuel. LNG does have
a pathway towards zero. LNG currently on low methane slip mode, meaning on the ME-GI engines, is much better than all the other fossils. Of course, there are issues with the DFDs and the low-pressure engines, but manufacturers are working on methane abatement technologies, and there are many initiatives in the industry about reducing methane. And about the fuel of the future and what will happen, I don't think that anyone has an answer. It depends on the company strategy, the investment plan. And it may seem that many compliance options with exotic fuels that seem really fantastic in terms of getting you to zero may actually don't make any sense in terms of investment purposes and net present value. Thank you, Stamati. Thank you, Fotia. Thank you, Theo. I don't know if there's any other question or...
Can I add something?
Yes, George.
Go ahead. So I Googled Greek energy power mix just now. Gas is, LNG is 37.3%, wind is 20.71%, solar is 12.62%, coal 10.41%, hydro 9.02%, and fossil fuels, i.e. oil, only 8.98%. We talked before about harmonizing what we do with the shore industry. We cannot ignore LNG and there are other countries with higher power generation percentage with gas. I don't know.
Good point, but I understand George would like to comment on this.
Yes, three things. First of all, as Sodoi said, the most important thing, and I don't know if I can give numbers to that, is know your vessel, do a full performance analysis, use all the digital tools that are very common in industries like the automotive industry, but have not made inroads into the shipping industry yet. So I think there will be, and of course, follow the guidelines imposed from the from this simulation activities, all these digital twins we're talking about, and fancy words. It means that have produced data, have faith in data, i.e. produce accurate data, and then use this data to probably optimize is a strong word, but at least know your vessel and the energy flows, etc. So I couldn't give a number, of course, to that yet. Now, coming to the fuel, I never said that LNG is not, it's a bad fuel, okay? And but it's if you're looking at one number, and this is CO2 emissions or the GHG emissions, and we're looking up current current engine technologies, then it's not very dissimilar. If the goal is to go to net zero by 2050, then we need to look at other fuels. But the problem is, as I said, I would leave the non-rosy picture for the discussion. Of course, the fuel availability, the fuel pricing is not controlled by the industry. And as correctly mentioned, the industry is only 3%, and also has not received the subsidies that the other industries have received. So it's struggling by itself, trying to acquire fuels that the price is will be controlled by somebody else, and having no access to the value chain. Okay, so I think this is probably the keys for which fuel. Okay, I don't have the answer, and people will say, okay, you're talking to general here, but that's the way it is. And I don't know how many fuels, how many types of fuels can survive. Now we have 2 or 3, right? I don't think we should go for a single fuel. There's no point in going for a single molecule, to put it that way. The third thing is about carbon capture. And I don't know if Don is still with us here, but I didn't mention pre-combustion capture. I only mentioned post-combustion capture. Pre-combustion capture, which is not exactly capture, but it's a way of moving probably into a single fuel, may be a possibility, but this is a bit more complicated. I like the idea, but it just builds a chemical plant on board ship. Okay, but this is something worth pursuing. Now, about carbon capture, we're limited. I think it's a powerful technology. As a technology, which is separation, is a fairly straightforward chemical engineering process. Okay, so it just needs to be optimized, etc., for the maritime environment. There are two problems there. One is the energetics, and this is why I'm a bit disfavor of the conventional, say, amine, in many quotation marks, technologies, because they're very energy intensive. So one thing is to reduce this energy requirement. There are 2 or 3 ways to do that. The second thing, though, is the most important, is what do we do with the thing? Okay, do we, again, it's a question of the shipping industry is not an island, but it's interconnected and sometimes disfavorably interconnected with what happens on land. Okay. So for practical solution, I said, as I mentioned in my last slide, I would go for a gradual in-way of increase of the alternative fuel cell, whatever that means, and drop in fuel and then coupled with carbon capture. And final thing, I cannot reveal the information because I'm evaluating this technology for a third party, for the EU. But the new combustion technologies that are more fuel flexible, for example. What I'm saying is now we're in 2023. Keep in mind how the engine and combustion and propulsion situation was 30 years ago. And then probably as time accelerates, you may have changes in 30 years from now that we do not know yet. So it's important to keep minds open.
Okay. So thank you, George. And with these comments, we are going to close. Yes, you have a question? Yes, sir. One last one. It's okay.
Thank you. I'd like to ask George Skevis this question. The well-to-wake figures that you have presented, are these figures taken into consideration by IMO or EU at all, or are these theoretical figures only for this presentation? Because it's very interesting for me to see to what extent this information is taken into serious consideration. And on this basis, of course, as we move to the future, this is going to be more and more important because people will increase their awareness at that level. And also I would like to mention Christos's presentation that the energy and the emissions produced at the building of the ship should also be taken into consideration because there's a vast amount of emissions building a new ship. Thank you.
Okay, may I start? Yes. Thank you for it. It's very nice question and has three answers, to put it that way. First of all, on the question whether these data are theoretical or solid values. They're solid values. They're theoretical in the sense they are not measured, okay, but they are solid in terms that this is a methodology that takes into account all the emissions per process. Huh?
Are they taken into account?
That's the second question. There are tools that are, how to say, approved. They're taken in. Yes, the short answer is yes. I don't know the formalism. Stamatis and others will know better, but yes, they're taken into account. It's not an academic exercise. And the third thing is that I just showed you a snapshot. If you see more complicated figures like the one produced by ABS or the one produced by DOE in the States, life cycle means that every part of the process is taken, gives a little bit to the CO2 emission. So, for example, if you have a fuel produced by 1, 2, 3, 4, 5 X sources, then you have X different numbers. And these numbers can be grouped. You can have a rough idea but the devil is in the details. So yes, they're real numbers, they're solid numbers. Yes, they're taken into account. And the other is not yes or no. It's every process, every situation, it's well to wake, right? So it's not only the production, it's also the combustion. And there also goes the carbon capture, either as a production step or as a combustion step. So it's more complicated, but at least it gives us a guideline, which is a solid guideline. I don't know if I answer your question, but yeah.
Maybe I could comment on this because we have seen the values from the European Commission through the EU Fuel Maritime Regulation. We have also their limits as well and the penalties and how we're going to calculate the penalties. So there we have a different picture depending on the engine you burn the LNG. So if you burn it in a low methane slip engine, it has been mentioned previously by Theo, then you have well-to-wake emissions in the terms of 76 grams CO2. Yes, this is about the well-to-wake emissions, yes, or everything. This includes... Yes, we measure the equivalent CO2 emissions. So actually, we calculate the CO2 that are being produced during the... Yes.
It was referred to as...
CO2 equivalent is what we have produced during burning of methane, but also we calculate the CO2 equivalent through the fugitive methane, and we're using the global warming potential of 28 currently. This is what we have to use. Yes, 100 years. So it depends on the engine. I mean, the graph we saw there, we understand it's related to the low pressure medium speed engine, which has quite significant methane slip. While we see, and also considering the limits that have been imposed by European Commission into the Fuel EU Maritime Regulation, we see that burning LNG in a low pressure, in a high pressure engine, and low methane emissions could be compliant up to 2040. And this is actually what raised, concerns, objections from environmental organizations in Europe, how we can consider fossil LNG as a compliant fuel up to 2040 that you will not have to pay penalties. We see also, for example, all the conventional fuels, they have around 92 grams CO2 per megajoule well-to-wake emissions. While, the LNG, if you burn it in this high-pressure engine, it's around 76, which is quite below. If you burn it in the low-pressure two-stroke engine, it's around 84. And if you burn it in these four-stroke engines, it's quite similar with the typical conventional fuels and engines. So we see, and we know that there was a big fight there between the Parliament and the Council where they're going to place the limits. And also there was a discussion about the well-to-tank part, not the well-to-wake, but about the default values that we are going to use on the well-to-tank part. And actually this part now is 18.5 grams CO2 per megajoule for LNG, while for MGO are well below, are around 12 grams CO2. But there are, majors that they say that they have said to us that they are able to produce LNG on much lower well-to-tank emissions, almost half of this number, around 9.5, 10. So this will give an additional benefit for the fossil LNG, but European Commission, and I have seen now it is also added in the IMO text, they said that we are not going to consider default values for fossil fuels. We are going to consider only default values and not certified values. So even a major is able to certify LNG at 9 grams or 10 grams CO2 per megajoule well to tank, we as operators will not be able to use it. Only for fossil fuels, we'll need to use the default values. But for non-fossil, then, and now IMO is developing the certification guidelines into the life cycle guidelines, but also European Commission has similar within the RED II directive about how we are going to certify these non-fossil fuels and use the default values. And they're also working on, procedures about how we are going to certify the methane slip, because there is an option there. It has been mentioned previously by Theo that vendors, manufacturers are working on developing, reducing their methane emissions within their engines with after-treatment technologies maybe or other ways. So now we are going to have also guidelines about how we are going to certify and have new methane slip certified values instead of using the default values. So we're a little, I don't know, there's one.
I don't think we can go too much technical on that. I think
Yes.
because if I recall correctly, the dividing line between biofuel and fossil fuel is 33, right?
Yes.
So, but I think I agree. Probably I was a bit too harsh on LNG. But the question is that if we are talking about defossilization, whatever we do, even the best available technology on LNG can take us down to 76. Whatever, even a bit less, I don't know, say 76. And there is a consensus, I'm not now pro or against, right? I'm talking about numbers, that the biofuel is 33. So that's my concern.
Good point, thank you. Oh, sorry, there are some more, but I don't know if we have time. Do we have?
Last one.
Last one.
Okay. Green LNG or whatever.
Yes. And there is a plan from Europe, maybe you have heard the REPowerEU plan. It has been voted last few months ago. It's the plan from Europe to disengage from the Russian fossil fuel. And actually this plan is going to cost us an additional 100 billion over the year as EU citizens. But what we're going to have is to increase the production of biomethane by 35 billion cubic meters by the year 2030. So we understand, and this will be injected also in the existing grid. So we understand that biomethane will be at least available in Europe. We don't know in other areas. I think we can close.
Yeah, I believe so.
Okay, so I would like
Just
to say,
if you want to say a word about what is the financial effect of using LNG according to the EU fuel. And grouping the ships together, it's a huge advantage from what I understand. I mean, if you have one DF Aframax, for example, you can zero your whatever, you can offset whatever you owe to for 4 ships, 4 conventional fuel Aframaxes.
Yes.
Approximately, I mean, it's not.
Yes, exactly. It depends on your consumption. We have seen this already. We do some calculations on a fleet basis, and this will be, the option that you will have through the fuel EU maritime regulation. You can pull the ships, and you can use the allowances because of this difference in terms of the emissions when you use LNG, to compensate other ships that will be above the limits. And as I mentioned, this could be compliant and pay no penalty almost until 2040. So I think we can end now.
So,
yes.
so you don't have to answer. Sulis Panagiotis from Chagos. Don't you think that because the same question is asked again and again, maybe we have to look what the aviation industry is doing?
Yes, good.
Because I think they are moving to biofuel with HVO.
Yes.
They do.
Which is important. It's the largest industry around us.
They do. The problem we have is that, the shipping industry needs about 250 million tons of fossil fuel. And now we understand that the production of biofuels and also with these strict certification requirements will not be enough. And that's why we do not see biofuel as a sustainable fuel considering also what you mentioned, the needs from aviation. But it will be a very good solution if we had the availability of these fuels. The problem, and I don't know, I think we can close. Yeah. We can close. So I would like to thank you all. I think one important, let's say, outcome of this discussion is because we discussed a lot about technologies and new fuels, and I think the most important element is about incentives. Theo mentioned a few things coming from IMO, and this is something that we need to have in mind, is that by 2025, IMO is going to approve the midterm measures, and those measures are going to gather a significant amount of money every year. So even in a very low price of 12.5 US dollars per ton of CO2, this will gather around 10 billions over the year. We're expecting much more. So we understand there will be incentives for ship owners. And this is something that we need to have in mind while considering our strategy for the future.
Your flag state has to agree on incentives.
Yes. We will see how IMO is going to distribute this amount of money. But of course, also European Commission has 20 million of allowances that will go straight to Innovation Fund, where these almost 2 billion every year will go for straight to the maritime sector. So this is something, at least, it's a good news that possibly will be an incentive for us to move forward this decarbonization journey. So thank you all. Wish you a good evening.
So in our panel, we have John Kogias, who is the president of Hellenic Shipbrokers Association and Projects and Finance in Exclusive Shipbrokers. Ms. Angelica Kemene, I think that is the only lady we have in this conference today. She is head of market analyst and intelligence of Optima Shipping Services. Mr. George Souravlas, Chief Executive Officer of Lodline Marine. And Mr. Panagiotis Zafet, Managing Director of BALT Hellas Group. So the difference with the previous panel, you immediately realize that here we do not have this technical expertise, and we will not go into technical details. And also, in this panel, we will not have presentations and the normal, what we have at the end as a question and answer session. We will have a free discussion, and please, during this discussion, if you have any question, raise your hand. Do not expect at the end, jump into this discussion that we have. So we will discuss this market with Market Voice, how Greece will maintain its leading position in global shipping. And when I read the subject of the discussion, the first thing I was thinking is, firstly, whether Greece, and not only Greek shipping, has a leading position in the international shipping now, if this is clear to everybody. And also, do we feel that this has been changed recently? We have seen newspapers saying that China now is #1, and other articles saying, but this is not the actual condition for the international shipping, because this is mainly related to the tonnage and the local transportation. So, starting with Mr. Kogias, who is next to me. And then we move again, and we will discuss this subject extensively. Do you really believe that Greece, if you go now to Singapore and you speak to shipping people, they consider that Greece as a country has something different than other countries in shipping, has something to offer in international shipping?
Pano, thank you very much. Thank you also, I thank the organizers for the privilege of being here and airing our voice in public. I see you also brought a hammer.
Yes, it was Chairman's.
Stavros' idea, and we have a prize to pay also. Bravo. The question of Greek shipping being powerful, being strong, being important, is something that definitely makes us very proud because we live out of this profession. It's our life, it's not our business, it's our life above all, and I think this is what distinguishes Greek shipping from other nations, because we all consider what we do as part of our lives and as our daily network that we intermingle with people in the shipping profession. And I think this is one of the biggest differences because of the quality, because of the know-how, because of the ability to think out of the box. The Greek word patenda sometimes is what makes us distinguish a lot of things because we find solutions, we find adaptability.
But this has something to do with the country.
This has something to do with the nation, with the country, with the Greeks, with the people, exactly. And I think this is very much connected with Greek shipping because shipping has been in the DNA for centuries, since the ancient years. One of the most ecological ships was the trireme. It had dual fuel at the time because it had also sails and it had oars. So it had dual propulsion. And that was pioneering. Definitely, what we can say about the challenge of China, Panos, if I have 1 minute for this, just to present some statistics, because we don't like to be challenged as Greeks. We don't like to be confronted and put in the corner, and we like always to come out of the corner. And I think I'll make it easy for Greece to be, again,
but we will come back
out of that.
Actually, to China.
We can discuss about the figures, which make it clear that we are the leaders. But coming to your question, yes, I think it's in the DNA of Greeks, and that's something that you cannot replace it with other nations.
Then, Mr. Chouravla, do you believe that this is our only feeling, or other countries also have the feeling that we have something special here? If you go to Shanghai and you ask the people involved in shipping, they're going to tell you, yeah, it's something different there, or it's only we have this feeling?
Okay. I believe that shipping is about human resources, the right human resources, the ability to attract talent, the ability to develop talent, the ability to attract people that have got the skills and bring them in and show them how to do the job and do it. So Greece, having a very long and very proud history in shipping, is able to do that. I would like to mention here, however, that the way that you attract talent and the way that you manage talent changes over the years. You have to change with the times, to be contemporary, and to be able to apply different management techniques to the people of this generation, and to be able to have their full resources, to be able to have their full potential. So the motivation mechanism that you have to apply is different to the one we used to have a few decades earlier when Panos and we were young. Thank you.
So is this an opinion which is shared also from Ms. Kemene and Mr. Zafet? Do you think that there is something special? Please, first.
Judy first.
Thank you. Well, I would not agree with what Mr. Chouravla said. I would also add that it's a long heritage and the long ship management, the expertise that we have that adds to all the other nations. And I think that we are very agile and adapting. So these are the only things that I would like to add now.
Mr. Zafet.
Okay. As all the speakers said before, of course, it starts from history, but ancient history is not the only reason. The main reason is the need. Greece was always a poor country, and there was a need for entrepreneurship, and that's why shipping was invented more or less in Greece in order to be able to transport goods around the world, the known world at that time. And a part of this reason, it was a way of discovering new continents for Greeks, and that's how it all started. There onwards, things have changed. Shipping used to be a very unregulated area, which is not the case anymore. And there is the significant change I have seen in the recent years, that we were able to adapt to a more regulated environment. And it's a cause of pride for the Greeks, the position of shipping worldwide.
Would you like to say something? Because I have some different opinions here.
Okay.
So I'm not sure that I fully agree about the past and about the experience and about what we think for ourselves, and that we are proud for what our ancestors have done. But all the recipes in a changing world, I don't know if is actually what we can do. We have AI, we have financial institutions, huge money in the market, regulations, as you say. Do you think that all of this doesn't matter?
Of course it does matter, but that's what I just touched upon by saying that we have been able to adapt. Just remember what happened recently with the change of fuels. And we all thought this was a big mountain, and how are we going to surpass this big mountain? And we did surpass it, and the vessels are trading worldwide. So the times have changed. Definitely, it is not the same time as it used to be, where it used to be the captain owner, and the companies are now, I would say, much more advanced than what they used to be.
Stavros, you had something also to add.
Yes, I think we should not look at absolute numbers at this moment, which are not very well defined, but we should look at the trend. And I'm, let's say, kind of sorry to say that for 2022 until March 2023, the numbers that were released by the Greek Shipping Cooperation Committee, which I believe are valid numbers, showed that the Greek fleet has been reduced by about 45 ships and by about 6 million tons dead weight. Everybody can say that, the Greeks, they sold to the old ships to the Russians or to the Dubai-based establishment, but there is a reduction of the Greek fleet in 2023, and something should be done to reverse this trend. As far as new technology is concerned, I was doing a presentation in Cormarine 2 weeks ago. There are 45 DF ships that have been ordered by Greeks, and this is not corresponding to the 16% of the portion of the Greek fleet in the international fleet. And about trust, because you asked if people know about Greek shipping, if people trust Greek shipping, 30 years ago, the tanker owners were Onassis and Niarchos and maybe Goulandris, the three of them. Prokopiou started in 92, Angelikousis started in 92, and today 24% of the tanker fleet is owned by Greeks. And this means that the majors, i.e. the strong people, trust the Greeks at this moment.
About numbers, you said you have the numbers. He has a different list of numbers. What is going on here?
I have numbers which are updated up to yesterday.
Okay.
So the Greek Shipping Cooperation Committee produces data which is actually done in the beginning of the year.
End of March.
End of March. And since then there have been a lot of new building deliveries for Greeks. There have been a lot of sale and purchase. Greeks have bought a lot of bulkers. They have sold, of course, very correct, Stavros, they have sold 149 tankers and have bought 98 tankers. So there is a little bit of an imbalance there. But in actual fact, we've seen that the Greek fleet has grown. There is a bit of a discrepancy how some calculate the Greek fleet and how people consider Greek control or Greek interests, some of the US-listed companies which are Greek-controlled are not considered Greek companies in the statistics. We have included them all, and we have come up with a figure which says that Greece has 5,700 ships of 395 million deadweight, average age of 10 years, and the average size of the vessel is 81,400 tons, when the world average is 45K. China has 12,000 ships of 360 million deadweight carrying capacity. Their average age is 3.8 years more, 13.8, and their average size is 38,000 deadweight. But what is very important is that China has 2,500 vessels of zero deadweight, majority of which are fishing vessels. So we cannot consider this fleet as a fleet that transports internationally. And also they have more than 3,000 vessels, which are less than 10,000 deadweight tonnage, which are Chinese flagged and CCS classed, which means that these are intra-trade. So we consider that 1 out of 3 Chinese-controlled ships are used for intra-China trade, and therefore we can make an estimation, approximation, that around 6,000 ships of 280 million tons of deadweight capacity are the ones that compete with the Greek strong #1 position fleet. So it follows that the Greek shipping transports a majority of the international and long-distance trade.
Do we agree with the numbers finally?
For me, I didn't bring any numbers, but I have to say that I agree with Mr. Kogias that China, when we're calculating Chinese fleet, we calculate coasters
He's
and smaller
convincing,
vessels.
actually, yes.
No, I just agree because this is my view. And I would add to what he said that Greeks recently started heavy contracting, so we are 10% more in 2023. China and Japan, the previous years, were heavily putting new contracts. Now it's our time. Maybe we're deciding what we like in terms of alternative fuels or no alternative fuels, better ship designs and the traditional engines we have. So I think because the difference is very marginal with China, we are actually first.
We are first in deadweight terms, which is the important.
Yes, exactly.
But still, I have the feeling that there is a tendency. Because with these numbers, we had not this kind of questions 2-3 years ago. So something is changing. I don't know whether our fleet is going smaller or their fleet is going bigger. Please.
Even if we become second, will something change? Will we stop having conferences, stop having Greek shipping as we know it?
Conferences we enjoy, actually.
I know. I mean, will anything change? No. It will just be statistics. And you know, statistics is one of the nicest arts of cooking, as you wish to present data. I presented the data in a nice way because I wanted to present them in this way.
Okay, fine.
So obviously, it's based on data, but it's manipulated in a way that we want it to be manipulated because we're making assumptions. But I'm asking again, even if we are second, an achievement of a nation of 10 million people, comparing with a nation that has a GDP growth of around 4%, exponentially every year, an economy of 1.5 billion people, and we're competing with that. I mean, only this is an achievement, and I think we should stick to that.
Okay. Now, Mr. Suravlas and Mr. Zafet, you have your own fleet, you are ship owners, and you have your own ships there. Do you see any meaning in a national fleet when we are in an international environment like shipping? What is the meaning of a national fleet? I mean, your client, your charterers, you have personal relations with bankers. Do they consider this? Do they consider that your nationality in that terms, your fleet matters? Who will answer first? Please.
Pano, would you like to go first?
Well, I think national fleets are of importance. As Yannis said before, if we are the first or the second fleet in the world, I don't think that is too important at this stage. What is important, however, is the presence in the world trade. It is a fact that nearly 90% of the global trade is being transported by sea. So having such a strong commercial fleet gives the nation the ability to transport goods that are needed, commodities that are needed, to transport oil products, and also strengthen the economy of the country. Greek shipping is a very strong pillar of the Greek economy if you take into consideration that it's not only the people who are involved daily in the running a shipping company, which is approximately 200,000 people all over Greece that are working in the shipping industry, but it's also about other industries such as legal, insurance, makers of marine products, services, and all of these organizations are based on our national fleet. And this is despite the fact that the country has a weakness in providing services. As you can see, most of the institutions providing insurance they're not based in Greece, they are foreign companies. But still, Greek economy is very much dependent on Greek shipping. Actually, Greek shipping amounts for nearly 7.9% of our GDP. It's a huge number by all standards. Even if you take the unbudgeted footprint of the Greek shipping in the Greek economy, it's more than 3.2% versus 0.2% in EU. That's how important shipping is for a nation like Greece.
My question was also about your clients, whether it is important that you are in. And so do they consider that this is an advantage for your fleet being managed by Greece? Or
I think it depends on each and every company and the reputation it makes.
Yeah.
Because, for example, we always pride ourselves that we are doing business with the major companies, the major charters, and that's why we want to have a very well-maintained fleet. Okay. So I think it's very important in terms of how they consider you, but this, you have to prove yourself. And this is a daily exercise, and an exercise that takes a lot of years. You must make a reputation first in order to be trusted by these people. And as we talked before, all the oil majors are trusting right now Greek tanker owners. More than 24% of the tanker owner fleet is Greek.
Mr. Zoravlas?
As far as we're concerned, there is no difference to our counterparts, our charterers, if our fleet is flying the Marshall Islands flag or the Greek flag. So there is no difference there. As far as I can see, Greece is benefiting from shipping, whether it is Greek flagged or Liberian flagged or Malta flagged. So it is, as far as we're concerned, it is Greek shipping, whether it is flying European, Greek, or Marshall Islands or Liberian flag. I would like to add here about the skills and about Greek shipping. It is not only about entrepreneurs. It is also about the other shipping-related individuals that form the Greek shipping miracle. And I'm referring to the technical managers, the superintendents, the lawyers, the operators, the accountants, and all these are part of the captains. All these people are the ones that form the Greek shipping miracle, and it is not only related to the entrepreneurs.
Greece has got a leading role in shipping. Everybody is watching us, how we do it. Everybody in shipping is coming here to Greece and trying to decipher how we do things. It's very important. We're in the pole position if we were at the Grand Prix. It's very, very important. Everybody is watching us and see how we do it. One of the, can I expand a little bit, please?
Yes, please do.
One of the major advantages that we have here in Greece is that we're able to communicate with each other. Today, we have spent here a day, and thank you very much, Natasha, for organizing again this fantastic event. About 700 participants in this. This is the 5th year or 6th year, I don't remember. Sorry? 15th. Okay, 15th year. And you bring here senior and junior shipping personnel, shipping individuals. And I think within one day, we have exchanged here so many views, and there's such a huge amount of information that has been exchanged either by the panelists or the speakers or during lunch and coffees, that it is something amazing. I do not know other countries that have got such conferences or Martecma or other groups that information can flow between the members and enhance the stimulate and enhance the way that we understand the new challenges. And this is very, very important. I would say here in Greece is where everything happens about shipping. I think we should have even a stronger role in IMO, in the European Union, or other fora, and be able to express our views in a much stronger way than we do now. I think we still have a very strong voice, but I think we can go several steps further. I think that the ability that we have to exchange views in the technical fields or in the commercial fields is very, very important, and we do this all the time.
I will go back to what to the numbers and what Stavros Hatzigrigouris said a little bit earlier. He made a comparison of the ships that are ordered as double fuel ships and those that are ordered by Greeks, and I understand that the percentage of the ships ordered by Greeks are the majority conventional, and very few of them are double fuel. So if we are taking the correct decisions always, and if we believe, then the correct path is to go to the conventional fuels for the moment, and the others that they go already for the double fuels are doing wrong decision. Mr. Kogias, what do you think?
A very difficult question. Who is right, who is wrong? I think in 20 years we will know who was wrong and who was right. But right now, the consensus of majority of Greek owners, which we deal daily in our professional, we're sale and purchase brokers, so we feel the pulse and we feel what the concerns are today and what the ambiguities that everybody has to face. Let's start with why somebody orders a new building today. First of all, we had 2 very fantastic years. We talk about the container business. Container companies made more money in 1.5 or 2 years from the accumulated losses and profits of the past 20 years. So this amount of money that was accumulated had to be somehow invested.
So meaning that they have money, so they just
No.
spend the money?
No. container orders, which we saw a tremendous boost, like 70% within a year and a half, were the only way that you can actually bring the very, 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 very hungry in terms of fuel container vessels, which consume more than 200 tons per day at the speeds that they do, the high speeds. So any improvement on a conventional container vessel today as a new building order that has a 20%, a 10% reduction is a serious reduction in terms of fuel consumed and, of course, emissions emitted. So it was the golden chance for the container industry to self-regulate its emissions faster than any other segment. Then we had the extra profits that were accumulated in the dry bulk business before the tanker market started booming. A lot of money was invested in tankers because people expected that the tanker market will go up, and it went up because of the geopolitical issue. After that, we still see that the tanker business is at the healthiest and more sustainable position that it has ever been. It had spikes of 2 months, 3 months, 5 months, but not a fantastic good market of more than a year and a half. And the prediction for the tanker market is that it will be a very good market, at least for a long period of time, more than 1 year or 2 years ahead. And that makes the vision of the Greeks that I can talk about, that we need to invest in newer tonnage, which is the best that technology can give you today.
Newer conventional tonnage.
Majority is conventional, but they don't omit the dual fuel vessels because, as Angelica mentioned, there's a surge of orders, especially in 2023, across all segments, dry, wet, and the mix of the new orders is more in favor of dual fuel now than what it was in 2022 and 2021, because we still have orders that have been placed in 2021 and are going to be delivered in the next 1 or 2 years.
Do you suggest to your clients for dual fuel? And what about you, Ms. Kimena? And you also?
You are out of the subject of your...
No, I'm not out.
I want to add something to what Mr. Koutia said, because I have some statistics about, let's say, the environmental tech update and the global order book.
Okay.
So
we are talking about Greek owners, always.
yes, but I want to, because you're saying that we, I mean, as Greeks, we order conventional fuels, and that's true, but I think globally this is what they do, even if they have 27% of the order book in alternative fuel capable, but we know that this is made, sorry?
Which means zero, alternative
exactly.
fuel capable means
because
zero.
It's LNG, and in terms of alternative fuels ready, this is only 8.2%, again, more, it's LNG and some methanol. For scrubber, I don't know if you care, but it's 12.1%. And what we suggest to our clients at the moment is to build conventional fuels, yes.
With sales or without?
If they can pay for it. Because, you know, the OPEX is more than 8 to 10 years.
Just to remind the floor that we will not have normal question answers. So if you have any question or if you wish to add something, please raise your hand and jump into this. Please, yes.
Can I go back to the issue of the national fleet?
Yes.
According to the Greek Shipping Cooperation Committee again, in March, the number of Greek flag vessels was reduced to below 500 for the first time in I don't know how many years. I don't care about, if it is about OPEX, I don't care what is the decision of individual ship owners. But it is a fact that part of the growth of Greek shipping over the past 20-25 years was because we had Greek officers manning the ships, old ships at that time, and managing to perform. And they are also manning the management offices here in Greece. If we lose them, and we will lose them if there is no national flag available, then what will happen. I don't know. It's a risk.
Mr. Souravlas, Mr. Hadjigrigouris is not very optimistic.
No, it's not
What
about
do you
being
think?
optimistic. It's about looking at a possible problem, a possible risk.
The issue of the seafarers is, the issue of the seafarers is a very important one. There's no doubt about this. And it's very important to be able to train and give the necessary incentives for the Greek skilled people to join Greek shipping. There's no doubt about it, of the importance of this. I would like to add, however, something about decarbonization now. Decarbonization, have to understand that will happen only if the entrepreneur decides that it is a good time to invest a large amount of money to build ships of that consume that can be powered on these fuels that produce fewer CO2 emissions. So the decarbonization has to pass through the decision of the individual entrepreneur that decides to build a ship with alternative fuels. And he has to say that this is something which is going to make sense, financial sense to him.
We'll have also Mr. Zafer opinion, and after something for Mr. Hadjigeorgiou would like to say something.
Well, I think that Stavros touched about a very sensitive issue, an issue of concern that we all have, which is the aging seafarers. The average seafarer now on Greek ships, a Greek seafarer is about in the area of 41 years to 50 years of age, which means that the younger generation is not attracted to work on board vessels. This is despite the fact that even when they are cadets, they can earn some money from the age of 20 or 21 years old, which is much more, I would say, respectable than the money that they could earn in any other business at this age. It is a failure of the country, and and I know that the Union of Greek Ship Owners is trying to address this issue too, how to attract more Greeks to the shipping profession. It is obviously something which is not so easy nowadays, despite the fact that the conditions of living and welfare on board the ships have improved tremendously in the past years.
Yeah, Mr. Hadjigeorgiou. Do you have a microphone? I think in...
I would like to go a bit further to what the gentleman before said regarding the issue of seafarers. And in our company, we employ a Greek captain, chief engineer, and second engineer. We can never find a chief officer. And one critical issue, I think, is that once they graduate from the school and they become either fourth or third engineer or a deck officer, this period, the salary commanded by the market as opposed to the salary commanded by, let's say, other nationalities, has a very great difference, and this is why they cannot really find easily employment in Greek companies. This is at least my feeling. If that bridge until they become more senior ranked could be somehow treated in a better way, then younger people would find an easier career path into shipping, and then the money differential would be so great that they would not want to leave it. That's one.
You are not thinking about increasing the salaries of the foreign seafarers.
Anyway. Okay, the problem with the seafarers is it's real. We all understand that. But anyway, the office, even if seafarers are very important, even for the employment in the office, but the office, I think that we need also people with financial background, with other background, quality. And in this term, I don't think we have any shortage. Instead, we have many people, but and many students actually from universities coming, and very competent also, very good universities and very competent people. But now we are in a changing environment. We have new regulations. If we consider all this changing now, do you think that are beneficial for this traditional Greek shipping, or there are additional challenges? Do you have any benefit of having offices here in Greece? And if we have a benefit, why we don't see German ship owners moving their office here in Greece? Why we don't see Chinese ship owners?
Because they go to Cyprus, the Germans.
There is a disadvantage being here in Greece, or an advantage, considering the challenges. Mr. Zafet, please.
On a tax perspective, we are not the cheapest country. So there are other regulations that offer more incentives in order to attract foreign investment. But this more or less has been something that we know and has changed after the financial crisis the country has faced. And it was agreed, it was a social agreement made that the taxes would be increased for the Greek flag and also for the foreign flags being registered in a Greek ship-owning company. I don't know if you call it Law 89, whatever you call it, but it was more or less a social bond that had to be done because of the difficult times that the Greek economy was facing. That's the answer. We are not the most competitive environment right now.
When I was in Maran, I was doing a benchmarking exercise, comparing about 20 tanker companies, both Greek and foreign, for example, Frontline, that were using third-party managers. I can guarantee to you that the OPEX of the Maran fleet with Greek officers, 5, 6, max 7, not more than 7, were exactly equal to were comparable to the cost of the third-party managers.
Actually, it's not.
And the quality, because we are also benchmarking against port state control, vetting, breakdowns, blah blah. The quality of the Greek fleet was Greek manned fleet was better than the foreign one.
This probably is correct, but I'm not talking about if it's Greek manned or not, the vessel, or the cost, because we know if we are very good at running ships at decent OPEX. The point is the taxation is different, the tax regime from the country.
Yes, but we include in the OPEX everything.
Yes, but usually the personnel in Greece, even though it's considered the shipping personnel to have good salaries, is not as expensive as it is, for example, in Norway or some other countries of the world.
Mr. Kogias, would like to add something about the...
I want to say, of course, that contrary to being able to attract seafarers or not, or being competitive and having the ability to bring out of the sea port captains and technicians and superintendents, and to have the maestro and the captain in the office, which were the backbone some decades ago and still are of companies. That is an issue, of course, and I agree that we're going to be facing that in the future. But as you rightly said, Panos, we're more managers of regulations than managers of ships as we progress. More university professionals needed to handle all this paperwork than experienced people from the sea. But that is one big issue. I don't think that we can find a solution to that. We have identified the problem. We know this problem has been gradually decreasing. Stavros, I agree totally that the ships under Greek flag are diminishing, and that's a big problem. I think when the Greek flag realizes and does some serious action to attract and become a flag of convenience, in terms of convenience and not of cutting corners short, but being a safety and a regulatory flag, that's an issue that goes down to politicians, I think, and not down to us. But let me say something about broking. Greek shipping being number one or number two or whatever in the world definitely has broking to be on par. Shipbroking in chartering and S&P has to follow the quality and the ability of Greek shipping to excel. And this is a fact in Greece. I don't think there's a single foreign company that has not had a rep office, an office in Athens, in Piraeus. All of the major broking companies need to have access to the 20% of the fleet, because this is where the heart beats. This is where all the transactions happen. When we have 60% of the EU-controlled fleet, which I'll give you again a playing with statistics. We have the 80% of bulkers in European tonnage, 73% of tankers, and 85% of LNGs. And the reason we have only 60% is because we are brought down by the 17%, which is the container presence that we have, which is low, always has been low. So having such a big importance in terms of Europe, can you imagine all the European broking firms, how much they want to come to Greece and establish a presence here where the heart beats?
Is this a competition environment for you? And I understand also for you, Miss. Is this a problem, actually, having them next door?
I will speak personally.
Yes, personally.
Yeah. I don't think it's a problem, because broking is about relationships. And we build as Optima strong relationships across all services and all broking departments. So other houses from London, for example, try to compete, and there are ship owners that really trust the London houses, and that's fine. But we still have our clients that really trusts on us, and that's fine.
I would like to speak not as personal opinion, but as a president of the shipbrokers. I'm not representing everybody, but I happen to wear that hat for the past 10 years. It's welcome, more than welcome, because they actually employ, in the Greek offices, our fellow brokers. And they give them experience, and they give them the ability and know-how, and they give them also, I would say, bigger wings sometimes, because they're big firms. Yes, there are competition, of course. It's a competitive world. Nothing is given to you. It's won. You have to win it. So it makes us much better and to be on our toes. So yes, we want this competition.
Mr. Theodosopoulos would like to say something.
Yeah, just a point or a question, if you like, to your point of whether the Greek companies are under challenge with the new regulations of the changing environment and whatever. Personally, I don't think it's a question of being Greek. So it's not a question of they're challenged because they're Greek. They're probably challenged because they're small. So the question really, at least in my eyes, is will we be able to keep that Greek miracle of shipping in the changing environment with complexity of operational and technical level, as well as overhead brought by regulation? Can small companies survive that hurdle? And do we see any potential of consolidation if this is the case? So, you know, it's a question that I'm posing rather than a statement.
Who will answer this next question?
I will answer. Whenever I was asking the late John Angelikousis, telling him we have this problem with new regulations, with new technology, blah, 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 his reply was, don't worry, Stavro, the strongest will prevail.
The strongest? And he
Will
was
prevail.
right.
Mr. Zahati, would you like also? Do you consider that the size is important? Do you consider that the size and the mentality has to be changed to tackle the future challenges?
Well, I think that it has been proven that most of us here have been able to cope with the new challenges. Of course, size does matter. And, consolidation is something that the industry should consider. But being Greeks, that's not so easy.
That's what I'm asking.
Yeah,
I believe as far as the new regulations are concerned, I think that Greece, I'm not making a comment to the smaller companies or to the larger companies, but I'm talking about the Greek ship owners are adaptable. They have the skills, they have the people and the synergies, and they are in the best possible position to take on these challenges and come out and be the winners out of everybody. Of course, the larger companies with more resources are in a better position. There's no doubt about it. But even the smaller ship owners, in comparison to some ship owners in other countries, they're in a very, very good position.
Yes, please.
There's also a major difference in most of the Greek ship-owning companies and ship management companies. They are managing more or less their own tonnage, their own money. This is a huge difference compared to other countries where it's other people's money. So that's possibly the reason why, although the biggest percentage of ownership in Greece is in small and medium companies, they manage so well in such a competitive and cutthroat arena.
Yes, you can introduce something new.
Okay.
But
what
actually,
we have seen recently is that we have quite a few, actually the biggest third-party managers moving into Greece, and at this point they are managing about 500 ships, Greek-owned ships.
Yes, but they are managing fleets and vessels of big companies in a joint venture. There's a difference there.
It's about 200 out of the 500.
Okay. I don't think that still we have
In
too
other
many.
words, we are managing also foreign money, foreign investment. As far as the classification societies are concerned, we have seen that over the years, the head office for Europe or Eastern Mediterranean is in Greece, and the decision-making ability has been moved to Greece for most of the classification societies. This means that they employ Greek talent and Greek skills. The employees are Greek. So, yes, you see, even we're not managing German ships, a lot of the work is done here.
Yes, but we saw a week ago the Turkish registered joining Ajax, and we don't have a national classification society.
I was going to mention...
Think about it and we discuss it next year.
I was going to mention, when we mentioned about the Greek flag, that also the Greek registry belonged to Bulgarian hands a couple of years ago. Crazy, just to think about it. And not a Greek entrepreneur, somebody who knows to take advantage and grow it. But anyway, I want to make a joke just to conclude with a nice tone. In the past, I mean, yes, we have a lot of regulations now. We talk about being managers of regulations and not managers of ships. In the past, the majority of the Greek companies, being family business, were actually run without even an accountant. The bank statement would show if the company is profitable or not. If we had money, we continued. If we didn't have money, we didn't continue. The operations manager was St. Nicholas picture. Sometimes, decisions were taken by St. Nicholas. Να το κάνουμε αυτό. Να το κάνουμε. Decisions were taken, really spontaneously and maybe sometimes without thinking of the consequences. Now we're moving into ESG. There's a Greek interpretation of ESG. Everything seems good. So yes, ESG has been running in our bloods for many, many, many decades. With that mentality, we were moving on to the next problem. Everything seems good. Prohora. Now, but ESG is something that we have to follow. We have to be more compliant. Definitely regulations are here. We need educated people. And definitely we need to bring Greek shipping into the next era.
Okay. So we must finish this conference with a prayer to St. Nicholas.
ESG.
Okay. I don't know if you have something to add, either from the floor, yes, or from the panel. Yes, παρακαλώ, Luca.
Hello, very interesting discussion. I have to, in continuation to Mr. Korzias, what said at the last, I think in Greece we have too much potential. I mean, we have excellent brains, we have dynamic growth of the shipyards now. We have seen a development in zero shipyards, LFCs, and I feel that there will be the same also in the Skalama gas yard. So I think because there are companies, for example, like Erma First and others that invest in these new technologies, we can combinedly make testings of these new technologies in the shipyards, in the Greek shipyards, so we can somehow be dependent from, example, the designs that we had in the past, because most of the owners were building ships in China, copy-paste ships like boxes. Now we have to, how can I say, to be focused on the potential we have in Greece.
Good. So thank you very much. Have some more. Please, yes.
I will move for a few minutes outside the main topic, and I would like, if I may, and I would like to say a few things about the CII. It's not a topic which is not being discussed. It is the center of our business, and CII plays a very important role how we see our fleet moving forward. We see that the CII is seen that it has to be borne by the ship owners. It is the ship's problem and not the charterer's problem. It is something which is, when being discussed at the commercial level, the charterer is saying, okay, this is your problem, I'm not involved in this, I don't want to have anything to do with the CII. Having said that, CII very much depends not only on the efficiency or the lines or the propulsion system of the ship, but how the ship is being utilized, how much cargo you carry, how much, what type of speed you do, and how much time you spend at the port. Charterers exclude themselves from this, of being parts of this discussion, and we are always trying to bring them in. I made earlier a comment about the port efficiency, and the port efficiency is never going to change. The port efficiency is never going to improve unless there is commercial pressure from the charterers, because the charterers are the part, the counterpart of the various ports, because they are the ones that are in agreements with shippers and receivers. So unless charters are involved and under pressure involved in the new charter party agreements, there is not going to be any improvement or streamlining of port operations. I'm sorry, I'm a little bit out of context, but I think it's very important to say that. Thank you.
I think now we can conclude. I wish to thank you very much for staying for so long. I wish to thank also the panelists for the nice speech and nice ideas that they have exchanged here, opinions. And when is the next one? I think the next one will be in Posidonia. It's in June.
It's in June, the 6th of June.
6th of June.
It's Posidonia.
During Posidonia. In the Posidonia premises, okay. So, thank you very much, Natasha, for the organization.
Wait.